I can't right now.
Okay.
Okay.
We should be live in like.
Tanisha, can you try saying something once? Like, then we'll get to know if we can hear you. No, I can just.
I think we should be live now.
Yeah, it's live.
Great.
Can someone write something on the screen? I can just.
Yeah. Yes.
Okay. Should we start with the problems then?
We should.
Yes.
Tanishka, is it working now? Just try again. Or like,
Yeah,
I think you
okay.
can try removing your headphones.
We are live. Yes. Okay.
Uh,
You can start with the problems.
Okay,
Is it working now?
Yes.
Yes.
it is.
Is it
Great.
working?
Yes, it's working. Tanishka, it's working.
Okay, so first we should replace LCM because LCM is trash.
There are 26 integers greater than 1 on the blackboard.
Amazing.
From different place from that.
Regardless of the choice or confuses after finitely many moves, exactly one integer m remains on the blackboard is greater than 1.
Wait, the product is
Look at
The
the
LCM.
product
If we
is
yeah,
non-integer.
LCM
multiply
is
the
like
integers, it's like less than equal to.
Yes.
Product
And
is
if it's
non-integer.
equal to in the
exactly.
case of m equals
This
to
is
n.
like less than equal to, and then this guy
LCM of ML.
LCM by
Is less
GCD
than M.
square. It's like MN by GCD
If-
square, which is not necessary. Which is like strictly greater than.
But
No, wait,
what we
that's
can do is
less than equal to
basically
MN, right?
Sorry?
Yeah, go on.
That's
but
like the
don't
product.
write in the
product-
problem, I guess.
Oh,
Yeah.
no.
What I can't write right now. So what I'm saying is that the product is LCM of Mn, which is less than equal to m times n. So the product is strictly decreasing. Like
Not strictly.
No,
because
Oh yeah,
non-integer.
not strictly.
But
Okay,
what
yeah,
we can do
say not
is
strictly.
the product plus the number of times the number of ones in the board, because if it's
No.
equal, then like
Not number of
GCD of
ones.
m comma n will be one.
Not number
will
of
be
ones,
one.
right?
Number of ones, yes.
No, because we cannot choose ones in this process. So,
Right. No,
Number of
like
things which are not
or
one.
maybe just induct on 2026.
no, number of ones will increase. That's what I'm saying. Number of things which are not ones.
Sure,
Like then
but
GCD of m comma n has to be 1. So
Yeah, if
number
GC
of ones will increase, so number of things which are not 1 will decrease, and the
Oh, that proves the process is finite.
the product will
Right.
the product is equal, so it's like strictly monotonically decreasing. So I think we are done with the A part.
What?
Yeah.
Wait, no.
wait,
Also,
wait.
we need to show m is greater than 1, but that is
No, it
Less
is
than
m and
equal to
m and n is greater than 1. Like that is given in the
yeah,
problem.
Yes.
Like
no, like,
because
the
m
thing
and n
which
are greater
gets
than 1, and
end up
we're
with
getting an integer which is like
But the value
equals
of
to
n
1.
does not
So
depend on the choice of functions.
basically I think this, yeah.
We should be done.
Yeah, this part A
So
is
like product of like what
yes,
AI
and
is
then the
One
product
divided.
will be basically lower if
Yeah.
GCD of m comma n is greater than 1.
Yes, all
Wait,
right.
so the invariant is the product times the number of things which are greater than 1.
Yeah.
Not
Yes.
invariant, monovariant.
The
Monovariant.
monovariant, yes.
Yeah.
Okay, so I think A part is done.
Yes.
Prove that
that
the
was quick.
value of m does not depend on the choice of Confucius. Great.
Okay, wait. I will try with random things.
Yeah.
Just 2, and
Okay.
6.
I'm doing one copy, guys. I'll let you know if I have any progress.
Sure.
Sure.
2, comma. What about
So GCD of m comma n we have. So if we have something like kx and ky, we'll get kxy by k. So k and xy. Right.
Oh, wait, what? 2-8 also goes to 2-1.
2-8 also goes to. Okay. See,
What about 4-8? That goes to 4-4. No, no. That goes to 4-2. And that also goes to 2-1. What?
4.
Is it like
Yeah.
minimum? Is it minimum VP?
Is it?
So, but the GCD of the VP is then with
3-4 goes to 6, by the way.
3-4 goes to 6.
Like 1 and
yeah.
6, I think.
Yeah.
What's the sequence
Yes.
you're taking?
Oh,
4
I'm
to
just starting with like random starting values and seeing
Okay,
what is
okay, okay.
happening.
Like
Got it.
something like 1, 2, 3, 4 also goes to like 1, 1, 1, 6.
1, 6.
4 to 8, 4, 8. Wait, why would this? What are we taking the minimum?
1, 6, 1.
But 3 and 4 goes to 12, sorry.
3 exactly. 3 and 4 goes to 12.
But 1, 2, 3, 4 goes to 6.
It seems
Is it
like
true?
the LCM of the numbers. Like, wait, why is it going to 2, 1? Like this one. 2, 8
It
goes to
goes
2,
to
4. Hmm.
Wait, 4-16 goes to 4-1. That's interesting.
2-16 and 8-16 go to the. Oh, this is.
okay, 1, 2, 3, 4 goes to 6. Like 2, 3, 4
4,
goes to 6, but 3, 4 goes to 1,
Yes.
12.
4-1.
Okay, so
3, 4. It's you know what? The LCM of the entire 2626 numbers, that's less than equal to whatever LCM you take of 2 numbers, multiply the rest
Yeah.
of the numbers, and that's less than equal to the product. So in
Okay.
whatever way we try to decrease, like choose 2 numbers and decrease, we still have the lower bound to be LCM of the entire numbers. So it
LCM,
should be
sure, yeah.
The
right.
lower
So
bound is what again?
the LCM of
The
all the numbers.
LCM of all the numbers. Because the LCM of 2, yes. Okay.
Yeah, right. So we should be able to somehow show that it's always
Wait, you're saying
achieved.
the lower bound of the product is the LCM of all the numbers?
Not the product, whatever step you are doing. So suppose
after each
as-
step,
as-
yeah.
yeah, so it's greater than equal to the LCM of all the numbers, the product. And
Sure.
at least we know the product should be m because all the other integers are greater than like less than equal to 1. So
Okay.
we need to show that the LCM is like the constant number is basically the LCM.
The
is it the
LCM.
LCM? I don't think so.
No, I don't think so. Look at
It's the
It
LCM.
being LCM is very. Wait, I don't think it is LCM.
Like
This
1, 2,
is-
3, 4. In that
Why?
case, say it's like 6. It's not the LCM. The LCM is 12. I'm pretty sure it's
right,
not
right,
the
right.
LCM.
Wait, yeah.
And I think we can just
The-
look at the prime factors individually. Like
We should look at
that will make us
Oh,
because
yes.
the LCM
Yes.
and GCD is
Fine.
basically the prime
Take a
process.
prime.
And like we don't
maybe
even
just
need to
consider like the prime powers. What is happening to the
wait,
prime
wait.
powers?
We don't even need to look at the primes. We just need to look at the powers. So
Exactly.
we
So
have
just look at
A
GP
comma
of
B goes to A
So
minus B
If we have like P powered A and P powered B,
and
then we'll have like P powered A and B minus A.
A minus B and min of A plus B.
Ah,
Maybe we
okay.
just look at
So it's just the GCD process, I think.
oh, the GCD is invariant.
The GCD of all of
Like
them.
GCD of the
Therefore-
powers is invariant,
Sure.
I think.
Basically GCD of all the VPs. No, not the power. Yeah, just the
Oh.
powers.
Just
How
powers.
do you
Like P
define
will be
GCD of-
same, just the powers we need to take GCD upon. Okay, that makes sense with 2, 3, 4 because GCD is 2. That's why we're getting that.
Correct.
Right.
Right. So for P power A and P power B, we'll get like P power of GCD A comma B comma 1.
Invariant.
So something
That
like
is great.
Wait, does this not finish?
This should if we have it, if we prove this, just like if we show
Oh.
that.
Oh, but we did show that.
But no, we have this. We just
no, we
have
showed
this
it for
Oh.
prime powers.
Yeah.
So we need to show like it breaks on like which should
no,
be true, but
or,
like
or just
No,
look
it
at
works,
like
it
prime
works.
ka power.
For
Like
all
just fix a
primes.
power of the fix a prime and then look at that prime ka power in both M and N.
Just take
Yes,
two
yes,
values.
yes.
That is what we did.
Yeah,
Ah.
VP
So
of
this is
A,
proven.
VP of A. Okay, like this is what X,
See,
this is Y.
If we have
I'll
if
write
we
the
have X
thing,
and
so-
Y, then it goes to X minus Y and minimum of X comma Y. And those should have the same GCD, right? That's just Euclidean algorithm.
They
Yeah,
do,
yeah.
they do.
That's why
Yes.
That's why we are like this invariant is correct.
Wait, just a minute. I just want to
Uh,
reconfirm. Acha, VP of the LCM will be y minus x if x is less than y. Sure.
I think
Y.
we'll just run with P1.
how does
Yeah,
this
since this
imply?
is
How? Oh, so
GCD
GCD
of
is
x comma y
decreasing.
comma minus x.
See, like we can write M equals product
I'll just
Yeah,
write the value, like we
over
can write it.
primes.
We can
I
actually
should
just write the value.
This does finish. Yes, this. Sorry, no. We do have the thing. What do you call the claim?
It
GCD
finishes the claim. I'm not sure how it finishes the problem.
that we are not on. Yeah, sure. Yeah.
uh
Hmm.
Okay.
Value.
At each point. Okay.
right.
Correct. Okay, wait. I'm just wait. Ridhiman, just like call this G or something. Okay, no, it's Arham was right. Fine.
Yeah, this is the final value of M regardless of what he does. So we are done.
Is it the number of steps in each like
It
in the
wouldn't matter
GCD
because of that.
Euclidean algorithm of each this thing?
What?
Each
That
prime.
does not matter. That does not
What's
It
your
matter.
don't
question?
matter. Like we need the final number. Right? For each prime, it will be like P of GCD VP of A1 dot 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 VP of A2026. And when we have all the primes together, like they will just multiply. So
And that is
we
anyway
don't
the
need the
product,
number
so
of
it's
Euclidean
invariant.
steps and other things. It will just come out to be this number. Because like if all the numbers, because all the numbers are one except like one number, all the primes must be for some m and n, all the primes must uh, be divisible by like the prime will divide m and prime will divide n. So
Yeah,
they
yeah.
will be like paired at some step. And if they will
Okay,
paired up
yeah,
at some
sure. I
step, it
see.
will come out to be this number.
It's just the
Yes.
product.
Sure. So are we already done with what is this P1?
P1,
Yes.
yeah. Now,
Oh, by the way, are we doing like write-ups or like we are just solving, right?
We might
yeah,
do
let's
write-ups later, not right now.
Not
not right
Sure.
now, but
So
yeah.
we move on to problem number 2, which is a geode, which is amazing.
Only Geo.
Proposed by
This is so sad.
Ukraine. Okay, this is a weird geo.
Where is
No.
Geo?
Wait, can you
Oh,
paste the
wait, do we?
problem in this side? Yeah.
Okay.
Like people just.
I'll
Wait,
take
this is
the
Where
P5,
is it?
Lama.
Where is it?
Wait,
sorry,
I'll take
why
the
is
P5
P5?
and
P5 is randomly
Who's drawing
floating.
the
fine.
diagram?
I'll do it, it's fine.
Somebody has a stylus, so not me. We have midpoint, we have track K and L inside BMC and BNC, so set K inside angle. Okay, random stuff. OM equal to 1. Okay, sure, this should be fine.
ABC is at
Should be
triangle.
okay.
Should be fine. This is
Yeah.
A, this is B,
Okay.
C.
Now what else is there? M and N midpoints aside. BC, sure.
D.
Let's draw them.
Somebody make
Wait,
KBA.
Where is L?
let's not like label them right now. It'll be a bit hard to draw the diagram.
L
Okay,
is
sure,
inside
labelings
triangle
later.
LBA.
हाँ तो अब
Oh.
क्या?
हाँ,
Let K and L
how
midpoints inside BMC. Okay, wait, hold on.
Okay, you will
I'll-
probably need.
I'll draw BMC. Don't worry.
Wait, what is this
Wait,
random
we
circle
don't need
center?
the circle yet. We don't need the circle yet.
Okay, fine. You know what? I should just read the problem first.
हाँ,
Okay.
read the stuff.
KBA
Like
is
circle
equal
इधर
to
है ही नहीं.
ACL.
Respectively, such that K and L.
See, see. We have I think we should just make labels.
So
We can just
confusing.
erase and
Yeah.
reposition them later.
नहीं,
KBA is
नहीं,
equal to ACL.
ये लेबल थोड़ा चलो ठीक है.
Wait, are these isogonal conjugates or something?
Hold
No,
on.
don't
Check
jump.
करो.
Should be
Like, are
roughly
they
around
isogonal
here?
in BMNC or something? What?
Wait,
Roughly
yeah,
around.
KBA equal to ACL, so doesn't that imply count?
Yeah, I think it would. LBK is. Oh, no, it's slightly different, I guess. Like we
Okay,
have
wait, that is.
They are
KBA.
not
KBA
hexagonal
equal to
conjugates. I don't think so.
It's like
ACL.
LBK is equal to
Wait, no, I
LNC.
think
Oh, cyclic.
Wait,
you put K on the wrong position. That the other one's K.
That's not K.
That's L.
is this L?
No, this one's K.
No.
Okay.
Put a little bit higher here, like
Oh, K should be within B and C, no?
Yeah.
Or oh,
Wait,
wait,
how are
L
we
that's
drawing
should
this
be
diagram?
somewhere around here, I think.
How are we going to
Ah,
draw this
no,
diagram?
no,
That's
L,
very cool.
No,
L is
K
not
should be
there.
with BMC and L should be in
that
BMC.
this is fine. This is fine. This is
BMC.
fine. So angle KBA is
How
equal
is
to
it
angle
same?
ACL.
Why
Just
have we drawn the medians? Don't really need them. No.
Wait, L is inside AKC, but this is to,
what? Okay.
yeah. Draw L somewhere here.
Wait, let's
And I
just
can't
draw
find
the circle AKL once.
Okay,
What
it's a
isn't
bit too
required?
chaotic. Just
But
Uh,
why are you drawing this circle?
AKL, we need AKL, right?
AKL.
We can't get away with not drawing anything.
I mean, first draw the basic things.
We need
At least mark the angles.
later. Okay, later in the problem we do need AKL.
LBK. What's LBK? LNC.
I will
LBK and
Now we have
LNC, okay.
LNC.
He
That
Oh.
is
So let me mark it.
use like a
okay.
different color or
I'm
something.
reducing my pen thickness. This is too large.
And the other guy is LCK
Oh, this
is
is cool.
BMC.
BMK.
BMK, yeah.
Okay, this diagram
Oh,
is
wait,
not
this is
mature.
interesting. Like random कुछ भी configuration.
Exactly.
Random angles.
Okay, we've got KBA,
BMK.
ACL,
You need LCK.
LV,
Oh.
LBK, LBK. Oh,
Yeah,
Okay, fine.
what's this?
it's fine. It's
Oh,
fine.
wait, I have a nice diagram. Ancho, sorry.
You made a nice diagram. Like, just take a photo of your copy and send it.
Wait,
Oh my
like
God,
take
okay.
BK cap, like probably take
With the
BK
circle,
cap.
Never
circle,
mind,
triangle.
yours is
OM
good
is
enough.
OM, I see.
Can you
Okay.
take like BK cap?
Have we
BK
done
cap
all
AC.
the angles? You've done all the angles, right?
We have. Can you
Wait,
take BK cap AC?
yeah, wait, hold on.
Can you guys take your marker a little bit off the picture?
Sorry. How do I take mine off? I genuinely don't. What?
It's
It
move your
is
circle.
outside the picture. It's don't make the
Okay,
lines.
I can't make this really.
Hey,
that
okay,
much.
can we leave it like just free-handed? Like it's not that big of a
Can we
deal, right?
choose
Yeah.
O
Done,
first
done,
and
done.
then
Oh,
draw
okay.
stuff?
Dekho, we have a cyclic chord. Yeah. That is amazing.
We do,
Right.
finally.
Oh, yeah.
What was the term you said?
Can we choose O first and then draw L? Like,
Probably, but
I
that
think
might
this
be a
is
bit
okay.
tricky.
We can just work
This is
with it.
okay.
This is like
okay.
good enough diagram.
Okay, the second cyclic quadrilateral is like very off. So wow.
Okay, wait, what do we call these? P and Q? No, X and Y.
X and Y and D. Wait,
Okay.
what? Wait. I meant this to be call this P or something. The
But
intersection.
why do you
Alright,
need
bro.
X and Y? Why do you need X and Y?
We may, who knows? I want P and Q, like intersection with sides, because that gives us cyclic chord.
Okay, wait, let's just like. Wait, what was it that X and Y was? Yeah, this thing and this thing. X, and that thing is. Oh my gosh, this is so bad. This is already horrendous.
Sure. We can work with this.
Okay, wait. No, I'm not changing the diagram. No, it is.
I'm already feeling like pop or something. Maybe.
Yes, like that's probably how you like OM equals OM. Possibly, yeah. Wait, let me
Might
just
be.
smooth the circumcenter out.
Wait, PowerPoint where?
What?
PowerPoint basically like you take stuff centered at B and C since you have good circles like AMN.
Okay.
Like let's see what claims can we get now.
Honestly, like we don't know what we are yapping about.
Wait,
We
is
are just, like, guessing.
YLC Kalim?
We do have
YLC, like Y is defined as CL cap AB.
Okay, we have like BXYC. That's good. Like by
BXYC.
two maroon angles.
Acha, those angles. Wait, why are those angles equal? Oh, acha, that's given. Wow. Hey, that is great.
BCXY. All right.
So we already have infinitely many angles. Like,
I mean, I know, right? Like we'll have X and LB. Yeah, that one as well. Okay, then you can get the conjugate as well. YM K C.
probably.
Yeah. Oh, right. This one's already written here. Excellent.
So we should look for Mikhail points now. Given
Wait,
that
so
we have.
if you
Ideally speaking, yeah.
If you draw this circle KXC, then it's tangent to MK.
Yeah, let me quickly
And
draw that
also,
circle.
Is that
don't-
true?
is
That
that
might.
necessary? Yeah, that's like exceedent.
Wait,
Is
no,
that
no, no.
necessary
Is
to draw?
it? Is
Is
that
what?
actually true?
I mean, you just take
Oh,
angle
acha. Okay, it is true.
MKX.
It is true. That is interesting.
But
Okay,
Oh,
there
no, no,
we
he is
got.
saying
might
ki,
not be useful.
no, he's saying ki this is like MK is tangent
Tangent
to
to
this.
MK. Yeah.
Yeah.
It's a bit bad, but yeah.
Okay, now we
So,
need another.
let's not draw it now. I don't think it will be required. At least I feel.
Like we can freehand, I think, right?
Fine.
Can we?
No, like I can
Yeah,
quickly
yeah.
do this. Don't worry about it. Don't worry about it. Wait,
Okay.
what? What the hell?
What is that, Lama?
That was like the mirror link.
BC
Crazy.
XY cycle.
Bro,
Yeah.
pasted the Miro link in the Miro.
What is X? Okay, X is I don't know.
Can someone else freehand the other thing? I don't trust my freehand skills.
Oh, I will try to freehand. I don't trust my skills either, but
I don't trust your skills either, but okay.
it's the best we got. It's not bad, hey.
Not bad at all. Not bad at all.
Therefore,
Wait, what is
this one,
Okay.
It's a Z angle.
MKC.
Okay, yeah.
Oh, right.
this
Right.
one.
But what was the
Yeah.
claim? The red circle is tangent to what?
Wait, what is the red
Not
circle?
the red circle. It was CKX tangent to M, like MK tangent to CKX.
I am just making this green for like
MK tangent.
other reasons.
What is the red circle? Like, it passes
The
through
red
what-
circle
MKC.
is it is CKMY. CKY.
Okay,
Oh,
wait.
CK.
Hold
Oh,
on. This
okay.
one is like
Okay.
Wait,
okay.
MK is tangent to the circle.
Not this
Black.
circle, other circle. That was CKX.
Okay,
Maybe
black,
black,
green,
yes.
red. Simple.
That's nice. So like अभी कहाँ से pop
Yeah.
or something?
Uh
Or maybe pop is not very good yet.
no. Like, hold on.
I mean, it is cold. You know?
If you can take those, then would that work? Mm,
Hold on.
no, it's not looking too good.
Is there any nice circle that M and N pass through?
Well,
Yeah, at least not in this config that we have
Not-
right now.
not here.
But
I think
yeah,
we
I
should
mean
draw
we have
another
to.
diagram where we have everything cleanly without
That
this
is true.
infinitely many circles.
Okay, fine. Hold on.
Just copy this, no?
Yep. I'll put it to the left. And like, what are we doing? We're moving all the circles?
Yeah.
Fine,
Yeah.
just keep those. Just keep
Oh,
those.
wait. Okay, so A lies on the power of point of the green and red circles.
Wait. What's
You
the
mean
Hold
radical
on, hold on.
axis?
Yeah, wait. Does it? Let me just check.
Does
Okay,
it?
it does not. Never mind. Never mind. At least it doesn't. Oh, wait, it actually does. It actually does. And then we also have MNXY cyclic. First, we have
Right.
MNXY cyclic because, like, by Rames or something.
How does it like?
Okay, MN is perpendicular to BC. That makes sense.
Like BYXC is cyclic, so MNXY should also be cyclic by
Oh,
Rames.
right.
And then once we have that, we get that AX.
Got it. Yes.
into-
Yes.
Yeah. Let me. Yeah.
But
AX
after that,
into-
what do you do? MN XY cyclic then?
So AX into AN is equal to AM into AY. So A lies on the radical axis of the green and red circles.
Yes.
Right.
After that, who knows? But wait, what if we show? Okay, hold on. This circle.
So we should
MNXY
write
seems promising.
stuffs down, I guess.
Write it on the right side, yeah.
Yeah. Okay, MNXY looks promising because like we want. Can we try to figure out what is the center of MNXY? Because we want to show that O lies on the perpendicular bisector of MN.
If we take these two. Okay, ideally speaking. Wait, what?
What is these two?
We take the midpoints. Take the midpoints because like I'm
Of
trying to
BM and
work
C?
backwards. Yeah, of like BY and
A
C is
lies on
X.
radical axis. Oh,
Interesting. इससे क्या होगा?
I mean, then like you can change the condition now. So now you need to show what what. Why have they used MNN already? We need other things. K and L also they used. Brilliant. What other midpoints name exists? We haven't used P and Q yet, right? Okay, fine.
We have not.
P and Q. So A, P, Q, K, and L.
What's PQ?
P and Q are the midpoints of BY and CN.
A P Q K L. Why
CX.
so?
What's the
Like
motivation for
that's
getting
what
those?
that's what the question asks, like OM and ON.
Sure.
Since those are the midpoints. So
Yeah.
if you want to show those two are equal, it's going to be the same as showing that P and Q midpoints of BY and CX. Those
Yeah.
line thing.
Those
Oh my
line what?
god.
Wait, is it
But
actually what? I'm not sure if it is.
I mean P does not look like it at all.
I mean, like 8 also does not seem to lie on the radical axis of red and green circle. So our diagram is just bad. Like
I mean, you
horrendously
can't
bad.
trust the diagram. Like, we don't have the angles to be equal at all.
True.
Don't trust
I'm
the
not
diagram.
wait,
Trust
I'm
the
not sure
angles.
why we want to prove
Wait, do we need to
APQL.
prove APQL or?
We would need to, I think. Let me
Okay.
just. If you take
Can
all-
you explain why?
I
Okay,
guess
hold on.
OM equals to ON will be easier to prove than introducing two random points.
Fine, yeah.
Hold on, wait. No. We want OM equal to ON and we don't know anything else.
This other
So
diagram is
I am
much
like
better.
sure कि spicing ही करना है. Like this problem is surely spicing.
A
Not sure.
lies on that.
Ridhiman, can you move your cursor?
Oh, fair.
Alright, yeah.
This is weird. I went the other direction. My cursor went the other direction. This is interesting problem. This is proposed by whom again? Who is
Some
Ukrainian.
Ukrainian person. I don't know.
that is insane. That is
See.
interesting. Okay. So
I
okay.
see there are.
Well,
Bol.
You can go on.
I was wondering if O lies on MNXY. Like हमारे diagram से तो no way, but
O
yeah,
lies
Does
on?
not lie.
M and
नहीं,
XY.
that's not true.
I don't think that is true, right? Because
What then? O would have to be the midpoint of arc, no?
yes, it would. I mean, I'm not sure. This diagram is just
no,
poor.
I don't think that's true. Like, not because of the diagram.
Why is that not true? Do you have a reason or is it just feel?
For now, we just feel, I think.
For now, I'm just feeling sure.
Okay.
If OM is.
That might be too good to be true. Who knows? Wait, so how can we reconstruct this diagram? Can we like just take like पहले draw x and y and then उसके बाद नहीं first take a random circle through MN draw no like generally how would we reconstruct this diagram on say GeoGebra? How do we draw K and L? Sense.
We even have this.
Yeah, can we just like okay, can we just make a new diagram? I think better way to think
We
is
had a new diagram. I think
where is
the new diagram we can.
Oh,
We don't
there
have to
is
draw
new-
the all circles. Yeah.
What this is?
Good job.
Wait, did somebody just copy paste the whole diagram here?
Yes.
Exactamundo.
Oh, I was.
The other was to represent KNL without the angles.
अरे we can.
We can just do
we
cycles,
can,
right?
We can
You
just
can just do
define.
cyclic now.
No, first
देखो,
choose
देखो, देखो,
x
just
and
take a
y.
circle.
First choose x and y, right? Such that
exactly.
b, y, x is
Wait, we
cyclic.
choose
And
K,
then you
then we
choose
find O,
K
and
and
then can we find L?
Exactly.
Choose K.
First,
yes.
no, first define x and y. Just take a.
Random two lines, then you take those. X and Y. Now you have those and with those.
No, X and Y are not random. You can only
X
define
and
one.
Y
We
are
see XY is cyclic, so you can't take it
Only
random, right?
cyclic is.
just
Take X,
those
then get
Just
such
take a
Y, then
random
get
circle
K and
through
L.
BC.
Is there
Take a
1
random
degree of
circle.
freedom?
Okay.
Wait,
No, I mean you take a random circle through BC and then mark x and y. And then on BX choose K and CY choose whatever. Like L, and such that you require one more angle condition that BYLC is.
Like, you can do the tangent
Oh.
condition.
Wait, it's predetermined, right? After you choose x and y because of this angle condition.
Yeah, like if you choose X, Y is also predetermined.
Yeah, just
Yes,
take
yes.
take X and Y, and then उसके बाद take like K,
Then you take the circles like what?
T,
B
CMX,
and
CMY, and B and
B and
X.
X. Yeah, you take circles B and X, C, M, Y, and
And
you
then
get K and L.
exactly.
Like
And
taking
By
the
the
then
way, if
intersection
we
with B, K, and these things.
so
if
we
we
can
want to
already complex.
MMP, because we can move X on AC, MN will be fixed. We just need to prove O lies on the perpendicular bisector of MN.
Uh,
Like
can we
the
actually
perpendicular bisector of
do
MN is
something?
fixed, so
Wait,
we
hold
just
on,
need
hold
the
on.
degree of O.
Wait, I am just thinking कि surely one Mikhail will finish this. Like this gives me that vibes. Like there's some G5 or something. This is very similar to it.
22.
It was also center of something lies on perpendicular bisector of something else. So
Huh.
I think 16 G5 or something. Like
Okay,
that had
okay
literally,
equals OL. Okay equals OL, yeah.
yeah, it was literally just like there was like one line MMP solution to it. And even if you don't want to use, you can just use PySim to kind of hide the MMP. So yeah. Mm, okay, I want the circles.
Yeah. The red circles. Weird. A1.
Do we have intersection of circles?
Okay, like we can write trivial pop stuff. AM times AY,
We can, but it's so okay.
AN times AX. Or what else?
What I'm wondering, what else? Or maybe
You can
maybe just
you
we
can
make.
these
Oh,
intersections.
Aram is making a new diagram. Yes, let's go. Thank you.
Damn.
But Adam, if
Okay.
you're done with the diagram, tell me, I'll show that diagram.
Yeah, I will just help Arham
Okay.
make a new diagram because like this diagram is looks peak till now.
Till now,
It
yes.
looks normal.
I mean,
Yeah.
like we're betting on you, Arham. Don't be.
Yes. So, can you draw the circle?
I mean, if you take P and Q, then you can also have that this thing is
Either
equal
if
to.
degree of X is 1, is degree of Y also 1?
It's not. It's not. They don't move projectively. They do not move projectively, as far as I'm aware.
Yeah, it's not a projective map, but is the degree 1.
Degree one,
Like
I don't think
it
so.
doesn't necessarily have to be projective map to be degree
Do
1.
we have anything about P and Q though?
It's
Like,
not. It's not. It's not.
like you define P and Q as intersection of red circle with AC. Oh wait, I swapped P and Q. Damn it. Right.
Wait,
Oh.
after getting the circle, how do you define K?
You define K with like you look at you defined X and Y, right?
Yeah,
Yes.
you feel like
So you look
BX
at
cap.
D and L. Okay, no, sorry. B and X. Yeah, take D and X. Similarly,
I took
C, Y, M.
CMY right now.
Yeah.
CYM. Yeah,
So
CYM.
it would be CYM cap CM.
Okay, wait. Like we should probably first draw the lines.
Just intersected with CM.
Those two.
Okay, you're making the circle. Okay, great.
पहले वो circle. First the circle.
BMX,
Okay.
right?
B and X, yeah.
Okay.
Hmm.
Wait.
Oh wait. Damn.
Oh, what do you get?
See. Like look on the left of the diagram. The
AP,
pop.
AC.
Right.
You see P and Q.
Wait,
And
why?
now
Oh,
Yes.
okay. Wait, so
now
we have
AC
involution
is half
slopes.
of
Yeah.
AC is half of AN. AB is half of AM. We can surely cook.
Oh, okay.
Is
So
equal to,
like
why do we have these are equal to AP into AC?
because of
Is
by
it,
pop on
pop
green,
again? Oh, acha, is it
pop
pop?
on A with green and red circle. That
Oh,
will do
so
that.
this is kind of like homothety only. Yeah.
Like this thing is yes, yeah, you can
Kind of. Or
start up.
like extended range or whatever.
So like
We can
AQ
get
times
ratio.
AQ times half of AX. Half of
Do you want to
AX.
work in M or X? M or
Like
Yeah. So AY
remove
is
the
just
M.
2 AQ, I
Remove the
think.
M.
AY is 2 AQ.
Okay, so like that means
So
P and
Q
Q
is
are the
midpoint of
midpoints.
AY.
P and Q. Okay,
Wait, I'll
P is
just
equal.
make it a bit like this. And
anyone knows? Okay, I'm just calling it
Q
mid of
is
this
AY.
thing. Mid of AX.
Oh.
Q is equal to mid of AY.
Midpoint
This is
of
brilliant.
AY.
Wait,
Brilliant.
Ram, can you like adjust the red circle a bit? Like
So
it's
like you have PQ is parallel to XY.
Sorry?
yes,
Oh,
PQ
PQ
is
would be
parallel to
parallel
XY.
to XY.
PQ is
Yeah.
parallel to XY. That is true. On that note, we should draw
You
PNQ.
can angle station.
Maybe yeah. Just like I think
No, you
uh,
can't. PQP is not nice.
Wait, we are losing focus on KL. We should focus on that.
That is true.
How to
uh,
Mm.
take it into consideration.
oh okay, we have to
AKL
what,
circle, right?
what did
What does it pass through?
I
I think there's a
Arham,
nice
I
thing.
think the diagram has to be like very accurate for the POP claim to hold because like green circle is very big.
Let's try working backwards. If OM is equal to ON, then what do we have that's nice? Okay, OM squared is equal to ON squared. If you want to use pop again, but like I'm not sure about that.
Yeah, me neither.
Wait, do we
What
have M X N Y? Surely not. No. MN is sorry, my bad.
yeah, MNX5 exists. Yeah.
Yeah. Like I mean MN is parallel to BC, XY is anti-parallel to BC. Yeah.
Yeah. Um
MNXY. We have this as well.
I
I
wonder
am not drawing that.
if MN okay, I'll just make like a makeshift diagram for now, Nietzsche.
Nietzsche, like just don't draw MX and Y like that. That's
Mm, I want to like work with the new definition, like
wait, then XY
kind of what
goes
I think
through
Vincent is doing.
midpoint of XY goes through the AC median. Okay. That is good. That is good.
What
Midpoint
did
like-
you say, Rania?
Wait, we
Midpoint
have
of?
a sorry, midpoint of XY. Because like XY is
yeah.
anti-parallel to BC. And similarly PQ.
Oh, okay, that makes sense.
So like you can have a transformation that takes AXY to ABC. PQ would go to MN. So like you reflect about the angle bisector and then you use some dilation ratio, some homocity ratio.
That's fine.
That's
But
not
I
really
want to
good.
introduce K and L into the picture.
Yes, K and L.
Right. So what if you take the second intersection of BK with the circles, like whatever circle?
Sure.
We-
Since you introduced the idea, you will have to introduce the names of the points.
Yeah, of course. Let me just over here.
X and Y, R and S.
Okay, what are you calling it? What is this?
R is BX intersection circle AKL and like CY intersection AX whatnot. AKL. Yeah.
Okay, fine.
M, S, and Y literally look like the same point.
I think now the midpoints idea might help, like taking the midpoints of BM and CM.
Like what does that give you?
Because we can use POP again with these points. One
POP
sec.
on what?
I'm writing. Why should I?
What?
Like BM into BA. Wait, not BM into BA. Sorry, BA into BY.
Yeah.
BM into BY. This is like, say this is PQ.
No, we've already used PQ. Like
Wait,
Oh,
my
okay.
diagram is very nice. It's like MON are
UV.
connected. Is that even true?
That
Great.
is not true.
That's
Like,
not
That
true.
is.
O
Okay.
can O is
Okay,
visible.
we have UV. So it's like BU into BA, right?
Oh, sure. What circle are you taking though?
One second.
What is U?
You you can introduce them, sure, but it's Arithra's idea. Like take the midpoints
Midpoint of BY and midpoint of CX.
Then what is P and Q?
P and Q are the intersections of the red circle with AC, that's P, and the green circle with AB, that's Q. You can also think of it like P and Q are the midpoints of AX and AY.
Either can any of you check if the sharing screen is working properly?
It it is like,
It
It's
is
fine.
fine.
Yeah.
yeah.
So ideally, you should probably zoom out a bit, but okay.
I can't see the
Yeah.
diagram if I zoom out.
Easy.
Oh, I swapped with
That's
circular screen.
Wait, let me see.
Okay, I will change the
Yeah.
colors.
Yeah, no, this is. Oh, right, those two. Sure.
Sure. Okay.
Okie dokie.
So
Fine.
you have this is X. Wait, no, this is P. Oh, okay.
That's Q. That's Q. The one which you just drawn. That's Q. Other
P.
one's P.
Okay, wait, this looks accurate. They do look like the midpoints.
really nice.
Excellent.
Oh.
Wait, they actually do look like the midpoints.
The radical axis thing is a bit scam though.
Kaun sa radax?
Realism
This.
radax of these.
It's
uh,
approximately a line. It's fine.
Just approximate. Wait, does the radax concur? Like, does this point lie on the radax? Does it?
BXCY E.
BX capture.
Yeah, does this
Sorry,
lie
this
on
is
the
just some.
radax?
Sorry, this is some brocard.
Radax of.
Oh, it's not even Brocard. This into this equal to this into this.
So,
Because BXYC is cyclic, right?
हाँ वो तो है.
So
Then
it does.
what?
So it
Oh,
does lie.
it does. Oh,
Yeah,
so
it's
we know the
speak,
radax.
speak.
A time. Okay, wait, define this point. Call it like.
But can you explain
W.
me
What are we
again
calling
what
this point?
happened?
Hold on.
Call it P. Wait, no. Fine.
Like,
Call it
observe
S.
that this into this is
We are
equal
done
to
with
this
S also, Arham. Just call it W.
Okay, sure.
Right.
Hi, when did we go through all these points?
I mean,
So what is the radax of
we-
which silicon?
Green and red circles.
You know what? I don't think RNS give much mileage. Just remove them or
Right.
reuse it maybe.
it's fine. Just let them be.
Uh,
Okay, wait. Yeah,
Interesting
Is BX
diagram
the radax?
choices.
I forgot RNS exists. Let's
No,
just like
BS is-
pop on them.
So like
BK,
this is supposed to be the radax,
BK
which
times
looks like
BR
not bad.
is equal to BY times B.
Interesting.
Wait, what
No,
is the
no.
radax of the green and red circles?
Green and red
Yes,
circles,
green.
it's AW.
8W. Weird. What?
Yeah, like see, you see W, the power point of W is with say, the green
W
circle,
times KX.
like BW times WX is the power of W in the what do you call green circle.
Mhm.
WY times WC is the what do you call it?
Yeah,
Now,
it's red circle.
red
Is
circle,
O,
and those two are equal because BCXY are cyclic.
is O the center of MXY?
Okay.
It's not, right?
Is that true?
MX.
No,
I don't
O
think
is,
so.
O is
Yeah,
center
like,
of AKL.
probably not.
Yeah,
Wait,
okay.
how do you
MXY.
Too
have
good to be true.
I
Yeah.
see what you're thinking of, MXY.
So on.
how do you have
No, I see like
AYX?
Aram was like conjecturing
AYX.
basically that cyclic we had na M, X, and Y. Aram is conjecturing that O is the what do you call
That's probably
circumcenter of that.
false. Yeah.
If we have that, we would be done, ideally.
Yes.
But I mean, I don't think like O is variable, right? So like O is
O is
geometry.
variable with K and L, and X and Y are also variable. So
Yeah,
Like-
like it would be very insane if K and L kind of remain.
who said
diametric.
same problems come on the IMO, Ridhima?
Hmm?
Who said same problems ever came on the IMO?
That is true. Who knows?
The people over there, they knows.
Okay, so what are we currently trying? What's the claim?
By the we proved, right?
True,
Like-
what?
What did we prove?
Aram, till
why
now,
does-
basically we got a lot of cyclics, lot of pop.
No, wait. Why
Okay.
does K,
got
W, X and
midpoints.
this intersection seem to be collinear? Intersection of that AKL and the red circle.
AKL and
Also-
red circles.
Interesting.
And also
So you're saying it
CLWY
lies on the
and-
radax, is what you're
I
saying.
mean, it might be the radical center if that happens.
Wait,
What
what?
do you think are the
That's
radical
too
center?
hopeful.
What do you think is the
W.
radical center of?
Like this, he's
W.
saying this basically.
Yeah.
Huh?
Oh, okay.
That is
That
like
may not be
interesting.
true.
That
Because
may
for
not-
that
so
we-
like
I
K,
don't get it. What is the radax of what?
Oh,
W
even
is
this,
the
even this, even
BW
this,
is
even
the
this.
radax of red circle and AKL, is what he's saying.
Yes.
And
Red-
CY. Yeah, they look very collinear.
Exactly, that is peak.
Yes.
Is
Red
it
circle and
there is no way this problem is just Radhax spam, like ऐसा नहीं हो सकता है भाई.
wait, we've already defined those 2 points
What?
like as R and S. That's what they presented.
Wait,
I can define
guess,
them. Wait.
but I
Might
have
be.
no, I have shown that BX intersection AKL is R. I have defined it as follows. So it may not
How
be
you
under
defined
red
R?
circle.
R.
Yeah, you defined that
Ah.
as R and that is S. Sure. Yeah.
Oh,
That should
yeah, that might
give us
help.
good stuff.
Call
Okay,
this
wait.
S.
We have
How do I show it
BX.
lies in the red circle?
Wait, how do we show it rise in the red circle? How have you defined R?
R is basically so BK or BX, whatever you want. Take that line, extend it, and meet it with AKL. That's what I was.
Okay, okay.
Oh wait, I
So-
have a couple of ideas. Wait, okay. So
Wait.
actually, can we redefine R and S? Like define. Okay, I don't know what you have defined right now, but let us work with the definition. R is equal to BK cap AKL, and S is equal to
Yes.
AKL cap.
That's the
Yeah,
one we're working
that is
with.
what we are doing. That is
Okay,
what
That
we
is
are
what
doing.
we're working.
Sure. Then observe that like obviously SRLK is cyclic.
Oh wait, I got it. Yeah.
Further,
A
do you have
yes. A yes. Okay, fine. Wait, let me just write the form.
You know what? We can also show B lies on the radical axis of AKL and the red circle.
BK times BR is equal to
B?
BM.
Wait, BK times?
No. Wait,
No,
you're
we don't
assuming
have that.
BK
that.
times BR.
Wait,
BK
what is
times
your
B.
definition of R? R, we don't know R
R
lies
is
on red
not
circle or not.
Here.
R
Yes.
is
R does
R
not
is
lie
the
on red
definition.
circle.
No,
R lies
but
on
it.
BK by definition.
Yeah, but we don't know if it lies on red circle.
Yeah.
Yeah, we don't know that.
So okay, go on.
So BM times what again? BM times BY and BM times BY is equal to
Wait, how is this though? Doesn't this assume ki MYKR is cyclic, which is
yeah. So we're
something.
trying to show this lies on AK, no? AKL.
No.
No. We
Look
are
at the
assuming
definition
something.
once again.
The
Look at the
definition is
definition.
ki.
Oh, you're doing it the other way.
Yes.
Well, this one also works, but sure, fine.
Hold on. I was like thinking some different things, but sure. I mean that will also eventually work.
Wait,
So
what
what
is
if we
Arithra
add
writing?
this?
BKBR is equal to BMBY.
Where is Arithra? Oh, no, that's mine. That's
I'm
mine.
not writing. I'm not
The
writing.
Oh,
thread
I thought Arithra
disappeared.
was writing. No,
No,
my bad.
that's mine. Actually, I should put a question mark on top of that. Yes.
Why is it BMBY? Oh, okay. That's
You need
you
to
don't
show.
know. Okay.
Now, what is BK times BR?
BK times BR.
AK. AKL. We need other points to lie on AKL. Okay, fine. Like introduce the intersections of this
Do
thing
we
with
introduce
AB.
AKL cap BC?
Yes.
Two
Not
intersections.
BC. I was thinking more
Wait,
of
we might be
AB.
hoping. We might wait. A second.
Why?
Just a second. Sorry. Just like consider the radical center of red circle, green circle, and AKL. So W
And
that
AKL?
has to be W.
That is A.
That
Oh, wait.
is
Why?
that is W.
W. Sorry.
I think. Wait. Wait. Hold on. Because
What is the
W lies on.
justification?
Hold on. W lies on
Like
radix of like
red and
of
green.
green and red circles that we know.
That we
And
know.
yes.
So now we need to find the power of W with like whatnot, AKL. Okay, then you have SL. Okay, you need to show W lies on SL. What have we defined SL? Oh no,
That is
this
like
must
equivalent. We are just running
You
around
lies
the
on
same
what?
in a circle.
wait.
If S is actually that, or if S exists. So we
Yeah,
can
if S exists, yeah. Yeah, RM is basically cyclic reasoning. Nothing interesting, not yet.
we already have a lot of cyclic quads. Don't introduce circular reasoning.
Well, ideally, then we do need cyclic reasoning.
Bro, we are running
Okay.
around in circles.
But I am just thinking, does the midpoint of BY and like CX also lies in the AKL circle?
It
BY.
By the
does.
diagram.
Like Ronit, isn't
These-
that
that
what you had
seems
conjectures
nice.
last said?
You had,
Okay,
right?
so-
That before.
I think Ronit had that.
I did, yeah.
What do you name
Did you
them?
prove that before?
These we don't have that. If we do that, then like
Life will be easier, huh?
much easier.
True.
I mean, like,
is it
okay, we need more point names.
call that something Z?
We've already called it U and V, I think.
No, I don't think that's used.
W life.
You know, IJ is missing.
What is
H
U
is
now?
missing.
No, Devarjan, no I.
Okay, so if you have V as the midpoint of XC, so you would get XV times XA is equal to what not? XP times XC. So from that you can get
Okay,
a
wait.
relation.
Wait,
Let's see.
we already wait, but we exam. Wait, we were just like done, right? Because
So
W lies on the
P is,
radical axis of red and green circle.
oh yeah,
And observe
wait,
that
P is,
BXW is collinear and BXW is just the
no,
radical axis of green and
Ju-
of red
Just a
and
minute,
red.
Riddhiman, just a minute.
wait,
So
wait, run it.
We haven't,
Look
how
at
do we
this.
have this? Like, we have BA
like
times BY over 2.
BXW we know, right? Like W is literally lying on BX, and we know that
Okay.
BX is the radical axis of red and AKL.
No, actually run it. Look at this. We already have
We
P
don't
as
know
the
that
midpoint
BX is
of
the radical
AX,
axis
right?
yet.
We
right?
don't know BX is radical
Why
axis of
it is
red
now?
and
Because wait,
Now-
It is not,
sorry,
it is not.
We don't
never
know
mind.
that.
Okay, never mind. Never mind.
Yeah, I got a bit confused. So,
Wait,
like, this is
look
what
at,
you're saying,
oh
Aritra.
shit.
BA times
not
BY over 2.
Yeah.
Sure. Now, what is BA times BY?
So
AY
like
times
BA by 2 is just BM into BY basically.
So, like, this is BY. Sorry, no. This is AB times
But like there are
AB.
so many POPs we might use linpop,
We might
No,
actually
no.
consider.
but like
Don't
we
use
need to
it.
know the
Oh, by
POPs
the way,
number.
why is BU into BA? Why is U the midpoint of BY? Like,
That's what we are defining.
Defining.
oh, but
Okay.
like
Okay.
then we don't know if it lies on the.
We are trying
We
to
don't.
prove that.
Oh, okay.
Riddhiman, see, it's just a product.
Uh,
We haven't said this product is equal to any other product.
Okay, sure. I see.
I mean, now we're getting into some nasty squares.
Wait, what is AB minus AY? That does not look nice.
But like AB
Not
into
nice.
AY is good because AB into AY is AX into AC.
AB into AY. Wait, what is AB into
AX into
AY into AB. AY into AB is
AXAC?
AX.
That's AXAC, right?
Yeah, exactly.
But AXAC is still random. Like,
Well, now we
we
need
know those two are
something.
equal, but we don't know what they're equal to.
Yes, what's AB square over 2? Oh, wait, AB, we can substitute with AM. Does that give you anything?
Probably I doubt.
2
AM
AM.
is
2
2
AM
AM.
square.
So
2
2
AM
AM.
square, I think.
We are just hold on. Angles, why have we not looked at angles? Why is
We also have the like X is the midpoint of PV and like Y is the midpoint of QU.
wait, we do?
Yeah.
He is
Hold
the
on.
midpoint
That's
of
not
AX,
true.
right?
Arham, what were you saying? AM's 2 AM square
It's the
minus.
midpoint of A.
Yeah, 2 AM square minus AXAC by 2. But that's still not nice.
Not nice. Yeah. Aritra, how confident are you in your claim?
Not at all. It
Okay.
looks like the points are good for some reason.
Like
Uh,
you are wait, by the way, like R and S, like the Radax, the existence of R and S is equivalent to U and V lying on AKL.
Yes. That's
So
what I'm trying
like
to show.
one true implies other true.
Wait.
but how is that RNS?
Because like just do the pop, you will see it. Like
Let's
BY
remove
into BM will
AKL.
be BU into BA is equal to like power, like so power with red circle equal to power with black circle.
Okay.
BU is equal to BY over 2 times BQ.
Is the AXY circle good?
Might be, but I'm not really
Does
sure.
that pass through U or something? I don't know.
XY passing
Oh no,
through
it can't. It
Why
can't. No, it can.
XK,
But it's not true. I don't think the angles match.
XR, XA.
AYC is not
XP times
YC is
XC.
CYC. Because these
Oh,
two angles
shit.
are equal, so
Wait. Aritra, your claim is actually correct.
did you
Yeah.
prove it?
See, look at POP of X. So this gives you XK times XR is equal to XP times XC.
Wait, what
Wait,
is
but we
XR
don't
right
know
now?
if R
No, that
lies
is
correct.
yeah.
XR times
XP?
X. Okay, XP times XC. XP times XC is equal to XA times XV.
Wait, why
Why?
is
But like the first one is
XK
assuming
XR
the R
equals
lies
to
on it.
XP XC?
Yeah,
Exactly.
like we need to assume R, like
After
we prove
assuming
like
R, you do have your claim.
Okay,
But
that
like,
is your
we are
assuming.
that
reasonably
is what it
confident
is.
R exists. We are reasonably confident R exists. We need to prove that. All agreed. But
Can
once
we
you
just
have
try
that,
to okay, yeah, I see. From that I see U and V existence.
Yeah.
What
X.
after that? How do you and B like what?
See,
Oh, देखो
Just
देखो,
take
I'll give
POP
you
from
wait,
X.
I will just give you a simpler one. Observe that BY into BM is equal to
BY,
BU
BM.
into BA because U is midpoint of BY, M is midpoint of BA.
BU into B. Okay, sure, yeah.
Yeah, so like red and black circles have equal power.
Red
B
and
has
black
this.
circle. What?
But okay, you know what? Let's just assume this.
No, that
We'll
doesn't
just
make
try to
sense.
prove it.
Okay, let us assume this and prove, and then the proof comes to just proving this.
Yeah,
So
exactly.
why
I
is
think
BU
we should
BA?
redefine R.
Why does U lie on that
Sure.
circle?
See,
Yeah,
like
so
the issue now we're getting is we have this great claim about U and V, but that is if we assume something about R. But if we just redefine R, we already get that claim.
How?
So no, just redefine R to be that same intersection.
But then it does
Which
not have
intersection?
to lie on that circle, right? Like
Then it
we
won't lie
can't
on
assume
it
BX.
three
cannot lie.
circles, two circles and a line at once.
Exactly.
Oh,
We need all three. Like there is something left to the problem
We are just like I
at,
think we are
at this
just
point.
missing something easy. Like इतना नहीं होगा ये. Or
No, I
maybe
think we're
होगा.
going in a loop. There is something different
Like
we have to think.
I think W like showing with respect to W is like best, but what is the power with respect to W?
Have we
That
like
is
used all of the conditions in the problem yet? All the angle conditions?
we have because we
we just
remade the
redefined the
problem, right?
cyclistics.
Okay. But where have we used the circumcenter definition?
Oh, we have not reached that yet.
Exactly. So
But like that, the circumcenter and RNS are independent. So.
sure. Okay, yeah, fair enough.
And XY. Have we made full use of this?
Also, why is there like some random config issue? Like, what are the conditions for? Is there some config issue?
I doubt. They have specifically mentioned stuff like K lies within this triangle, L lies within that triangle. So they want to avoid config issues probably.
Yes, but like we need to make sure then that our proof doesn't have those issues.
I mean, I honestly don't see why they have done that. Like, surely it does not matter.
No. Wait, I'm sorry, I don't get something. In the pop we had over here, xk times xr is equal to xp times xc. We are saying that's where the issue is. But if we instead, like I was saying before, define r to be dx intersection red circle,
Okay.
what are we missing?
then we also get MR equal to KP if we define that.
Then don't you already have Arithra's claim?
No.
What was his claim?
No, wait,
What is
hold
his
on.
claim?
What is V? Where is V?
Like at some
We
point,
need
it's gonna be
R
very
lying
easy.
on the
So R
AKL
lies on
circle. We
AKL.
need that, right?
We also
Otherwise,
need R lies on the black circle, AKL circle.
xp times
like xc xv equal to xk xr, like xp xc equal to.
Exactly.
No. What? See. Wx times
Oh, wait,
Wr.
I see what you mean.
We
xk.
already have that. Why are we bothering about third intersection? No. Xk times xr is equal to xp times xc. If we redefine r to be bx
Oh,
intersection this,
we do xxp, sure, but then
we
how do
like
we? But then that assumes ki v lies on AKL.
no. Xp times xc. Xp is half of xa. Xv is half of xc.
Oh,
2 times
acha.
half cancel.
And y is p half of xy. I will just trust you on that.
We proved that before.
Oh, acha.
P
Have
is
we done? Oh, AMAY, okay, APAC. Okay, sure.
so XA into XV.
So we. Oh, acha. Wait. So what do we get from this?
But that is
We
XA into
lie,
XV, right? Yeah.
we get that the midpoints of by and bx lie on
Wait, from where we get like
AKL.
X into XR is like XA into XV. So
Wait,
like
but एक second,
ARKV is cyclic. But
Wait,
we don't
just
know AKR is the black circle. So we don't know V
exactly.
lies on the black circle.
Exactly. We will know ARKV, but we don't know if AKR is the
AR,
black
Like we
circle.
know
that is right.
ARKV and AUL and
Okay,
R.
fine. Aritra, just a minute. Like we should write this first.
But we can probably write some other circle and prove like the radical center does not exist, or like the three radical axis does not meet or something. And
Can
then
someone
we'll
tell me
have
the
like this
cyclics we
three are
have
like one
now?
circle.
Can someone tell me the cyclics we have now? A, K, V, R,
Yeah.
and
Like
someone,
last,
and the other one A, L, U, S.
yes.
I just
Not
want to
S, it is
see
R. ALUR.
AL, how do we have AL?
Oh no, ALUS. Sorry, yes.
ALUS because okay, wait. I just like we've already boxed the definition over there. I'm
Okay, we
changing.
don't have 2 points in common. Otherwise, the radical
We have
axis item would have
boxed
been.
the wrong thing. Wait, hold on.
No, that was what we were doing before. Have you changed the definition?
Yeah, we have because otherwise the PowerPoint won't work.
Sure.
And now, yeah, okay. By the way, our whole thing is skewed with RGB.
Hold on, we should be.
Okay, so after we have AKVR cycling, what if we have some other set of 3 points, say ARVL or AUVR, something like that?
Wait, with
So
this
out of
definition,
those,
why
which
is
is true?
AKVR cyclic?
Yeah, hold on.
If we have that.
No.
Okay, so
There is no if
hold
over here.
on.
AKVR is true.
Why?
Oh,
Let
acha,
me tell
because
you.
of the thing.
Yeah,
here.
that is POP. We did it.
Yeah,
Okay.
Aram's just
So
like,
now
let me
choose
tell
between
Aram.
U and L. Okay,
So,
sure.
Aram, like, are you completely sure what the definition of R is? I'll just say that
Yeah.
again. Okay,
Sure.
fine. Cool. So, xk times xr is equal to xp times xc. Agreed?
Wait, XKXR, XP, XC. Sure.
Right? xp is half of xa.
XP is half of XK. XP is half of X.
xa.
Sure. Yeah. Okay.
And xv is half of xc.
Okay.
So, like,
Fine.
2 times half cancel.
Okay, so that's XA, XC.
So, xa xv
XC.
is equal to
Yeah.
xb xr. So, arvk.
Yeah, okay, fine.
Similarly, alus.
Okay, fine.
Now you want to show that R and S, which we can now redefine because of our cyclicity, lie on AUV or AKL, whatever.
I'll- Wait, I'll erase all of this because it was.
Oh, this. Yeah, go ahead.
We don't have that AYW axis concyclic, right?
AYWX.
They are probably they are
Okay.
not like they are not. Wait, we could try to MMP. Yo, wait, for MMP, I have an idea.
Let's not.
No, like
That's
it is
not
really
MMP.
good because
That's
it is
Aram's idea.
because the locus of W is a degree 2 curve. So W moves with degree 2. So like X and Y are actually degree 2.
Yeah,
So
but
after
that's
that,
not a good. Like O just ruins the party for us.
वो भी हो सकता है.
It's like it will be almost 2 of degree A plus degree of B plus degree of C, which is like too much to handle.
That is true. Might be true. Yeah. I'm just
I have
surprised so many circles
ways to
are not.
vary this, but I don't want to do it.
I am
I was
surprised.
wondering when we'd get to this point when Aritra proposes a match. I was wondering when this would come.
Why is there
No,
not single nickel point? Like, yeah.
like too many circles are bad.
AKVR, AKVR. Yeah.
We are getting nowhere.
Can I just draw the cyclics?
Oh yeah, the cyclics
Don't I
already.
think like
Which
You can
cyclics?
copy the diagram and draw it separately.
AQBS. I mean, it's
Which
not
one?
angle
AQBS.
AQ,
AKBR, AKBR. The thing we
AKVR.
AKVR.
AKVR already are there. AKVR is already there. What we're trying to
like
show is that these three circles, AKVR, ARUS, and AKL, they're all in fact the same circle.
no, I mean like the lines.
Wait,
Oh,
Ronit,
the
when
lines.
did we show P lies on the red circle?
P lies on the red circle. Oh, okay, yeah.
who showed that?
Come to the other diagram.
Yeah.
Yeah. So AM times AY, okay.
AM times A. What is Y? Okay, yes, Y. Yes,
Yeah.
yes.
So AM times AY, that is equal to AQ times AB. So like actually what we're doing is we're defining PQ to be on the circles, red and green circles, and then we're showing the
Sure.
midpoints.
Okay. AMAY equals A.
Aram, it's written on the left, like I've written the thing.
Oh, okay. So I'll read it. AMAY equals ANAX.
This thing, or rather just look at these two. These two things are equal, yes? These two circle things.
Yes. Okay, by the ream thing.
Uh,
MX and Y is
just for.
concentric. Sure.
So AB is half of AB is twice of AM.
Okay,
That
and then
means
AP
AQ is twice. AQ is half of AY.
Okay, sure. Yeah.
That gives you the midpoints.
Okay.
Yeah.
What is the radical axis of the black and the green circle?
Black. Which
Or
one
black
is
or
It
red
is
black?
like
circle.
CW,
Which
but
black?
like we are not sure if it is CW.
CW means like C. W is we have proved, right?
That
W
is
is a
red
radical.
and blue. Like it's red and blue, red and green.
But I think W is like a radical center, maybe.
It is like it is equivalent to proving RNS. But
I'll be back.
So if we prove CX is radical axis or not CX, CY is radical axis of the green and black, like we are done, kind of.
if we
With
prove
the claim.
what? Yeah,
CY
yeah.
is the radical axis.
Okay, we have till now been focusing on showing that W lies on.
No, but
Like,
if we want to prove CY as radical axis, why don't we just do linpop? Like we know the good points, like other
sure.
POP with
Like we
this.
can just like finish Limpop. We've been coping here for like longer
Yes, I
than
think I have figured out enough POPs that we can do linpop at this point.
exactly. Like all the ratios are Menelausable or like POPable or whatever. Sure.
POP-able. Okay, that's a new word I have.
Yeah, trust us. It's a good word.
Popable.
topic. Wow. Okay.
Wow.
We know power of C with respect to the two circles. We know power. Like,
Wait,
y
by
to
the, are
the
you assuming like
We don't know. We don't know.
no. We know power
What-
of C with respect to both the circles.
What is the power of C with respect to AKF? You don't
हाँ
know
नहीं
B lies
wait.
on AKF.
Yeah. Wait.
Limpop is very bad at it. I mean, if you want to push. Look, we
I
already
forgot.
have SRKL cyclic because of that, the way we defined W. And we
wait,
also have
AKL is
AK.
not bad. Like AKL is
What?
actually like CV into CA, right? Like
No,
But
we
we
don't
don't
realize
have that
on.
V
we
lies
don't
on
know
the
that, but like it's
Yeah.
not bad. What I'm saying
Wait,
is
Debanchan, how do we have SRKL?
Because S is I'm defining as the intersection of CY and the green
Oh,
circle.
because W lies on the rad axis. So like WKW are
Yes.
equal to WLWS.
Okay,
Sure,
wait.
sure,
So
CY
we have
times
no, not
green.
CY terms.
CY and green.
WS times W. Yes,
Okay.
those.
So
That's us.
WX.
Devaltion, do you think XYKL is a cyclic quadrilateral?
What? Yes.
XYKL.
XYKL.
Is that equivalent to showing that,
I don't think so.
or would that be too good to be true?
That is good enough. I mean, I don't think that's true.
That might be actually too good to be true. Never mind.
We got anything?
Nah, not really.
Okay, so we have
I
SRKL.
so wish my
Okay, I see.
concept would be better.
We have what?
We have SRKL.
What?
SRKL.
SRKL. You do?
Yes. So SRKL, AKVR. Wait.
How do you have
ARKV
SRKL?
by power of point at W.
So WS times WL is equal to
Okay, and we
what's
have
Yeah, that is like peak.
ASLU. Interesting. Okay, we need to combine this.
We have SRKL and we have AL.
Wait, I'm sorry. What's your POP? You have WR times WK is equal. Wait, no, sorry. WS times WL is equal to WX times WB. Then
Yes.
what?
Wait, WXWB and then that is WSWL. What?
No, yeah. WX times WB is equal to WS times WL.
Yeah,
What
but
is WX
also
times WB?
W is on the rad axis of red and green, so that's WIWL.
WR times WK.
WYWC, I mean.
WR times WK. Yes.
Yeah.
So
Wait,
Sure.
yes,
we
you
have
do have that.
UKAR.
Wait, if we have SRKL, can we get SRUV now?
Wait one
SRUB.
second.
Yes, wait, no. Does SRU finish? No, it-
SRKL. SR.
Ridhiman,
SRUV
look at this.
needs to be true. But
Wait,
by
we have UKAR cyclic, right? Where
Wait,
U
hold
is
on.
the
I'm just.
midpoint of BY. And we also have ARVK cyclic. So ARUVK cyclic.
What ARUVK? कैसे?
ARUVK.
Because we have UAKR cyclic, right?
Oh, that is
Aditya, are you
smart.
trying Limpop?
I am trying Limpop, yes.
Okay.
We have UKAR and also now we have V. They lie in the same circle.
UKARV.
Devachan, could you just
Yes.
repeat
Okay,
that from the
sure.
start?
So we have BK times BR is equal to BY times BM. That is
Is
equal to
BY times BM is equal to
BU times BA. So we have
Yes.
UK.
No, we have the
cyclic.
cyclics. We have ARKV. That's what you're saying, right?
Yes, and also we have ARKV. So from that we can combine and say UKARV is on a circle.
that is peak.
And
Can
we
we? Wait, no,
Yes,
hold
we
on.
can.
Yes.
Wait,
We
listen.
can.
You have
Tell.
this thing and you have this thing. How does that imply that they all
No,
lie on the
उसमें ASL नहीं था.
Also, ASL नहीं था. Also, we have U, V, and A constant, right? It means they are not dependent on.
AS?
I mean, we can
they
do the
are
same
not-
thing with
Wait, I
constant
think
in
the
the
issue
sense.
is two people are talking at the same time. I'm not understanding. See, what I've understood till now
fine.
is that you have this cyclic AKRV and you have ALSU. What now?
ALSU. So
We have the stuff written in black. Like these three
Okay, wait,
things.
let me repeat from the beginning. It will be nice. So we have AKVR cyclic, right?
Yeah.
And we also
Yes.
have UKAR cyclic.
UK.
Oh, I think I got it. Yes.
Yeah,
of
yeah.
course.
I also got
So-
it. So
So we have
combined to say that,
UAV.
yeah,
Do we have
just take
UKAR?
UAV.
like
Okay, let me just write all the
UV.
points.
Yeah, so like
A
UVRAK.
R S K.
Yeah, now just focus on UAV. We have shown RK lies on both of those, like on that
Yeah.
circle. So similarly, we can sort of show that SL will also lie on UAV. So
These
all of these
7 points are
cyclic.
concyclic. These 7 points.
Wait, Ronit,
Yeah.
why is
1, 2, 3, 4,
UKAR
5.
true?
There's 6 points, right?
UKAR.
Oh,
UKAR.
what is that?
UKAR. Okay, fine. You see these three in black?
Which three? Yeah.
You see these three in black?
Yeah.
We
yeah.
also have that SRKL actually.
I mean, that's also written already.
Okay, yeah. Sorry.
Sure.
Yeah. So once you have these two, then you see the RK. Okay, wait. You know what? I'll
2
underline
points
these
doesn't
two.
give anything, right? You need 3, I think.
Sure, sure. But like you have once you have pairs of 2 points across all three of them.
Okay. What does that give? No, that doesn't give anything.
No, wait, hold
Okay,
on.
hold on. Wait, just a second. So
Uh,
Devachan said that we have UVRAK, right? UVRAK.
Yes, yes,
By symmetry, we should also have UVSAL.
yes.
So the radix of the
that gives you this,
circles.
no? That gives you this box thing.
Wait,
Yeah, so
wait.
that gives us those
Forget
7
all of
points.
this. We have only these 3. How are we like getting other stuff?
Wait, how does that give us the box thing? If it did, then like AKL will RNS lie on AKL. Done.
After these 3, how are
Wait,
we
what?
proceeding?
Where's the box? What is the box?
I
Box.
It's fine.
deleted
It's
it.
gone. It's gone. Like let's just work
It's
back
fine.
all
We
the.
already know what that is. We don't need to write it.
Yeah, there's a
After
lot
these
of
three-
mix of ideas. We should just like work on these three and get it down.
Yes.
UVRAK कैसे?
Arey, that is what Devachan said.
हाँ,
No, but
वो तो
that's
है
not
ही.
true.
It
How?
is
How?
UVRAK. It should be.
How did we get UV?
Devachan can explain.
Okay, so you have ARVK, right?
Yeah.
And you also have UARK.
No, we do not have UARK.
We have, because, okay, R is the intersection of BX and the red circle. So
BX was
from
A.
so from the power of point with respect to B, so we have
Yeah.
BK times BR is equal to BY times BM.
BK
And
BR
BM
equals BY BM. Yeah.
and BM is half of AB and BY
Yeah.
is twice of BU. So we
Okay.
have BU times BA is equal to BY times BM, which is equal to the power
BU
of
BA
B with respect to B.
equals.
What? Wait. So like हो गया. UVAR.
Okay, so we also have UKAR. Okay.
हाँ तो हो गया ना.
So
All of these lie on the same circle. So like
नहीं,
AKLRS हो गया.
We still
Okay,
have
once we have
only
UKAR,
UK.
we are done.
Wait, Riddhiman, we still have only UK. Sorry, UV.
हाँ तो
we
AV
have
है ना इधर.
UVA. A है ना
अच्छा
वो।
हाँ नहीं सही है.
सही है. Let's go. Finally, finally we got RNS. Like, क्या कर रहे थे अभी तक पता नहीं.
Wait, were we
Wait.
just like going in circles without actually doing anything?
Wait,
Wait, ये तो
Like,
5
very
मिनट
easy.
पहले हो गया था।
No, we're not
Okay.
really going in circles.
Oh, हाँ, like it's like
We are done.
yeah, like
Okay.
Like, we
RNS
got
are
this.
done.
We
So
got
finally,
RNS.
ON, finally we have
So
to
we
go.
have
how
these
is
7 points.
AUVKL? What did you do?
Long story.
Loud.
Okay, long story short. Long story short,
No,
you
just
first
like
show that.
what idea you used.
I mean, okay, first you show that UAV and RNK are cyclic. So since U is the midpoint of BY and V is the midpoint of CX, so it does not really depend on R and K, right? So you can also do the same thing for S and L. So you will get U, A, V, S and L are cyclic. And now UAV is like the fixed
Yeah,
3
if there
points
is
here.
U. Okay.
So yeah, so long story.
Wait, but
We'll tell sometime later.
UAV does
I
not.
think whatever we have now is written. Like
I
you first
understand.
look at
But like
these three, then you get those two, and
Okay,
those
wait,
two
what is
give you
Aditya
that.
saying? What is
okay,
Aditya saying?
UVAR. Okay, no, that finish. That does exactly. Yes.
Yeah, like this is step 1, this is step 2, and this is step 3. 1 implies 2 implies 3.
You know what? Let's finish this problem.
Let
It's
us
like
exactly
40
भाई कब
minutes.
से कर रहे हैं? We are
Exactly.
doing-
It's 6 बज गए. It's already 6.
We have spent an hour and a
We
half, and we
spent
have
10
done
minutes
like
on the first one and then like
exactly
Like
first
P1
one
was just easy.
randomly.
Then it was.
Even when everybody cooked, here everybody getting cooked. It's okay. This is like
I will
zero.
quote that later. You know what? I'll just like put it over here in the middle.
OM equal to OS. We want OM equal to ON. We know OS equal to OR.
We
oh
also
okay,
know
so
P
now we need to
equal
like use stuff
Yes.
about O.
Yeah, we
Oh,
need
but
to
O
use
is the
stuff about.
center of like this, like the best circle ever. So
Okay, sure.
7
Best
points.
circle ever.
come on.
And then you and me.
Wait. What
This
is the
actually
power
cool.
of?
This is
हो
actually
गया
cool.
ना? This is हो गया, right? Because power of M with respect to black circle is M
Power of
times
M and
MA.
power of M equate. Sure.
Yeah.
Oh yeah, so
they are
OM
the
square
same.
minus whatever that radius square is equal to ON square whatever that radius.
Can you
I mean, we
Right.
just need to show MU times MA is equal to whatever the hell that is.
We
NV
don't
That
know
times
is
much
MA.
surely
about M and
cookable.
N.
That is surely cookable because U is the midpoint of something. We basically
Yeah.
everything is cookable at this point. Oh, now it's just
Okay,
like one like
NV.
pop or something.
Wait, we need to
times
show
Do
this
we
thing.
need
AYA.
Wait, what do we need to
Yeah.
show? We need to show this thing
This
is
is
equal
this is like symmetric. Like wait.
to AN
MA
times
ME.
NV.
NV.
NV. Okay, fine.
Basically
So
compute MU and NV. If we can compute
Wait.
those, we are done. For that we need B. For the first we need
Ridhiman, let's just like
Wait.
what do you
Slow
call
down.
it? Shut up and calculate. Yeah, let's do that.
Okay, sure.
No, that's a quote. Although I do
Bye.
mean it to you, but it's a quote.
Code by.
Code by Ronit.
Oh.
No, it's quote by already been in existence.
देखो AY AB equal to 70 like BY AY.
What is UM?
UM is half.
This is
No clue, actually.
No, UM is not nice.
minus
Still.
this is BY, so BU is 1/2 of
It can
this.
like someone Ridhiman, can you do this a bit down, perhaps?
Oh, I'm just doing everything in one line. I'm like
Yeah.
Oh, Aritra, also like you should probably show
Yeah,
At
yeah.
this point, do we
stuff.
dispose of with R and S?
AB/2 minus. कहाँ गया यार? ये रहा.
Is the live stream
B-
still on?
UM.
By
Half
the
of
way,
AB.
I got like V is midpoint of CX. Not V is midpoint of CX. Okay, V is midpoint of CX. Right.
No, that we already knew, right? Oh no, we did not know. Or did we?
Oh,
know?
we are done. Let's go. We are done. Let's go.
Yeah,
Even
no,
I got. Wait,
Yes.
just a minute.
What?
I mean,
What?
I'm too lazy to do the
Something.
calculation. What's the calculation?
Oh,
Wait,
like
wait,
just look at
it's-
just look
Okay,
at
I
this.
got the import too.
Literally just like length chase, like देखो.
Okay.
Okay, look at this. Yeah,
Ronit,
this is
yes. AM UM is equals to AM times
Okay,
half of
Ronit's is better. Mine is random.
How is UM half of AY?
UY.
Proper.
Yeah, UM half of AY is. Wait, what?
UM. Is
No,
it true?
I'm
I
not
don't
sure.
think- That's not true.
Wait,
That's not true.
Like it is true, but like it's not obvious. देखो. U.
Wait, is
See.
it true? Oh,
हाँ,
Okay.
it is. देखो just.
Yeah, just
I
say.
guess that's true.
AY, A.
Oh हाँ,
Well.
it's like देखो. UM is equal to. Okay, I don't
Okay,
know.
yes, that makes sense.
It probably makes sense.
UY is okay. UM is equal to UY plus YM. UY is equal to half of BY.
Okay.
YM is like what
AM
is
minus AY and
AM
minus
AY
AY.
minus AY. AY minus AM and AM is half of AB. So like you do the computation, it will cancel. Trust.
Okay,
Will
I'll
Wait.
trust you. I'll trust you.
Okay, wait.
I did
Let's
the
write it.
computation, it does cancel.
Let's
Just
write
do
it.
Yes.
It's fine. Let's just do
Yes.
it for like
Let's add it.
fine. What do you want?
UM? Oh, okay, you read it.
UM is going to be equal
UY plus YM, which is half of BY plus YM.
Shit. Why am I?
Half of BY plus AY minus AY minus
By
AN,
the I have A UK LV by POP LinPop also.
which is half of BY plus
Half of AB.
half of plus AY. Okay, now what?
Half, which is going to be half of AB, BA minus BY, which is going to be half of
BA
AY
minus BY, half of
minus
of
half of AY plus half of plus AY is equal to
yes,
half
yes,
of AY.
yes. Sure.
Oh my
Okay.
God. You know,
Yes.
I am happy this is a very nice solution, but I'm sad that there was no angles here.
Why?
And
It
then
is
that's
just POP spam. Like I have
AN
genuinely no
times
idea
half of
what they have there.
AX.
Yeah.
Wait,
The
what?
main
No,
thing
no, no.
was S and R. Like
Yeah,
you
How
use
did
them
how
as
did
code
this
now.
motivated. I think
happen?
everything is motivated. It's just why no angles.
UV is like you
AY.
get it after a long time. I don't think UV
Ah,
is
yes. No,
really
no, no.
motivated.
So like
No,
see,
UV
Run
is
it,
good
run it.
for like all POPs, I think. Like you can just
UV
divide
is
it.
motivated once you get PQ. I understand that because PQ is
Yeah.
like Indian midpoints.
Run it, run it. Why is
Yeah.
half?
Also
Why
R and
is
S paid off. Damn.
this true?
Or you
Why
have
is
good
what
diagram
true?
and you draw AKL and
AM
then
times
UV lines
AY,
there.
AM times AY is equal to AN times AM because X, Y, MN is cyclic, right?
XYMN AM times sure. Okay.
And
AN
you're done.
times NB. Okay. And what does that give us? AN NB.
AN times AX and like half of AX is NB by the same computation.
Okay, after
Oh,
this,
worked out.
once you get this, what do you have?
Oh, okay. Now that you know that the powers are the same, you're going to have like
AMUM
OM squared
equals
minus like give R, yeah, R squared is equal to ON squared minus R squared, where R is the like
oh
circumradius of that.
okay. Done. Fine. So we're done.
Yes, so OM is on.
Okay.
Yeah, this was done.
Yes. So for everyone
Move on
watching
to problem
for
3.
a
I
long
never
time.
Should
I never
we?
checked any chat.
Should,
What
should
the
we
hell's
tell
going
the
on?
solution like from the start again, like
Yeah, we
recap
should
the
probably
solution?
summarize the solution.
Oh, somebody,
Rithiman,
yes.
hold on it.
Okay, it will. Okay, I will do the honors.
Of course, yes.
Please do.
Okay,
After that, you
so
can end with this wonderful quote above, which you yourself said, but you can
what
read.
quote? I do not see a quote.
We should go a
Go
little bit
just above
faster,
the
I
problem.
guess.
Ah,
But
okay, I see. Let's do this. Okay, okay. So first, let's go back to the old problem. Here, note that by first we defined x and y is equal to bk cap ac and like cl cap ab, and observe that due to angles bx cy is cyclic, and then uske baad also due to angles we have bl nx and ckmy to be cyclic. Like great, this is just great. So what we do is we read instead of like defining the figure in terms of angles, we define it in a more sane way. We define x and y first, then we define k then we define k is equal to the intersection bx cap cmy, and similarly for L. So we have a same thing to work with, and then after that, like we also define P and Q as like intersection of red circles with AC and symmetrically. And then uske baad we have this random insight that R and S, like this should be the power. Okay, hold on. First, before that, first we observe that A lies on the radax of blue and green and red circles, and W also lies on the radax of the two circles. Uske baad we decided that R and S are good points, and we will try to show that they lie on these radaxes respectively. But before that, in order to prove that, we define V as the midpoint of Cx, and we do that because we observe that proving the existence of R is equivalent to showing that V lies on this AKL circle. So we define V, and we define R as Bx cap red circle. So V does lie on ARL, and then uske baad we do like symmetrically for S, and then uske baad a power of point at B proves that A R like kya tha U like kya tha UV RAK are cyclic, and similarly UV SAL are cyclic. So all of the like these two circles are just equal to UAV circle. So we have that, like, so basically we get the existence of R and S and the existence of U and V, and then uske baad finally we decide that showing, instead of blindly showing OM equal to ON randomly, we show the power of M with respect to the black circle is equal to the power of N with respect to black circle, because the radius is same. And then in
Power
order
of M with respect to black circle is power of M with
AKL.
respect to black. Okay.
Yeah, AKL. So that uske baad it's just like some random length chase. I had different random length chase. Ronit had a more good looking length chase. Yeah, that's it.
Couldn't
So
have
in
put it better
conclusion,
myself.
this problem was poppable.
This is poppable. This is just pop. We have not used angle. We have not used anything.
The only problem that
Yeah,
has
we use
angle in the
angles.
problem does not use angle in the solution.
Exactly.
Exactly.
Defined is angles. It is not at all angles. कुछ भी है.
Also, by the way, I don't want to do a P3 right now. Let's do P4 and P5, I guess.
Let's do combi.
So
No.
No,
let's
let's do before. It's
We
fun.
should go
Let's do
problem by
P4.
problem. I'm pretty
Yeah,
sure.
can we try? Okay, what is P3?
so
Is
to
it a
conclude this, like we'll just put it in a nice little box.
yes, sir.
Great.
Just leave it as it is. Okay.
No,
never
no,
mind.
no, no, no. Like this is much more.
Try P3, like we should go to
P5, oh, that is P5. P3 is a random combi with like random stuff. P4 is literally kuch bhi hai. Wait, is P4 like, wait, so what is
P5
P4?
is so good looking. I want to do
P4 is
P5.
geo combi.
Bro,
Let's-
P4
let's-
looks like it might appear on IMO one day. Oh, P6
I don't
is
want more.
P6 looks like a goated problem. It's like integer sequences. Okay,
It's anti. I'm happy
it
to.
is anti.
But we should do problem by problem.
Let's either do it
We're
P3
doing
or P4.
P3.
I think
P3
so.
it is.
No.
P3.
Yes, sir.
Okay, but what if we spend another 2 hours on P3?
It's
That's why
okay.
we
Then
should do
we'll
P4.
leave and we'll
We'll
just
not
go to
spend. Like
P4.
Yeah.
if we like see
People,
no
can you check
progress,
the
we'll
chat?
move on.
Exactly. No progress, then we move on.
People, can you check the chat?
The chat.
You, I can't.
Yes, you should. You absolutely should.
Okay. No, Tanishka is saying no. I see.
Wait, no,
Okay.
I didn't say no.
I see. Okay, I'm getting the hat.
Okay.
What
Let's
problem are we doing?
be
P3.
on P3. Let us
P3.
do P3. Great.
Can anybody paste it here? Problem.
Right, let's move it there.
That should be Haronit when you do the things. Yes.
We should
sir.
respect some combis. Great.
Let us take off length 1 and divide it in. No, that-
Wait, I think before we start this problem, we should all have a estimate on how much time we'd actually be taking on this problem.
2 hours. 2 hours.
Okay,
I don't think
Ridhiman
we
is
can
two.
finish it. Probably
take-
like part of it. I don't think we can finish it.
Okay,
Ah.
Ridhiman is 2 hours. Aritra is
I
like
would say
infinity.
1 hour and then we move on to P4 and P5.
Yeah.
Yeah.
Actually, I think that's a good idea. 1 hour here and
No,
then.
I have heard before is not hard, so it shouldn't take us much time, I guess.
Wait, Devasan, do you think
no.
but like totally, how much time on P3?
Yeah.
What do you think?
Me forever.
How much?
So
Forever,
you are
forever.
saying we will not complete this problem?
4.5.
Oh no, for me and
No,
saying
like for
4.5?
us.
I
forever
see.
I
It's
told, but
it's very interesting.
Okay, wait,
Okay.
let's
Hold on.
read the problem first. Why are
Fine.
we estimating before reading?
Interesting question.
What?
I have no answer to that.
This is. Oh, what is this, bro?
Wait, like we have to maximize the length of their own pieces. So we need a function to.
why isn't the first
It's
10
not infinite. Like we will not do it here because after 1 hour
why
we
is
are
the
moving
first
to
10
another
not
problem.
italicized?
So
That is so
okay,
sad.
Liu goes first, right? So Liu can get at least half the stick. So like
Wait,
half is
first of
Wait,
all,
what?
It will be a
rename.
little more than half. I think like if n tends to infinity, it will be half.
yeah, something like that. But like at least half is guaranteed because like Liu can just take the
Okay.
bigger of the remaining pieces. Lamar.
I think n equals to 1 is 2 by 3.
What?
But what?
Oh, acha. Okay, sure.
Wait,
Like
It's
Liu
Liu
goes
going
first.
first. Okay, Liu is
See,
going
yes.
first.
Okay, I'll prove why it's n equals to 1, 2 by 3.
This is interesting.
The problem
take
statement is
this.
quite simple.
See, you divide it in the 1 by 3 part, okay?
okay, I see 2 by 3. They're like
And the reason you don't do half is like you can do like a delta, like a epsilon distance here, and when you choose this part, he will choose this part. So you get like half plus epsilon. That is not good. So you do like this one, 1 by 3. Now, whichever he takes, you take the bigger one and take the, if he takes this, you take this one. So it's 2 by 3. And if he doesn't take this, if he doesn't take this and take this, you take this one because this is greater than 1 by 3. And this is like 1 by 3. So you
Okay, so
have
that
at
Oh,
least
so
1
like
by 3.
odds ke liye we already have an estimate. I mean, like we could have just done this. Like we have we have three numbers A and B and C summing to 1.
And this
And
one
then,
is
like-
not good, like greater than 1 by 3 is not good because
equality holds.
because you can like copy the move here and copy the move here. Basically, whatever you choose here, he will choose here. So he has more than 1 by 3 if you have more than 1 by 3. And if you have less than 1 by 3, the remaining part he has, he just halves it. Basically, if you have do like 0.2, he does like 0.4, 0.4. So one of those is like greater than, like two of those are greater than 1 by 3. So he gets more than 1 by 3, so he gets less than 2 by 3. So n equals to 1 is 1 by 3.
N equal to 1.
So I think we have like something
by
for
3,
all
sorry.
two in
2 by
general then. If we copy the copycat.
Yeah, the copycat thing might be useful.
I'm just trying to guess the answer. Is it like, I
1
don't know.
minus 1 by 2n plus 1.
It's like
Constant.
2n moves, right? So it can be like 2n n plus 1 by 2n plus 1, something like that.
N plus 1 by 2n plus 1 is better.
Guess one. Let's try to do n equals to 2.
Yeah, like so don't we have
Four
for
cuts.
But n
odd
equals to 2.
plus
Then we have to
second?
do like by 5s, right? Can we get 3 by 5 in n equals to 2?
Okay, let's try. So here the optimal thing was to place it at 1/3. So there, let's try like,
So we have two cards, so we can place
And
on like
6.
one thing in the 1 by 2, 1 by 5, and another thing with a 3 by 5. So there is like three things with 2 by 5, 2 by 5, 1 by 5.
Wait, what was the argument for 2 over 3?
So if you do 1 by 3, do you see why like it is best for the second player that it is 2 by 3?
Why?
Okay, I'll show it again. So you do cut at 1 by 3, okay?
Sure.
Now, whatever he cuts, there is one part which is like greater than equal to 1 by 3 and a part which is less than equal to 1 by 3.
Sure.
You take the part greater than equal to 1 by 3.
So he'd like
If
to
you
make
take
them
this
equal.
part, you take this
Okay.
part, so this is 2 by 3. And like, because this is less than equal to 1 by 3, this is greater than this part is greater than this part. So you have greater than equal to 2 by 3. You see that?
I got the 2 by 3. Yes.
And if you do something not 1 by 3, something like that, he makes the same copy here. Basically, if this is 0.
Yeah,
Two.
I got it. Yeah.
Okay.
So you're going to half that thing and you're going to take that one and
Yeah,
that
half
one.
the larger thing. Like if
Half
you
the
have
larger
0.2, you
thing.
don't half
And
the
the
larger
other guy
thing.
wants
And
to
yeah.
maximize. So he'll just
Wait,
like
I
make it a
got
1
he
by 3
can
to
get
start
1
with.
by 3. What if he doesn't do that? Like,
Yeah,
Okay. See,
okay.
if you do 0.2,
fine.
then he does like 0.4, 0.4. So halves the maximum thing left. And like
Half, okay.
he can choose 0.4, at least one of the 0.4s.
But you have 0.6. Okay. Makes sense.
Yes.
Hello,
Like he
can
has
you
more
hear?
than 1 by 3. Yes.
yes, you can.
So for n equal to even, don't we just have half because of copycat?
No, you don't.
How
Right?
exactly?
Like
Because
whatever.
Okay, wait, Tanishka, what's your argument?
like you can do
Sorry.
more strategically placing. So I'll show a better than half. Okay, see the
Okay,
1
like
by
you
5.
can do better than half. That's fine. Okay.
Yeah, but it's like very slightly better. Like you are not placing at the exact same gap. That is like pretty bad way. Like symmetry is not a good in this game because
We can
like
get
he can
better than
copycat.
half.
So you want to avoid symmetry.
Wait, what is the order of the marking the points? Is
All
it like
in and
1
then all
point
in.
Liu, 1 point like the other
No,
guy?
it's all
No,
in and then
like
all
the
in.
player 1 does all the points first, then player 2 does all the points after that. And like when he chooses, they alternate.
So Liu
okay.
is the first in every situation. Wait, should we just rename Liu and Xiang, whatever?
Just
and
do
me.
AB.
Aloo and Batata.
So it's 2 by 5, 2 by 5, 1.
Yes, it is this.
Let's do Ali and Shalin.
No.
Ah,
Aloo and batata. Aloo and batata.
let Lamar revenge things stay in Lamar revenge.
Okay, 2 by 5, 2
Aloo
by 5,
batata
1
was
by
also
5.
Lamar revenge.
That is last year.
But why are you using 5 for 3? Oh,
Because
okay.
like
Because
what will
we're
it
thinking
take?
it's
So
3 by
duplicate, right?
5. Like that is our hypothesis for now.
Yeah, exactly. So what if I do two cuts here? So one of them less than 1 by 5, one of them greater than 1 by 5. So first the 2 by, like A gets 2 by 5, B gets the bigger than 1 by 5, C gets, like, then again A
B
gets
does 2
1 by
cut,
5.
by the way. B doesn't do 1 cut.
Oh, acha. Hold on. Should I make another cut here or something?
Wait, 1 sec. We'll need to case bash.
Wait,
Wait,
what
one
is
Just
the cut?
sec.
Red
Who
is the
is-
cuts that A is making.
Yeah.
Okay.
Wait, I'm
Okay,
just
why are we
copying this
working
thing
on
so that
3
we
by
can
5?
case bash effectively.
Just
One
case
is
bash
that-
in head. Don't do
One
Why are
is
we
anything.
that
working
thing and
on
one is this
3 by
thing.
5? Aditya, why are we working on
Yeah.
3 by 5?
Like that is our hypothesis that it's n plus 1 by 2 n plus 1 without any
Oh,
prior
oh.
justification.
Okay, fine.
It could always be Fibonacci for all you know.
It's
Yeah,
not
because
Fibonacci.
interesting.
Trust me on
No,
this.
that would be
Wait,
interesting.
can we just like find an argument which shows that the second cut should not be in the same 2 by 5 block?
I think
And
we
like
that
let
can,
would
us
be-
find the optimal construction first. Then we'll think
yeah,
about
case bash. Let's just case
cut.
bash here. So
Oh, I
like
get it, what you are doing now. Interesting.
B plus.
Okay,
B is
I
greater
don't
than
think
B is greater than C is greater than a fifth is equal to A, which is greater than D, which is greater than A. Yes.
see I'm pretty sure you can't do 3 by 5 like with this strategy.
You
Why?
can't do 3 by 5.
Yes. Like I have something for B. Like with this strategy, you probably can, but not with this 2 by 5, 1 by 5.
What do you have for B?
I'm drawing another diagram.
Oh, I mean like same में किया होगा फिर.
See, you have like this 2 by 5, 1 by 5, 2 by
Yeah.
5, 2 by 5, 1 by 5. You do like 2 cuts in the 2 by 5, like 1 at half. Like so this is like 1 by 5 and 1 at 2, 1 by 10, 1 by 10.
1 by 10, 1 by 10. Okay. I see.
So
Right.
now the
So you
pieces
take the
are
2 by
1 by
5,
5.
he takes 1 by 5. Wait, no, sorry.
No, you
Wait,
take the 1
no.
by 5.
No. Wait,
A,
you do
A.
1 by 3. Sorry. Like
What?
1 by 3
What?
of this.
So, wait, 1 by 3 of 2 by 5.
So, oh, you
1 by
divide
3
this
plus
into
2 by 3. No, that is no,
1 by
that
3
is
of 3
bad.
by
You
5.
can.
I think this strategy might just work. I'm not sure, but
Let me think.
What's your strategy?
Okay, you can't. See, you do 2 cuts in 1 by 5. Like if you take 2 by 5, he will take the another 2 by 5. So he at least has 2 by 5. And he has one other thing here. So like you do 1 by 15, 1 by 15, 1 by 15 here. So you have like 2 by 5 plus 2 by 15. So you don't have 3 by 5.
Yes.
Two cuts
You
at
do
1
2
by
cuts
5,
at
which
1
are
by
like
5 with same space.
1 by 3, 1 by 3.
Like 1 by
Okay,
3 in
so
1 by 5. So 1 by 15.
2 by 5 plus 2 by 15. Okay, that's what you're saying.
6
So-
by
And what is that? 8 by 15.
8 by 15.
Okay.
We don't need to calculate it. It's less than 3 by 5.
No,
Is-
we
is
should
it?
We should,
calculate
we want
because that
C.
might be the new bound. We should calculate.
No,
What
this is
is
like
this?
not at all optimal, I'm pretty sure.
That's
wait,
40.
what?
That's
Okay,
45.
hold on. Okay, you are doing cuts in 1 by 15. Oh, sorry, no.
Like 1 by 5.
1 by 5, yeah, sorry. I thought 2 by
Okay.
This is
The whole
this is
thing.
very asymmetrical in my opinion. Like
But like, if
we
we're
can't do such
dividing,
asymmetrical.
Yeah.
if you're dividing by like denominator of like divided by D, there should be a point when like going ahead of D gives you a lesser bound for C, and then going behind gives you a lesser bound for C. Though like D has to be perfectly in the middle, or are there like
What?
many values that satisfy?
Wait,
Like-
why aren't we
So
doing
are you
1
saying
by
ki by
4?
symmetry the cuts should be in the middle of the pieces?
No, no,
I
no.
don't think you can do any cuts which has the same length. Like the bigger cuts can't be the same length. Just because if you take one bigger cut, he takes the other one. Like he doesn't do cuts in the bigger one, he does cuts in the smaller one. And like if you take one bigger one, he takes the other bigger one. So it's just not optimal to do this construction where like most things are same. You need to do like one things to be large and like other things to be small.
Wait,
That's how
That's-
you should
what
No,
if
I'm
just
not
for
saying that. That's not what I meant.
What if
No,
we
I'm just
start
saying what
3 by
should
4,
the
1 by 8, 1 by
idea
8?
for optimal construction.
why can we just follow normal things and try 1 by 3 like 1 by 3 dividing into thirds basically?
There is
Sure.
no way 1 by 3 works. Like
Why? Why not?
it's too symmetrical to work.
Maybe the answer is just the same for all.
Nahi.
Nah,
Like
that is
1 by
Let,
you
let's
do too
just
many
try.
cards, right?
Okay,
No.
well, let's try what happens.
You can try 1 by 3.
What do we do?
Like
Case
I'm
match.
thinking if there is other way of construction. What if we do 1 by 5, 1 by 5, 3 by 5 instead of 1 by 5, 1 by 5,
3
2?
1 1 could work. Like 3 1 1 is another idea.
1 by
Yeah.
5, 1 by 5, 3 by 5. Okay.
Yeah.
Like 1 by 5 this side, 1 by 5 this side, and 3 by 5 other.
Okay, that seems.
हाँ ये क्या बना है?
What?
So you add one more here. What do you call this? 3 by 5 divided
Okay, but you
Wait,
can't
don't-
do this because what he does is he like takes the half of the thing
No, like,
and like does the epsilon cut. So if you take this, he takes this. If you take this, he takes this. So he like
Aditra.
divides the boat into perfect symmetry.
भाई
Aditra, you do
Wait, what
you
is
said
the
a lot of
epsilon?
things. You said a lot of take this and take that. No one understood what was
Okay,
this.
I
see.
did not see what you did.
Okay, come
Wait,
here,
can you
come here.
explain the epsilon thing? Like, what is the epsilon thing?
Yes, I'll explain. So you have 1 by 5, 1 by 5, 3 by 5. Okay. So what he does is he
Why are
goes
there-
to half of the board and cuts two pieces very close to each other.
But
Okay.
Oh,
where is
I
the
see.
So
original?
now
Oh,
if he takes this piece, you take this piece. So he
Mhm.
divides the boat into a symmetry. If he takes one piece, you take other piece. So both of you get like close to half, and the player one takes this epsilon because so he has like 1 by 2 plus epsilon, and other one has 1 by 2 minus epsilon.
This gives you
This
2
is
over
not
5.
at all optimal.
why can't this wait? Surely this can work.
no,
Yeah,
but
this
we
works,
put,
right? This gives you 2 over
but we
5,
put 3
doesn't
by
it?
5 in the middle, right?
This
Why-
doesn't give you 2/5. This gives you half.
no, what if we have this thing, like we have
What?
this box and the player one cuts very thin slices here. So whatever
Sure.
the player two does here, we can sort of take big chunks out of this. So the player two would want to optimally slice it into equal 3 parts, right? For n equal to 2 case, this one. So
I mean, all right.
I mean,
Sure,
okay.
But
fine.
see, if he cuts into 3 parts, the point is
Yeah.
he gets also a bigger part, right? If you cut
Yeah,
into
he gets a bigger part, but we have 2 bigger parts, right?
Yeah, so like it'll be more like
So we sort of here have another thing where only player 2 plays and it wants to maximize its output. So these two basically does not matter in the problem anymore because they can be as thin as we want. Right.
Mm-hmm.
So we basically are reduced to the problem of having a board and we are having 2 markings both by player 2 such that player 2 can maximize whatever it gets. Player 1 is out for now.
But does that help player 1 is the question.
The thing is, we player 1 still has the first choice of whatever it takes.
okay, so what player 2 does is basically take the half of the board and like clutch two like very similar, like with epsilon. So he takes like
Yeah.
there are only 2 bigger parts now, not 3 bigger parts.
I mean doing epsilon is going to like he will just copy you. So like you will get close to half.
Yes,
and we
exactly.
want to show ki it's not close. At least for the smaller ones, it's not close.
Half and 3 by 5.
But,
Oh, there
like,
is
do you
a
see why
reason.
does 1 by 5, 3 by 5, 1 by 5 idea doesn't work because of the symmetry
Yes.
Yeah,
condition?
because of symmetry. I see what you mean
Almost
by
the same
symmetry
thing.
is not going to work.
Yes.
No,
So
wait, I don't understand. This gives you a half. Maybe
yes.
So it's like would that not work? Half is a bound which you can get. We're trying to see if
Half
we
is
can get better.
but
Half is you
we
can
want
get
a
like
better
there are
one.
like from 2 by 5, 2 by 5, 1 by 5 you can get better. Like there is no way you are good enough with that. Like trust me. There
What
are
if
better
ऐसा
ways
ही
to
है 2 by
construct.
5 2 by 5 1 by 5 is the winning strategy.
That is not, it's too symmetrical to have a good winning strategy. There are, like if you do 2 by 5 plus epsilon 2 by 5 minus epsilon, that is better. So it's not like that.
Minus
But like
epsilon.
another problem is like if you don't have too much symmetry, how are you going to write up? Like
That
you
is
don't
problem
have
with you writing up. That is not problem with the strategy.
no, I mean like there is no way to prove it. Like
No, they're
you
like,
have
see, Fibonacci, something like Fibonacci is not symmetrical, but you can write up, right? So like there might be some other good. I'm not saying Fibonacci. I don't think it's Fibonacci. But I don't know.
I mean, wait, Aritra, 2 by 5
Like
2 by
if
5
there's
1 by
not
5 will also
symmetry,
just
then
give you
we
half only.
It can be like one is like 1 by 5, one is like 2 by 5, then 3 by 5, then 4 by 5, something like that kind of cut also.
Yeah, I agree.
3 by
Everything
5.
has to be
Symmetrical.
different.
see
Like,
like
so-
we won't have exact value. We'll have infimum, right? Like
sure,
Wait,
we'll just
Sure.
that is also
But
fine.
like depends upon the construction we are doing. If we
Wait, so
like,
till now
in the
we
construction
have
we
only half. We have only half.
no, we have
Yes.
better 2 by 5, 2 by 5, 1 by 5 gives like 2
But
by 5
like you
plus
could
1
do
by
the
5.
same epsilon logic in here also. Like 1 by 5 mein you cut two pieces, which is like epsilon close to each other, and then it's the same thing. So half.
I see, that is true.
No, wait, repeat what?
are we
So,
doing
yeah,
epsilon in the small piece?
Epsilon is like tiny piece.
Epsilon in the piece, like in construction, like I think this construction, like their V strategy varies upon different construction, upon what I have seen.
Then I mean, okay, wait. If you're taking epsilon, then just change the rules of the game saying that two cuts can coincide.
Yeah,
What?
we'll just change it to can coincide because epsilon is like close to 0.
Exactly. Just like sure.
But that doesn't matter.
That,
to be
that's a
honest.
No,
bit weird.
just
Sure.
don't do that. There's no point in doing
There
like
is no
keep
real
it
point in
epsilon.
doing it. So
I think there is a point in that. Why not?
Ridhiman, why? Can you repeat why it's half?
because wait, come up here as an
How is there a point in that?
Right, okay, got it.
1 by 5 mein you just cut like two epsilonly close pieces. So like
Okay.
this is A, this is B, this is A, this is B, and like this is epsilon. So again you just get
Yes.
A gets half plus
Oh.
epsilon.
Right.
So the point is like 2 by 5 turn 2 by 5. The symmetry is making us a bad.
Which the
It doesn't need the 2
denominator
by
of
5 2 by
5 will just not work.
So
Because there
the
will
denominator
always
of 5 is bad. Yes, it's not denominator of 5.
What is the problem with 5?
The problem with 5
It's
is
too
neither
symmetrical to work.
neither like any
Wait, what if we just do
partitions
epsilon and
of
4
1 minute.
4 by 5?
The issue with 5 basically, Aram, is now that anything you do with 5, if you cut 1 by 5, 2 by 5, 2 by 5, you get like stuff like 8 over 15.
What about
Or
4 by
again,
5,
you get
1 by 10, 1 by 10?
So you do like 4 by 5, you
again
do like
symmetry,
in the
nah.
middle, you do
4
2
by
cuts
5
in
you put-
epsilon epsilon.
Okay, yeah.
So
that's
like
fine.
the same idea.
anything
half
with
plus
5,
epsilon
since
plus.
it's just an odd number, you can do an epsilon again.
Basically, you can't have two of the same size or something. Right now, you
But
can't
like
have
we need
two
to
of the same
change the
size.
denominator, I'm pretty sure.
But like
No,
you have
this
to
is
keep it odd.
We have to
Is
keep
this
it
a
odd.
problem
So
with 5 though? I don't think it's a problem with 5.
Okay,
2 by
wait.
3, let me
Look at
think
the
of
Don't
number
keep
of
some.
it
parts.
like don't keep it as like a sum prime. Like we need more divisors to get more.
It's not
Sure.
divisor, it's real number. We don't care about divisors. Yeah.
No, I mean like whatever fraction you're taking, it's just the LCM of the fractions. So like it just gives us more freedom to make
Guys,
it
what if we
unsymmetrical.
try 1/3?
Don't really matter.
Sorry, what if we try 2/3, 1/3, 1/6?
2/3, okay. 2/3,
Right, it doesn't matter. Sorry.
and then 1/3, and then one. Wait, what?
Sorry, मैं क्या बोल रहा हूँ? What is wait, like 1/3 minus 1/6 is it? What is
Yeah.
1/3 plus 1/6?
Yeah,
Whatever
that is. Wait, what?
That is
No,
half.
that's-
Sorry,
that's
that is
not
half.
correct.
So sorry, I meant half 1/6 1/3.
Half
1/3
1/6.
1/6.
Okay, sure.
This is goated like ये half हो
Well,
गया.
how will you half 1/6 1/3? Sure. That's what like Alu does.
Yeah.
Okay.
Okay,
So
you're
now
right.
you take this thing. What do you call half? And your fourth.
No more symmetry. Yippee.
But what n are we working with right now?
N
N
equals
equal
How
to
many?
2. Like each
N
guy
equals
gets
to
2
2.
cuts.
So we get a fourth plus a third.
Wait, Aritra, can you try to find something for the other player in this case? Does
7 over
Aritra
12.
exist as of now?
7
I
over
think
12.
for n even it should be half. Wait.
For n even, it should be half.
Wait,
Yeah,
Aritra,
because
you
It
think
stopped sharing. Guys, one sec. My network's
What?
still
Shoot.
So why I'm saying this, because in the n equal to 1 case, if the first player has a control on the size of the chunk, he can take extra. But in the second, like n equal to 2 case, both of them have the same option to choose which one, right? Like which bigger chunk you'll take. Oh no, actually wait, I have a better idea.
What if?
We need to try more cards, like
Yeah, I have a better
Wait,
idea.
my
Okay.
idea is that what if so like in any case, like B, like suppose A has made some random cuts, B will pick the largest piece and make like two epsilonly close cuts there. So the
larger
possible
cut has to
difference
be
is
like
like
that
one.
much large.
So like the possible difference between them is like 1/3 and 1/6.
Okay, great. Okay. Yes, do 1/7, 2/7, 4/7. That works. Because if you do like
Yeah,
in the
that
middle
should
strategy,
work.
you want to do like half, then you have 3 2/7s.
How did you come up with 1 to 4? Like one, what?
Yeah, how do you
Because
get
the
that?
next
I
thing
was
was
trying
7.
3
So I was
7 3
thinking
7
for
1 over 7.
yeah, I was thinking for 7. But like I don't know if still don't know if it's the optimal or
Wait,
like
are
what
you
is the
yeah.
like
highest
doing
here.
are you
Wait.
doing
Oh, yeah,
2 to
that
the
is.
n plus 1 minus 1 and then all the powers of 2 or something?
No
Who
clue.
knows?
No, 1/7, 2/7,
Actually,
3/7
that's not a bad
is
idea.
Oh, powers of 2 might work because उधर
That's
भी
not a bad
two-third
idea.
two-third था.
See, like 2 to the
See,
0?
like if you want to do like epsilon, then like there are 3 2/7 parts. So that is good.
Wait, if you do epsilon, what do you get? You get like what, 2 over 7 plus 2 over 7. You get 4 over 7.
You get
Like
4/7. So it's like it's probably like whatever the denominator is plus 1/2, something like that.
2 to the n over 2 to the n plus 1 minus 1.
Right.
What?
Plus.
That's what
No,
we've seen, na?
Oh, yeah,
2/3,
Yeah,
Oh,
yeah.
wait,
4 over
wait.
7.
that's amazing.
Aritra,
So and also if you want to do like this type of cuts, then like there are 3 1/7 parts. So it's good. Like you can't do close enough cuts. Like we prefer
No,
that
but
strategy
see,
at least.
this epsilon idea again does not work when n is odd. Like, how are you doing it?
But n
Sorry.
is even here.
If n is odd, then like you have epsilon, but what about the last tick? Like, what about the last part? If
Sorry?
There are 3 elastic, right? Like there is 2/7, 2/7, and 2/7, 3 2/7. So
okay, fine. Sure. Wait.
I didn't
So
get what you mean exactly.
no, never mind. Ignore what I said. How did we get 4/7? What did we get for this?
4/7.
Like the
So like
epsilon
you
strategy
do.
gives 4/7. I am thinking
Ah.
if there is a better strategy for B.
Yeah, how does epsilon give 4/7?
Well, you see here, you take like the partition between 4 over 7. You take this cut. This is your
Sure.
epsilon. And
Yeah.
now this one's going to be 2 over 7. This is a 2 over 7. Another
Wait.
2 over 7. And a 1
Aritra.
over 7. So you just, the first one chooses this thing. And the
To
second one
do
doesn't really matter. If you
Listen,
choose this, he's
Aritra.
going. You got it.
Yeah.
Does bro exist? Can you come here? I am thinking that player 1 can also try use epsilon strategy. So he can do epsilon 1/3, 2/3. Something like that.
For what case? N equal to?
N equal to 2. दो cuts हो ना.
दो cut बनाओ.
will that overcomplicate it?
Try करके देखो because like we have to eventually try to maximize things. So,
No, basically what he can do is like 2/3, like
तो फिर
he can
difference
like do
like
half
1/3.
of this, right? Half of this thing.
X, 2x, 4x.
Oh.
Wait, I'm still confused. Like, whatever epsilon idea you're using, like, does it follow the fact that A moves first? Like, whatever
Yeah.
A
Yes.
whatever cuts he makes. So, like, epsilon
Yes.
will be random.
Epsilon is very small, basically. Very small.
No,
Epsilon
no,
was
That's
saying
fine.
she's thinking if you don't use epsilon, you use something bigger.
No, that's not what I'm saying. But I'm just saying that the position will be random. No, like if
posi-
B moves, Then yeah, I see.
Wait.
Tanishka, if the position is
5
random,
by
it
9.
doesn't
Oh,
help
that is
them
just
at all to use epsilon.
You can get 5 by 9. Is it better than 4 by 7?
That is not better than 4 by 7. Is it? No, it's not.
35, 36.
Close, but not.
4 by 7 is better, yes.
Wait.
Okay, yeah, if denominator is less, that is better actually. Hmm.
That is insane. X 2x 4x. Wait, let me try to like debunk this. And if not, then this is good.
Well, let me just case bash to see if 4 by 7 is optimal here.
Right.
See,
Are
he
you
has
case
to do
batching
cuts
on
in the
in
4
which
part.
half the sticks are? Like the cuts.
X 2x 2x.
See, he has to do cuts in the 4 part. Otherwise, we can just take the 4 by 7 and have 4 by 7. If he does
That is true.
2 cuts in the 4 part, then what we do, if there is something greater than 2 by 7, we take that.
I
Then
see.
he
I
has to
see.
take the
देखो ना
2 by
ये होगा
7.
ये होगा. हाँ सही.
Okay, he can't do one cut in the 2 by 7 because we take the greater part. If he takes the 2 by 7, we take the other 4 by 7 part and have 4 by 7. And
So 2x 4x
it's just 4 by 7. It is just 4 by 7.
Aritra, can we just show कि if there are 2 cuts in the same piece, then then like for player B it is optimal only when the cuts are epsilon cuts.
Like it's optimal when they're basically the same cut.
Why? I think that will probably help us like.
I mean,
It
we're
will be
still
easier
not
to
sure if this is the optimal construction. Like, what
We are
about?
pretty sure, right? Are we?
I don't think so.
This is a pretty good construction and it's easily generalizable as
No,
well.
I'm thinking, yeah, it is generalizable. That doesn't mean that this is a good construction. I'm thinking, what if we do like x,
Let's
3x,
try
9x, something like powers of 3 and not 2.
Can we try n equals
There
3
is
now?
one observation, like I mean, we've been using this from the start, is that whenever you've completed your cuts and you start actually divvying up the pieces, then it's like if you take all the pieces and you arrange them in ascending order,
alternating होगा. That is
they're
like
alternating.
Yeah, that is
Yeah,
true
yeah,
because
obviously, like by greedily have
True.
you will choose the thing
You
which
need
is
to do that, otherwise you can't get
largest.
flex.
Other like after they cut, there is no point of the game. Like you can just calculate what is the thing. The cut
Yeah.
is the part of the game.
Wait, so you
okay.
always have half at least. And okay.
We want to prove it's slightly greater than half.
So
Yeah.
it's like the difference between A score and B score would be the difference between like just order them and say A1, A2, L is better. L1, N2, L, whatnot. Then it's just basically the difference of L's
Alternating
with odd
difference, yeah.
IDCs and the difference between L odd IDCs and like L even.
Yeah, exactly.
But like, is converting this even to like algebra even good?
Okay, 4 by 7 is optimal. I'm thinking about what if we do like 1 by 13, 3 by 13, 9 by 13.
Wait, why will you do that?
What like x2 x4? So let's go to power of 3. If like
Okay,
2
that
works
makes
good,
sense.
let's go to power of 3. Like, why is 2 good? I'm thinking.
Because
Like
n
one thing
equals
is
2.
easily
Like,
to generalize, but another thing is
see, powers of
why
3 will probably not work in this case. It might work in some other case. But this is n equals 2. So like powers of 2 is good.
is it like n power n? Like you took it as base of n or something. Like you don't do base 2 everywhere. It's n
Maybe.
equals
I
to 2,
don't know.
that's why you do base 2. And for n
Maybe.
equals to 3,
Yeah.
you'll do base 3.
That is
But for n equals to 1, you still do like base 2, right? It's like 1 and 2. Okay, it's 1 and 2 in n equals to 1. You still do base 2. Why you don't do like 1 and 3 in n equals to 1?
2 is nice. So like, do you look at the nearest power of 2 or something? Then
Like,
use that as a no. That would
why
still be
is
just
4 to
fine as a
1 the best? Like that matches with our previous n equals to 1 thing. So I'm now a little more hopeful that this works.
I'll be back in a minute.
Okay.
Wait, did we prove for n equal to 2 yet?
Yeah, like not prove. We prove that if he cuts 1/7, 2/7, 4/7, then like it is like he can do at least 4/7. But we did not prove for player A that it is 4/7. Like it can still be greater than 4/7 with some more optimal cut. Like we did case bash for player B. Like, yeah.
Anything with denominator 7, 6, 3, or 5 based on 4 over 7's best.
Should I try 1/1? It's hard case bash, but I can try.
1 by 1?
So it's like 149. No, like with power of threes, not 149. But 149, that is a good option. But for now, 139, let's see. No, it
Yes.
can't be power like perfect square. That doesn't make sense. It's too random to do that. And you have two cuts, right? So you have to do cuts in 9 because that is the optimal thing you can choose.
Either you directly get 9 or you get 7.5. So what is 7.5 out of
Okay,
13?
I see. I see why this is not optimal. See, if you do like half there, the point with the good thing x2, x4, x does is when I use the epsilon strategy,
Plate to plate.
there are 3 2x's, but in the 9 case, that does not happen because these two parts are still greater than 3. So like we can view 3 as a small thing, but in the
We
case
can
of
just,
x2, x4,
I mean, we can just do epsilon and get like 7.5 by 13, which is less.
yes. So the thing x2, x4x was because the epsilon strategy gives 2x, 2x, 2x. Like there are 3 2x's. Like
Yeah,
we want the
exactly.
odd number of the 2x's.
But then with that logic, like, we want odd
But
number.
should we go to n equals to 3 and try to use the same logic if it follows? Like
So what do
we
you
have
have
1
to
to
do
4,
this?
8. Okay. Let me take 1, 2, 4.
Okay, what progress do we have? Can you just explain please?
The only progress is that 139 don't work. Like 1 over 13, 3 over 13, and 9
And the
over 13.
strategy for B is basically you divide the 9 into part 2. The thing with like 1
Okay.
to 1 to 4 was like when you divide the 4 in like epsilon half cuts, like with epsilon, then there will be like 3 2x's. But with 9, the 2x's are like still bigger than 3. So like we
Oh,
don't have the optimal
yes.
thing. So that's why it's good. So I think it is 1 to 4 because the epsilon strategy doesn't work. Like if there is
Exactly.
something, you need to come up with a better strategy.
Okay.
Why I can't draw a simple box?
I think we are actually like very like this is a good idea, good progress, I guess.
What idea? What's what idea?
The thing that we have done.
The what epsilon thing?
The epsilon thing, the powers thing. Yeah.
Okay, yeah. N to the what? N plus 1. That what you saying?
Okay, we have the 1 to 4 8 cut. Now he has 3 cuts.
Okay, सबसे पहले right away I wanna try to make 3 epsilon cuts. So like 1, 2, 3.
By the way, one point is if he does the cut 8 also in like 1 to 4, so there is like 4 2 1 1, then it is optimal of basically it is 8 by 15 is optimal in that case.
Yeah.
Wait,
So with
Riddhiman,
both
3
cuts we
cuts
can
in
get
that
8
makes
by
no
15.
sense.
Huh?
3
8
cuts over
15?
there makes no sense. You want to put the other cut in like 4.
Yeah.
Oh,
Like,
right.
You put 2 cuts there and the third one is in 4.
Yeah, and then 1 4 gives.
Yeah.
So like now you'll get 4 2
But
2.
now the point is when you take 2, like when you take this, he takes this. When you take this, he takes this. When you take 2, he has to take 1. So
4 to 1,
like
8.
you have the 1/15 advantage now,
4 to
which
2
you
is
all which all you
7 over
want.
15.
8
Aram,
by
if you do
15.
that, thing, you get 7 over 15. That's
No,
the
8,
Like
8 over 15, right?
we get 8/15, like
4 plus 2 plus. Alright.
Yeah, 8 over
4 plus
15.
2 plus 2.
So do
This
both of them
matches
give
what
the
we
same
have.
thing? Do both of them give the same thing?
Oh, wait. Can we come back? Can we come back to 2? Because what if we did one cut in 4x, one cut in 2x? Like n equal to
But then
2.
you
What
can
do you
take,
think?
like, there are 3 4x's. So the problem is you can take 4x's, 2 4x's now. The same problem is there, right?
Oh,
Like
okay.
doing
I
cuts
see.
in the lowered one is just bad, like in this case, because there are like 3 more cuts here.
I'm a bit confused. I think I have a 9 over 15. Which
Okay.
is if you take the 3 cuts.
No, I have a 4/15. Like if 8 does like 4 2 1 1, like if the player B does, then the optimal is 8/15. Like
Just a minute.
with 1 to
See,
48, you can't get more than.
yeah, just a minute. Like you have this thing. 4, 4. Yeah, tell me.
No, there's 3
Yeah,
cuts.
this is bad. Like player B doesn't do that. This is just not optimal. We don't do this.
You take
Yeah, but
4, he takes.
why would B do that though?
Like there is no point we should do that. What
But
B
this,
does is one
but
second.
this just gives you 8 already. I don't understand.
No, we want 8 to
That's
have
why you don't do that. Like you don't do the epsilon strategy. You do like this. So if you take 4, he takes 4. If you take 2, he takes 2. If you take 1, he takes 1. And you have the last one. Like you want to do copycat, but you have like one extra move. So you take that
Got it.
advantage of one extra move
Got
and
it.
do 8 by
yes.
That's
15.
what we
But
did in n equal
doesn't,
to
I
1,
mean,
right?
wait, doesn't 8 over
Yes.
15 already give you again the same thing from before?
Yes, that's why we are doing it.
2 to the 3 over 2 to the 4 minus 1.
So we
Yeah.
need to
Yes.
prove that this is maximal. Why is this maximal again?
But I mean, this might not. No, this is probably maximal at this
This
point.
is
It's
At this
probably
fine.
point, it's just
this.
fallen too much.
Like if this is
This
not,
should
then
be.
like just sad.
Okay, let's try with 1 3 9 27 just in case.
I
Wait.
don't think
You
so.
can.
Like,
Yeah, I'm
well,
pretty
you
sure that
might,
won't work.
because 27. What if you do like 9 9 9? Okay, no, that doesn't work because like there is 3 and 1. So you take all the 9s.
18,
You take
yeah,
the 3 and
18.
he takes the 1.
So he takes
Yeah.
18 and 1,
It's
19.
basically you want to
19
Why
over
divide
is
the
it
15.
largest
optimal
piece, and then you
19
want to
over
divide the
27.
largest piece after
So
that.
4 13 40. 40.
It
You
is
have
19.
18 by 40. You have 21 by 40. Is 21 by 40 better than 8 by 15?
No.
Wait, instead of epsilon, wait, what if we
It's
do
not better.
this?
8 by 15 is just better, right?
Yeah, 8 by 15 is better.
What if B does 4 4 4 and then this 2 2 2? Oh, but that's still the same.
That's
That's
the
still the
same thing.
same.
That's still the same. Like, yeah, like if you want to do symmetry now, the point with symmetry now, like symmetry for B is bad now because you have the one extra move at last. So you take the
Yeah.
one.
So it should just be powers of 2 now. Yeah.
It is. I'm pretty sure it's
Yes, I
part
think
of
I'm
it.
convinced enough that it's powers of.
Yeah.
Yeah.
I'm also convinced.
Like you want to
Someone
keep
can
dividing the
someone
largest piece
convince
into
me
2,
too.
and it doesn't make sense to divide the largest
See,
piece into 3.
powers of 2 is good for player A because if you want to do half, 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 like the epsilon strategy, which we like for most of the cases, how we did half with the epsilon strategy. So here you can't use the epsilon strategy or symmetry
Right.
strategy just because you have the last move. So you can take the one if you use the symmetry strategy. And for epsilon strategy, there are like even number of big copies. So if there are even number of big copies, then both player can take the same number of big copies and it's just bad.
Right.
Then
Okay.
can you show that, like,
Works.
Okay, my first
B
first
takes
claim is that all. I think first we should try to prove that it is optimal for B to have all the cuts in the
Yeah,
biggest
I
piece.
think proof for B should be
What
easier
about-
than proof for A.
Yeah.
Wait, what about if you just like, since if you're assuming this is your thing, then can you show that the difference between whatever A gets and whatever B gets would be at least this thing?
Yeah, that's what we'll try to do, I guess. But let us pause and think for a sec. What are we
Is that
trying
what
to do?
Ridhiman, is that what you're saying?
I was saying ki the best like. Actually working with the difference is also like a good idea.
But
No, but
working
like
with
that
difference
was, I
is
thought
good
I was
when
trying to do this.
both players using like the symmetry strategy. If you're not using symmetry strategy, then working with difference might not be so good.
But like
So
we are
depends
assuming,
on the strategy of B.
Dekho, what I
Aritra, we
was
are
saying,
assuming it is the strategy, right? If we are claiming that this is the answer, then we are like literally banking on the fact that it's going to be symmetry
Yeah,
strategy.
yeah. So does the equality hold only in the case of symmetry strategy, or does it the for B I am saying, or
I
is
think
there other construction?
I'm pretty sure
If
this is
2 is right, then we have the strategy by just like bounding by 2 or something. Because like
Actually,
we can, because like with the everything is just powers of 2, so we know the bounds. We know what's L1, L2, and like the bounds.
yeah, actually that's why difference is very good, because once you get difference now and you're trying to show that B is trying to minimize the difference, or it's at least 1 over 2 to the n plus 1 minus 1, we can like forget about whatever anyone else does. We are just given a construction, and then we just need to show that it must be less than this. So like the mind bracking thing of finding which cuts to take, it's like half of that's gone.
And then for
So like fine, you have how many pieces? 2n plus 1. Yeah. So divvy them up into some number. So like n of these, n plus 1 of those, and n of these. So you're saying that the summation of Li I odd minus summation Lj j even.
wait, Aritra, we were actually wrong. It is actually like not like making only cuts in A is not optimal. Like what B will do is divide 8 into 2, divide 4 into 2, divide 2.
Sure.
Wait,
1
it's
over
just
2 to the
brilliant.
n.
Wait. See,
No, it doesn't make any difference. It's the same thing. It's the same thing.
But like if we want to prove,
Before we had 2-1,
Ronit's
now
logic
it's
of
1-1-1.
symmetry.
Like-
I agree. But like if we want to prove via Ronit's thing ki B is trying to minimize the difference.
yes, then this is better.
हाँ.
Then we should do this for B.
Sure. Yeah. Like this doesn't rely on epsilon, basically.
Which is quite
basically.
true. Yes.
I mean, the idea of epsilon was also to make the two things equal. So it is kind of related, but this is a better.
And to like try to find some random hole in the rules.
Yeah, exactly.
Like just be rebellious that way.
Like n is even, so we shouldn't need epsilon. But for odd n, we will probably
But
need
the point
epsilon.
is,
No,
for
but-
this strategy, 1 to 48 is good. Like you can do halves, but like if he does like something else, like all the cuts are big, then if you want to do half for like n of the things, then that's bad, right? Because the lowest one is also like lot. So this strategy of doing the half of all the things is not always good.
Wait, yeah, exactly. So the lowest one is like going to be close to 1 by n. So like the difference will be 1 by n and not power
No,
of 2.
Yeah,
but that
yeah,
is
yeah.
like, no, if A is doing powers of 2, then it's the same. But
Yeah,
if
if A
if
is doing powers of 2,
if-
then it's good. But
if A
we
is
can't
not
do
doing,
both the
then-
strategies at once. Like we have
Yeah.
to assume A is doing some cut and then B is doing some
Yeah.
cuts.
What if wait, have we proven that for 1 to 4 8 by 15 is the maximum?
Yeah, like yes, kind of.
Like
not really.
I'd
Does
say
that
in
mean
most cases.
that means we are Aritra is like translation of Aritra is we are reasonably confident.
Yes.
yeah, we are confident, but like we don't have a proof. So what if like in 1 to 4 8 B will have to do symmetry, and for like A, for proving that A cannot do anything else to get more than 8 by 15, then B has like different things. Like the symmetry one is for only 1 to 4 8, and like for others B just tries different things. Like, at least कुछ तो proof होगा.
But I have some another idea,
Just a minute, like
Hold on.
but no, that doesn't work. That doesn't work. Sorry.
Ranat, are you proving this?
I am thinking of, yes.
Can I tell you an idea?
Yes, please. Like I'm lost. My issue is like I'm trying to figure out where the hell does 2 to the n plus 1 here come from.
Like the way I'm thinking is like after these partitions, you know that everything is like just a power of 2, right? Like after A works his magic, then you have like 1, 2, 4, 8, blah 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 blah. And then after he makes the cuts, it's like basically something less. And if you know, wait, What's this here? Let me think it through.
We should have. It was good that we checked the case that n to the n stuff was existing. But like
Oh,
it's
no.
also sort
Yeah.
of motivated why it should be powers of 2 because every cut
Wait, I think I
which
have
A
proven
does.
that 8/15 is maximal.
That is good. Use this case bash. There is
It's
No,
nothing
no,
else to do.
reassuring.
not case. I mean, like n equal to 10 के लिए कैसे case bash करोगे? But yeah, it's like simple proof. Like basically formalizing what we have done. So
Which
observe that.
is
देखो. Observe that B can make cuts in at most like there are 4 partitions and B can make cuts in at most 3 of them.
yes.
And in each partition where B makes cut, A will get at least half of that partition, and A will also get the last partition.
Yes.
Huh. So like the difference, suppose half wale mein the difference is epsilon, but in the last partition the difference is at least 1. So the
Oh, so
difference
this
is
just
at least 1.
generalizes to all the things.
Exactly. We can generalize. So like in this
Wait,
strategy, 1
I
to
could
4
not
strategy,
understand.
like the
One
I'll-
second,
difference,
can you
I'm
just
saying ki there will be at least one compartment which is just untouched.
yes.
Huh. So in that compartment, B will get like A will get that compartment fully.
But
Oh,
you are
wait.
assuming all the compartment has one cut. Like some compartment might have two cuts and some
Huh.
two compartments have no
Doesn't
cut.
matter. The last one will get to be there. Doesn't
But
matter.
then, for example, 8 like this compartment does not have a cut, and like wherever the
Oh, this makes sense. Okay, wait, hold on. See, the reason why if you have more than one cut is that if you take the part which you're assuming has say 2 cuts, then either it's going to be this epsilon. Okay. It's just going to be
wait,
whatever
I think I see what Aditra means.
what
Not okay.
Riddhiman, instead of
No,
saying that
I
one
think
thing
this
will be
is complete.
completely
I see.
untouched, other than saying what is completely untouched, you should rather say the smallest thing will get to A,
Oh, wait. So
Exactly.
which is
The smallest
obvious.
thing that gets to A is
Which
the
is
difference.
obvious because like if you're taking the sum of odd indices minus the sum of even indices,
Huh,
there is one
exactly,
indice which stays
exactly.
unchanged. The difference between like xi minus xi minus 1, xi plus 1. Because we are ordering the lengths as like ascending order. Sorry, descending order. Yes. So like if you take this thing, xi, x1, x2, x3, x4, blah blah blah, x2n minus 1, x2n, and x2n plus 1. So like these two are competing for like who is largest, but we know the even ones are the one which are greater. So now since these two, whatever difference they make, let's just assume that the difference between them is all like roughly 0. Then A will have to take this. It doesn't matter. So the difference will be at least this thing.
Wait, but then hold on.
So
The
you actually
smallest.
need to show that this thing x2n plus 1 is greater than or equal to 1 over 2 to the n. If you show this, you're done.
So like basically, I'm thinking ki like at least one of the compartments will be in an odd position. Like that is enough to prove. And suppose contradiction. Suppose all of them are in even positions. Then there's like a contradiction.
Riddhiman, how does positions matter, right? We're just like
Like it matters
reordering
now
them.
because A is getting odd position wale. So like
No, A is
No,
not.
it's like it's in descending
and
order.
the last okay, I see. It's the last guy that
We're
matters.
reordering like the stuff.
Wait, how are we allowed to reorder like that?
No,
Because after the
it's
cuts
just
are
A
made,
and
the
B who
game is
choose.
determined.
It's just A and B who choose.
see, after
Okay.
you cut, that doesn't matter. Like basically, it's fixed. Like A takes the largest one, B takes the smallest one. That is the best algorithm. So after cut, it's not a game. So
No,
you can
like you're
reorder and
taking
stuff.
A's cuts, then you're reordering them in ascending order, and
After
then you're
both the
doing
No,
cuts
no,
are
descending.
no,
made,
it's
right?
not A's cuts. The point is that A and B have both made their cuts.
Okay.
So like the obvious thing which A and B will do to play optimally is they will take the largest thing which they can get their hands on.
Okay.
So
Fine.
like assume you take all of the lengths and you give all of them a label. Okay, like x1,
Fine.
x2, all of those, which is basically x1 is greater than x2, greater than or equal to x3, blah blah blah. So
Yeah.
then A will always get hold of all the odd indices and B will always get hold of all the even indices.
Okay, you're doing it that way. Alright, fine.
So x2n plus 1 will always be something A has. Now you look at x1 and x2. Since we're going to take the difference of like whatever A gets and whatever B gets, just assume you're taking x1 minus x2, x3 minus x4, blah blah blah.
Okay.
So like assume it's just the thing is 0. It's greater than or equal to 0, assume it's 0. That means that the difference between the two of them must be at least the smallest
Wait.
chunk.
Yeah, we won.
So you just need to show that the smallest chunk there is can be maximized to be this thing.
Wait,
1 over 2n plus
Aritra. Okay, I am actually rethinking like it. I think it is probably like the best. The obviously after the cuts are made, the best strategy for A is to take by order, like the first, the largest, the third largest, the fifth largest, and so on.
See, it's no
But
strategy. After the cuts are made, there is no strategy.
exactly. So what I am saying ki this is the best possible thing that is the highest that he can get, but it's hard to work with. So let's like actually, so instead of that, what we can do is that think of like each compartment as its own game. So like for example, 8 made like for example in 8, sorry, B made some random cuts. So actually A will pick this one and then
strong induction,
in each
something like that, huh?
No, but
not
We
quite.
that
play
doesn't account
the
for the
game
fact
on
that
that
the
compartment
endpoints are the
basically.
cuts.
I'm just saying ki these compartment guys like pieces will compete with themselves is what I'm saying.
Sure, but the main
Wait, but
thing which is bit variable here is that you don't know how many cuts B chooses to give to each compartment.
Still okay, I'm working on that, but
see,
like
no, but
That means you need to
this
find a best strategy.
we
for
can't
the
induct
best strategy we
because
know this.
A will have no cuts inside that compartment by definition, right?
No, I'm not saying ki it's induction. I'm just saying ki the like whenever B chooses a piece of 8 wala compartment, A will not choose the second largest piece from the overall. A will choose the second largest piece also from the 8th compartment.
What do you mean?
Like suppose B pick like
Wait, doesn't that give B a better?
no, it does not because A is like doing the starting move. So basically, what A will do first of all, A will just pick the largest. A will just pick the largest piece, and then uske baad, whenever B picks a piece, okay, it might not. Okay,
Wait,
I'm
but are
not
you just
sure.
overcomplicating stuff which is like does not need to be overcomplicated?
No, it does not.
No,
I mean,
there are better ways to do this. I think
I guess yeah. I'm
to
not.
divide
I'm not
it
really sure.
compartment because then in some compartment we can start the game which is just not that good to work with. Yeah, I feel.
Exactly. In other compartments, B gets to start that game, which is bad.
No, it's just some summation. It's just some calculation we have to do. I think, and
I guess not sure.
Wait, why don't we look at the first n-1 cuts that A has made?
N plus 1.
No, the first n-1 cuts
Oh,
that
A
has
made.
made.
Yeah, fine. Yes.
And now there is this last piece and then there's this n-1. But no, you can't induct still. You can't induct.
I think there might be one combinatorial part left, like as in
I can
doing a cut, like doing a small cut in 8 is useless or something like that. Like epsilon cut in 8 is useless because like here using an extra unnecessary cut which could have gone to another compartment.
Okay, wait. I think I have an idea. So if you look at A, they make n cuts. So we actually we put like we have like n cuts from A, n, and we look at the first n minus like wait. What? Yeah, you look at the first n pieces and you reorder them so that they're in increasing order. So the length of this is less than the length of this and so on. So basically you end up with this is the largest piece largest, and then you have the rest over here. And somehow, like, if we can show that B makes n minus 1 cuts over here, and B makes 1 cut over here, and then we can try to induct.
That may not be true, right? How will you show that B makes a minus plus the rest?
It's 7:08 and we are just
I
Okay,
think
yeah,
it's
that,
good. It's good. Like we'll do P4, P5 maybe. It's
You
okay.
want
Let
to
us
do
give
P4,
some
started
more time.
4:30.
See, the question is how long do we get to stick here? Which is
Like at least
I mean,
9:30 at least.
9:30.
I mean, as long as we end before like 12:30, I'm okay. Because
Oh no, I have to eat.
bhai,
I can have dinner at 12:30. It's okay.
yeah, bhai, I just want to watch the World Cup. That's it. I don't have anything else planned for today.
We can include that in the live stream.
Yes,
Someone
yes.
opens
I'm
up
for
the
live.
yeah.
Let's watch Argentina lift it again.
rename it to
Let's
ONC
not
World
waste
Cup live
time and do
stream.
this.
Let's not waste time and just solve this.
No, I'm thinking the other ways to induct, like some a little bit weird inductive hypothesis. Uh, like on the first turn, what is the maximum piece you can get? Like as a perspective.
Like on the first turn.
With the
Yeah.
power minus
So I'm
1.
trying to induct like yes, Tanishka.
No, never mind.
So,
Why is everybody quiet all of a sudden?
Everyone's thinking.
I'm not okay,
yeah.
guys. I mean, I've been listening to all of your ideas till now.
Well, let me just read the problem again. I Hmm. Right.
Wait, so what is stopping us from proving our thing is optimal?
The
We don't
maths.
have the proof. That's kind of stopping us.
Isn't it the fact that B can cut like more than 2 times in a
That is a very
partition?
irritating thing. Like I think we have
Like,
to do some combi to show that more than one cut in each compartment is. No, we can't do that because doing all the
I
cuts in the
think they
A
should
See,
see.
you might need more than 1 cut in a compartment
My
because what if
idea
A
was
makes 1 compartment very big?
wait. Should I tell my idea?
Yeah,
What I'm
sure.
trying to what I'm trying to do is say B does some cut. It takes the like first, third, fifth takes like this. B takes second, fourth, and this kind of things. I want to prove like A1 plus A3 plus A5 greater than equal to something. Say A1 is largest, greater than equal to some stuff like A1 plus A3 plus A5 dot 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 AI is greater than equal to something in terms of N and I. So basically, and prove it inductive hypothesis
Can we
with
do something
induction.
like weights where the number of cuts B gives to a compartment is proportional to its size?
I mean, it's just restatement of the problem. That does not help us to solve the problem.
Wait, but
Okay.
Aritra, in your E1, A2, like that thing, you have to include the fact that like 1 to 4 8 कैसे लाओगे उसमें? It's a bit
क्यों नहीं ला
tricky.
सकते?
Like ला सकते हो, but it's a bit tricky. How do you bring that in?
It's not trick. Yeah, like wait, I'm thinking. I need a good inductive hypothesis. I think we can do if I have the one sec. I am having four at least, right? In this moves, if when we cut it, I am having at least four. Am I?
In which place?
Right. Because in 8, I need like 2 cuts. to not get 4. And in 4, I need like 2 cuts again, right? No, in 4, I need 1 cut. In 8, I need 2 cut. So we have 3 cuts. Wait, did all of us become silent for us?
Okay, fine.
Very,
Like,
very heavily.
yeah, we did get silent. My issue is that, like,
My issue is it's a P3 and the combi.
I mean, you would have been in even
Right.
more of an issue if it was a P3 Geo, but okay.
There's a
That
P3
is
Geo?
No, Geo would have been
Wait, what?
worse.
There's a P3 Geo? I didn't know that.
There is a P3 Geo, but like that is IMO P3.
Oh, no, I don't think you know.
Bhai. Okay, there's a P6.
Like,
Wait, can we just try P4, P5 and then something like
But
that?
wait,
I think
like,
we're having ideas. If we like let off the problem, we'll stop having any ideas right now. Let us give
No,
like
if,
at least 10 minutes, 5 minutes, and then we can go to next problem. If we don't have any ideas,
sure.
we'll
okay,
go to
fine.
P4.
If
Okay,
you're only going to take 5
7:20.
minutes, I'll just tell you, let's just take turns telling whatever we thought extra until now, not what everyone knows. So, like, I mean, what I was thinking is that you have this L1, L2, L3, L4, L2, and whatnot. Since we're trying to get a bound on it, we want to show that L2n minus 1 is greater than or equal to whatever the difference is. So if we want to do that, then we'll just look at we're trying to actually what we're trying to do is we're trying to take all the other L's and we're trying to find a way to get them all to 0. So what I'm trying to do is I'm trying to first let A make all the cuts and then have B make cuts in such a way that there's always 2 pieces which are equal to each other. So that will like instantly get everything is 0. Then you're only left with L2 and minus 1. It's like basically the worst possible case you have. And if you show that thing is less than or equal to 1 over 2 to the n plus 1 minus 1, then you'll be okay. Point is, what's the best divisions B can make such that everything has an equal counterpart and the thing which you're left with is huge enough.
Oh, that is okay. Let me think about it.
Okay, I think I have an inductive hypothesis. Let me just check with the cases that it's true.
What is a hypothesis?
That like B's sum of the first k cuts is less than. Okay, let me just do the maths correctly. It's less than 2
Shut up and
power, like
calculate.
by whatever the by thing, I don't know, 2 to the n plus 1 by minus 1. Just write it. First k cuts is less than equal to.
I mean, if you want, just take f of n and try to fit it into our induction and
Like
solve for it.
summation of 2 power n minus 1, like not summation, 2 power n minus 1, 2 power n minus 2 plus dot 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 2 power n minus k.
That is very valid.
Yes, I think for B this is. So A will be greater than. If we know B, we know A.
Wait, what are we
Wait,
doing?
this is for B. This was for B.
Yeah, that's why I'm trying to do less than equal to. It's for B.
But hold on, how did you get this? What did you do?
So basically, I want to prove that with the K, like not with the K.
Ith thing.
No, for like K, what should I say? like after K moves, after K pieces
So
taken
K
by
turn
B,
of B.
the sum is at most this. I want to prove that by induction. And if we prove this, I think the sum will match for the number we are getting.
And this is for like any strategy, right? You're saying.
No, like for A strategy, you're fixing A strategy, obviously.
Like for like any of A strategy.
Any strategy by B, yes, I want to prove that. I'm thinking to prove that.
Like this is not for 142, 1248, right? Not
It
specific.
is for 1244, like which fix A strategy, we don't fix B strategy.
Oh, acha, is this for only 1248 strategy?
Yes, we want to prove A is greater than equal to that, basically. It is for 1248. Like
So for
for
1248,
any
you
B
want to
strategy
show
that this will work.
for 1248, you want to show 2 to the n divided by 2 to n plus 1 minus 1.
Yes.
Yes.
Okay.
Oh,
And
wait,
this
wait.
does finish. This does finish for that.
If we prove this claim, there's that. I'm just doing the inductive
What is this
hypothesis.
claim?
Okay, I got
If you
wait,
take K pieces, 1 second on it.
yeah, go for
If
it.
you for the first K pieces that B takes, the sum of the lengths of the first K pieces. Okay, first K pieces meaning like if you have A1, A2 dot dot dot, then A2 plus A4 plus dot A4 plus dot 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 till A2K. Okay.
What? Okay.
Say A1 greater than equal to
Fine,
A2
fine.
greater than equal to A3
Okay.
greater than then
Sure.
A2 plus A4 plus dot 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 A2K is the first K
Yeah.
pieces,
Yeah.
which is less than equal to 2 to the power n minus 1 plus 2 to the power n minus 2 plus dot 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 2 power n minus k by that.
Okay.
I want to prove this inductive hypothesis because base case is obviously true, you can see. Because if it is greater than 2 power n minus 1, then like A will just take it or something.
No, basically it's twice. I can tell you.
Wait, but isn't this like the exact opposite of what Ronit said? Like his thing was exactly same for A. In like
Oh,
A
that's
squared
greater than. I'm
of
doing like less than. So the bounds are. I don't
like
know.
yeah,
Not
it's
it.
for A.
Okay, like my idea was that like if you remember what I was doing was I was trying to get equal segments, right? I was trying to make B such that we get equal segments and then we can just cancel them out.
Yeah.
So like you start with A doing its thing. A makes its cuts. Now you want to make sure that B cuts them into all what do you call equal things. So what you do is that you just take a bunch of what A has. So suppose oh shit. Yeah, okay. This is your thing, and A has done a random assortment of cuts. Yeah, sure. Okay, I'll just put one more here. Fine. So like the issue which I was running into is like if you take the biggest ones, if you do the same ordering like we did before, suppose that all of the lengths are A1, A2, A3. So like A1, A2, AN minus 1. Yeah? N minus 1 or N plus 1. What was it?
Minus something. So plus what?
Either way, like I mean, sure, just like keep it AN plus 1. Sure. So like the issue is if you take the difference of these two, difference of A3, A4, blah blah blah, you'll get some small amount left. And now whatever small amounts you're left with, you're trying to now have B make more cuts in between, such that those two are equal. So it's basically difference of things. So instead of that, the issue with that is like you can't B obviously has a cap on the number of cuts it can make. We need to take care of that.
I think
So what you
Iran.
do?
Okay, go on, go on.
No, no, go. Yeah.
No, I was just thinking. I was thinking that you might just want to prove that the difference between like two consecutive things is at least one, something like that.
So, but then I see, like, but then the idea which I got was that if you take these divisions here, and now you just take two, you just take the division in between. So, like the this guy. Then you break it into two of these things. Okay. Now this is some sort of divisions, and this is some sort of divisions. Okay. So now what you do is you just divide. What D does is you look at the leftmost division on both sides. So that would be this guy, right? Right.
What?
Yeah.
Yes.
So like what B does is B also cuts along that thing. Similarly, B cuts along here and here and here.
Wait. Why is A cutting what?
No, B is cutting. B is cutting. So then these are all equal. Do you see?
Wait. Wait, sorry, like what are these two sections?
Okay, this is like you look at the section, you look at the division which cuts this thing roughly in half. Okay,
Okay, so this is like 1/2 and this is 1/2, like the left half and the right half.
put them next to each other. Okay, and then whatever divisions you've got, suppose is this thing,
Wait,
and this
what are
thing.
you trying to show right now? I'm confused.
I'm trying to make these above over here, these things 0, because then we
Okay.
can work rather on this last bit. So suppose you have this thing.
Wait,
Now
no,
over
what do you
here,
mean by that?
you remember that if we take the differences, we assume L1 minus L2, L3 minus all of those are 0.
Wait, are we fixing a strategy or not?
We are fixing A, like A
Yeah,
does whatever
we are
the
just
hell
doing
wants.
for 1 to 4, 8, I think.
And
Wait,
then you
Ridhima,
want
did
to
you-
show that what? That
L2n minus 1 is greater than or equal to 1 over 2 to the n plus 1 minus 1. Whatever.
do you want to show A
Aritra's
will always
was.
get that much, or B can guarantee A gets at most that much?
No. Whatever B does
Yeah.
is less than or equal to that.
Okay. Fine. Sure.
Yeah.
Alright.
So then now what B does over here is once he has put them into these two sections, he cuts along over here. Do you see, like I'm just extending this thing here,
Yeah, I see.
here, 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 and here, and one more here.
Wait, I'm confused, but like what if these overlap? You don't know like whatever A does here and like A does here, what if they overlap? You can't
They have
prove
to
this.
overlap. Whatever comes first, you just cut those, and the number is always n.
No, that's not really like.
What's your question? I don't get it.
Like, what if it's something like this?
No, that we are choosing what B does here.
Yeah, like okay, like B has yeah. I
B
see.
will
has
cut
an
through
O.
a piece which was already there in the above one.
Oh, I see.
So whatever it is, it'll be left to this thing, the sum of these two pieces.
Does that finish?
No, I don't know what the hell that sum is. That's the problem.
Are we overcomplicating this? I don't know.
It's a
This is
P3.
P3.
It's a
It
P3.
is a P3.
You
No.
needs to be
When,
overcomplicated.
no, when A strategy is fixed to show that whatever B does, A will get at least that much. That should be
Okay,
quite
yeah,
simple.
I think like my induction works, but I just need to calculate because for some reason I
Like
can't calculate. I'll just
the
skip the idea.
complicated part is when you don't know A strategy. But for this particular strategy of A, it should be a lot simpler than what we are
Wait,
trying to
Adam,
do.
can you come here?
No,
And where I am.
Arham,
Yeah.
we are like we just don't care what A does. It does something. You
No,
are given
but
with whatever A does.
No, Ronit
No,
is
no, no,
doing the
no.
other thing, and I'm doing the other thing. Right?
Oh, but I thought Ronit was doing what you were doing. What?
No.
Oh, because I asked you. Okay, anyways.
But Adam, can you come? So
Yeah,
I'm
I'll
trying to
answer.
prove this, okay?
Yeah,
And for like k equals to 1, it's true, right?
okay.
Now, the idea
T
I'm trying
equals
to do
M.
is,
Sure.
for inductive hypothesis, this is true.
Yeah.
Uh,
Are we inducting on K?
Yes.
yes, you are inducting on k.
Okay.
B is less than or equal to 2 power, right? N minus 1 plus n minus 2 dot dot dot. This, say this is bk, and
Yeah.
bk plus 1 is greater than or equal to summation of 2 power n minus I equals to 1 to k plus 1. Okay.
Okay.
and we want to prove a contradiction.
Yeah.
Yeah, divide by 2 is
So now what I'm doing is, we know that this is the A2K length is getting added. So A2K should be greater than equal to 2 power n minus k minus 1, right?
N minus K. Wait, let me check.
Yeah, that is the last time we're adding basically. All other terms are same.
Sure. Sure. Yeah.
Okay, right.
And
Now
now
if A2K is this, now like whenever B is taking, say, B one sec.
But then we get bound on A2K minus 1 also, which should be greater than this.
We have A2K. Wait. I was thinking of something else. Am I?
No, this makes sense.
No,
But
this makes sense. But from here to progress, I was thinking like where will the 2 to the power, like the A has done some cuts, right? From which of the cuts 2 to the power n minus 1, 2 to the power n minus 2, this can come basically. 2 to the power n minus k, this can come with from which cuts. But I think because we have less than equal to bound, this can come from any cut. We don't have the control over which cut it comes from. I thought 2 to the n minus 1 must come from the larger cut, but that
we
might
don't
not be
know
true
that.
because that is less than equal to 2 to the n minus 1. Okay, but that is greater than. Okay, no. So, okay, see. Yes. Correct. Great. Right. Okay. A to
I
the
count
power.
5 adjectives until now.
Great.
6.
A2k is greater than equal to 2 to the power n minus 2k. So the point is A2 is greater than equal to A4 greater than equal to A2k, right?
Yes.
Now, if A2k, okay, it's not greater than equal to because we had strictly less, we need strictly greater than, so it's strictly greater than, okay. And we can't have cuts from same, so it's like strictly greater than, we don't care about anything. A2k is greater than 2 to the power n minus k minus 1.
Yes.
So which cut it must have come from? 2 to the power n minus k?
Could have
Like
been something above that also, right?
It can be something, it's at least 2 to the power n minus k, right?
Sure.
Now the fun part comes. We'll do another induction to show it comes from 2 power n minus k. And like A2k minus 2, this comes from 2 power n minus. But
By
it's
the way,
2k plus 2, right?
Aritra,
Yeah.
do you think after we work with your idea a little bit, like after your explanation, I think we should all work on a different problem.
I think
Wait, I have something to say about your idea, Ronit, after this.
Okay. Yeah, Aritra, will keep us finish.
No, I think this finishes. I see the
also
finish.
think this might finish.
A2k plus 2, right? Is this plus 2 or not?
It will be A.
This is A1 till AK. This is AK 2k plus 2.
It will be plus 2. Like we added.
Yeah. It is 2k plus 2. Okay.
Yeah.
So A2k plus 2, this comes from 2 to the power n minus k, right? So A2k must come from like 2 power n minus 1. Not n minus 1, sorry. N minus k
plus 1. Or like it can be in the same one only, no?
It can't be because of the greater than, strictly greater than, right?
Oh, acha, I see. Okay.
Because two powers like less than,
exactly.
like,
I see.
is just greater than.
Yeah, it is greater than half.
So we get like from here, we will just get that A2 comes from.
What
Is
is
it 2
AK
power
again?
n or 2 power n minus 1? It's 2 power n, right?
2 power n.
Aritra, what's AK again?
AK is the like A1 is the largest cut, A2 is the second largest cut. So whatever B takes is like the second largest cut, A2 plus
Aritra,
A4.
how are we continuing this? We don't know if A2k is greater than n minus 2 raised to n minus k plus 1. Like we don't know that, right?
Even if the equality holds,
No,
like
like even like I'm not sure why this inequality slash thing should hold. Why is A, like we have for A 2k plus 2? Why for A 2k?
no, the inequality doesn't hold because it comes from the fact that ak 2k plus 2 comes from 2 power n minus k, right?
Okay,
And
एक second.
a2k is greater than equal to a2k plus 2, right?
So we still have a weak bound of 2 raised to n minus k
Don't we
minus
have
1.
a
Why
2k
plus
is
1?
greater than equal to 2 to the n minus k?
Like why are we multiplying by 4? Like how do we have
We're
that?
not multiplying by 4, we're multiplying by 2.
Like
Like
minus 1 से
a2k
plus 1.
comes from 2 power n minus k plus 1. It is not greater than 2 power n minus 1. It's less than 2 power n minus k plus 1.
Oh,
That's where it
अच्छा,
comes
अच्छा,
from it.
okay.
Like
अच्छा,
this
it
is
comes
arrow sign
from it.
from where it
Arithmetic.
comes from.
Okay,
Why
sure.
is a 2k greater than equal to 2 to the n minus k minus 1?
2k नहीं वो 2k plus 2 होगा, I guess.
A2k
What?
plus 2, right?
What indexing are you using?
Like we are
The
assuming
inductive
contradiction.
hypothesis I wrote. So bk is less than equal to this, but bk plus 1 is greater than equal to this. So bk plus 1 minus bk is just a2k. A2k
2k
plus
plus
2. So it has to be greater than a2k plus 2 has to be greater than 2 power n minus k minus 1.
That is true.
Why not 2 power n minus k?
No, like just subtract the.
Well, the
Oh,
last
okay,
term
yeah,
is 2
fine,
power n
fine.
minus
Makes
k
sense. Makes
minus.
sense. Makes sense.
So because it is greater than 2 power n minus k minus 1, it comes from 2 power n minus. It might come from which is above 2 power n minus k, but we don't care. It at least comes from
At
2
least comes
power
from.
n minus k. Then a2k at least comes from 2 power n minus k plus 1.
Hmm.
But
What do you
because
mean
it
that
can
comes
come.
from?
See, A has done the segments, right? A has done the 1, 2, 4, 8 at segments, like
Oh,
2
and
power
B
I
made the cut
segments.
over there.
So
Okay.
B made the
In that.
cut. So from
Okay.
before B made the cut, like B made the cut, right? So that cut is within some cut that A has made. So this part is some cut which A has also made. So that part, this part is from which
Yeah,
A
yeah,
part
I
I'm
see what you
counting
mean
that.
now. Yeah. Okay.
It's like the worst English I have said, but like you understand. Great. I just want to understand A2k like comes from 2 power n minus k plus 1.
But
Does that mean
A2k
A2
minus
comes from
2.
2 power n or n minus n minus 1? Like I
No,
need to
what
do
if
that.
A2k and A2k minus 2 are from the same?
It
Is it?
can't be from the same. That just
Wait,
exceeds
2k
the
is
like
not 2k is not n minus k plus 1. It's n minus k.
it is no A2k comes from n minus k plus 1. Because like A2k plus 2 comes from 2 power n minus k.
Okay.
So it comes from n minus k plus 1. Because it can't come from the same, right? Because it's greater than that. A2k is greater than that, 2 power
okay,
n minus k
okay.
minus 1. Like both of them are total greater than 2 power n minus k. So both of them together can't come from 2 power n minus k. You understand what I'm trying to say? So A2 comes from 2 power n, and now we use the A1. So A1 is greater than equal to A2, is greater than equal to A3, right? So we have like 2 into 2 power n plus 2 power n minus 1 plus dot dot dot, because A1 is greater than equal to A3 is greater than A4. I'm using that idea.
Wait, what? Look at the sum I wrote. What do we have to do? Yeah.
No, this see, this sum is the B sum, right? Like A2 plus A2k, right? That like from what it comes from.
Yeah.
Now I want to add the A also basically.
Okay. Fine.
So
Just
yes.
do twice of that. Yeah, do twice of that.
Wait. One sec. Wait, we need to. Can you just remove it once? I'll just need to like get the
What I wrote?
inequalities in my head.
Okay.
Just one sec. You don't need to remove this. This is fine. Just one sec.
Is the last
So
thing n minus k or n minus k plus 1?
it is plus 1
Okay.
because we are doing till A2k.
Well, it will be 2 raised to. I mean, okay, sure.
No, A2k plus 2 is greater than. It should be 2 power n minus k, like not plus 1. There should be another term.
Wait, I just want to be clear. What exactly is 2A, 2K? Is it it's the 2K piece, right?
Yeah, if we
Like,
order it like A1, A2, A3, so it's the kth piece we choose.
so why
Why is the last
why
piece
can't why can't एक second, why can't
So the last
A2K minus 2 and why can't A2K and A2K minus 2 be from the same guy?
Because just calculate the inequality, like if it comes from the same guy, A2K plus 2 is greater than 2 power n minus k minus 1, right? And A2K is greater than 2 power n minus k
Oh,
minus 1. So together they're greater than 2 power n minus k. So if both of them come from the 2 power n minus k, that can't happen because their sum is greater than 2 power n minus k.
okay, I
Wait,
see,
if
I
you're
see.
saying A to K is the last term, then are you like assuming that N is
It's not
odd?
the A2K is the last term. A2K plus 2 is the last term.
Whatever, like your last term is even.
Because
That
B chooses
means
only even terms, right? Like A1, A3, A5, A will choose.
you're ordering A here or you're ordering everything?
We are just ordering the pieces.
The pieces after A cuts or after B?
After both cuts.
So after both cuts it will be odd, na?
A will have odd, B will have even. We are looking at B.
Like A will pick the highest piece, B will
Oh,
pick the
B
second
is
highest piece.
A. Okay, B is A. I see. B is
B,
AI.
what? B is A. That is insane.
The cuts B has made is AI. I thought that.
Yeah, the cuts
Wait,
B
why
had
don't
made.
we like restart what
Not the
we've
cuts
just
B had
done so
made, like the total
helpfully?
final pieces are AI basically.
Aditya, let's restart what we've done like this argument
Hey,
fully.
can you just wait 1 second? Like,
Okay.
is 2 power n minus k. This should
Wait,
be greater than.
Aritra, if you're thinking, then like Tanishka, you can tell us whatever you were thinking.
Sure.
Wait, isn't this already kind of a contradiction? Because we assume B is greater than.
Yeah, you can hear that. Like, I'll be done. I am pretty sure. I just like the inequalities are missing my brain. I'm just thinking about it for like 1 minute in silence. Like, you guys can talk.
Yeah, Tanishka, what was it you thought of?
I don't think it'll work now, but like basically I was just looking at like the last guy here, like it's probably the AI, call it the AI thing here. And then this thing is AJ. So like we consider like all of these things, like because of like whatever B can do, he can like make these equal. And like even if we have stuff here, surely he can just like cut them in the middle and then make equal stuff. So like all we have to do is like in every case is just look at these two things here, call
AI
them AI
minus
and AJ.
AJ, yes.
Yeah. Plus, oh
But
right,
even
minus.
not exactly AI minus AJ. No, it's
Wait,
not
why
AI
not?
minus AJ. See,
Oh, odd even stuff. But
Okay, sorry. The thing we
all
can
right,
also
yes,
do.
it is minus AI minus AJ. So, but you're saying that we can take, oh yeah, we can take any I and any AJ. Fine.
and then like you can basically shift this, and then you can just consider all the AJ and AIs. Like maybe that gives a contradiction or
Yeah.
something.
Okay, this is good. Then you have that AI minus AJ. You just need to show that there exists I and J. So the AI minus AJ is less than this.
Yep, that's what I want. And like basically, if you shift this, the problem is like whatever you shift, every the other thing is fixed. Like after every shift you make, everything like this term will back up here. So like whatever you do here goes here, whatever you do there goes here.
No, I don't understand the backup here because like you're already starting from here.
Yeah,
Everything
basically like
behind them is anyway gone.
yeah, it's gone. Like it's just a
Yeah.
way of
So
looking
what are
at
you
things.
bringing back? What are you like pushing back? I don't get
Oh,
it.
like no, I'm just considering like I'm just telling you how you can consider all the AI agents. Like
Okay,
consider like
yeah,
pushing this chain here and then it goes. So,
sure. Yeah. So like fine, then we need to show this thing.
yeah, that is true. But like there is no guarantee that's true.
Oh yeah, A1 minus no. AI would be better. You want to find the two things which are closest to each other. You want to find the smallest difference. So
Hmm.
it needs to be AI minus AJ, not just A1 minus AJ.
Yeah, right. Okay,
AI
yeah.
minus
It
AJ.
is. Yes.
Fine. By the way, did everyone else get that?
I was thinking completely different stuff.
I see. Basically, the point is we need to show just this.
What is
We just need to show this.
for some INJ, for any
For
INJ?
for all INJ.
Wait, isn't that just true or something? Hold on. For
Is
all
this
INJ,
Yeah.
that is false. Like you can do epsilon, right?
no, like that's not for all.
There exists
you
the
just
smallest INJ.
Oh, there exists some INJ with XYZ. Oh, that is surely true. Just like look at just look at the entire something just sum over all of these things like I minus AJ, where I is greater than J. So I appears how many times? I minus 1 times, right? So it's a summation I minus 1. Oh wait, hold on. Okay, it's a bit more complicated than that. It's like I minus 1 is plus and then n I के ऊपर so n minus 1 है n minus I plus 1 n minus I.
whatever the number of cuts is 2n plus 2n minus I minus 1 times, right?
Yeah, it's something like n. What is n?
Not I minus 1, it's 2n minus I minus.
Wait, actually, you can rather think of it like this. You don't only look at INJ, you look at the whole thing. So this is the sum of some. Okay, fine. This is the sum of some AI, I in I,
Oh, right.
and this is the sum of J
Sum.
for some
Wait,
J
no,
and
no.
J. So you're
Wait, no,
taking.
you.
So this thing is just going to be the sum of AI minus the sum of AJ, and you need to minimize this.
Hold up. We can do that because, like, if you're assuming this, then you're assuming like if you have something here, like if this is like the sum of AJs and this is the sum of AI, whatever AI AJs. But like what we said was like it's not obvious. Like there could be a case where these two are not equal. Like the length of these two are not equal, and then in that case, what we were doing was
Sure,
like
the length of them aren't equal.
partitioning that.
The
Yeah.
length of them aren't equal. Sure, but what I'm saying is that all of these cuts, in the end, whatever is left is basically just the sum of AI minus the sum of
Johnny,
AJ.
just a second. Are you absolutely positive कि proving this is will finish 1 to 4 8 cards?
I mean, see,
Just tell me the argument.
fine, I'll tell you the argument. Do you understand what I did over here?
I agree. Wait, actually, I am not okay. I tried to look at this.
You need to basically look at a lower bound for this thing.
Wait. I'm actually not sure how this exactly works because it does depend on. Hold on. Let me just think. I think I see what this.
Aritra is getting. Could you yeah?
I'll explain once. I think this is done.
Wait, Aritra,
Because
I'm
Okay.
also
INJ have
almost done doing my
same
own.
parity or something like
Yeah.
that.
I'm
No,
also almost
INJ
done
don't
doing
need
it
to
on
have
my own.
anything. Honestly
Great.
speaking, there is no reason INJ need to have any parity. It's just some subset of the INJ are partitions of the set of all the AIs. So basically, this thing, I intersection J is the.
No, wait. Why is that true? Why is INJ का parity relevant?
There's nothing about INJ in parity. It's just you take any partition of the lengths, then the difference which you can get is going to be this.
Oh, but what if B gets that difference and not A? Like B gets positive difference instead of A.
Huh?
Like जो ये है. Okay, suppose I have some AI minus EJ greater equal to 1 by this thing. How will that finish?
No, you see here, fine. What we are looking at is the difference of whatever A gets and what B gets, yeah?
I
Difference
think
of
I
whatever
see
A gets and B gets is this boxed expression, yeah?
What?
It's just your wish, whatever I and J you want to pick, okay?
Sure. Wait, this. Why is it this? Like I is odd, B 8. Well, what is
No, I
actually?
is anything. I is all AIs in a set I and all AJs in a set J, such that I and
Sorry.
J is like a partition of N, and the intersection between I and J is nil.
हाँ मतलब partition का मुझे मतलब oh shit.
Partition
And then
वही है.
equal shit my God. And then they're like of equal sizes. Sure.
So basically the difference is just this term.
Oh, but like IN, it's not like A will pick I. Like, hold on, let
No
me.
one's speaking. It's
No one's
B's job.
speaking.
B will
B
pick
is making the
INJ.
partitions that way. Like he can
Acha,
just club up
B is
any
making
AIs and then just
what?
use
But
that.
then, wait a second.
A's job is done. A has done this and he's out. B is like, okay, I'll take your A thing. I'll split it up into whatever way I want. I'll make my I. I'll make my J. I'll put them together. I'll cut as I want, such that these things are equal. Since they are equal, I can just shove them. And now whatever I'm left is basically a difference of the partitions I had,
Wait, just
which
a
is the
second.
sum of all AIs in this.
Just a second. AI is like a piece or a cut.
AI is a piece. AI is a piece. And I is a set of the pieces.
I is a set of the pieces. AI is a piece. Sure, but then what if A picks from J? Like, yeah, like INJ hook करके हुआ क्या? Like, how will B use INJ?
The thing is, now you need to find a INJ. So, like, basically, have you realized that we can define the what you call the difference between the how much A gets and how much B gets? We can define this difference to be this thing. Yeah,
Yeah, but then B does not get to choose that.
B gets to choose INJ. Why not?
No, sure, B chooses INJ, but then A will not run according to B, right?
Sure.
Yeah.
Just choose the best INJ you've got and bound that.
We just need one INJ to work.
Like, yeah, exactly. Like, A will always choose the
Use a
like
global argument to show the difference between these two must be
Um,
less than or equal to whatever bound we want.
By the way, I think me and Aditya are both done with
Yeah, we
the
are both done with the first part.
first one.
I think I was having like different ideas, but like, yeah, yeah. I don't know.
But like the part we're working with is different from the part Ronit is working with, I think. So
Yeah, but the part which Ranithan is working with is the harder part.
how much positive are you? That is the harder part.
Very, very positive.
Great. See,
Amazing.
so the
Great,
idea,
great. Did I just hear that? Great. Huh?
let's just move
I
on
also
to the
agree.
problem.
Huh?
So the
Cool.
point is A1, A2, A2k plus 2, all this comes from the part 2 power n, 2 power n minus 1. Will you agree? Like we already did it.
Like greater than equal to, yeah.
Greater than equal to. So 2 power n plus 2 power n minus 1 is greater than equal to this.
I
Because this
agree.
all comes from that part.
I agree.
Now, this is greater than equal to 2 into A2 plus dot 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 plus A2k plus
Just a
2.
question before you do finish. Are you finished? You're done with
Yes.
the problem.
Yes, not the problem with one part.
What's that part?
1248 का optimum.
The part that for 1248, regardless of what B does, A will get that.
So just the case n is equal to 3.
What?
No, all case. So after
What's
all,
1248? What's 1248 supposed to mean?
Powers of 2.
So
Powers of 2.
we know the optimal
Partition
construction for
that
A,
A
right?
makes.
Wait, hold. We know the optimal construction for A, right?
we basically know it's like less than equal to 2 power n by 2 to the power n plus 1 minus 1. So we have the upper bound. Now we need the lower
Now,
bound.
given this optimal construction of A, we showed that no matter what B does, A will always get like at least that much.
Ah, yes. All right, I see.
And also B can also make sure A gets at most that much. So for that construction, the value of C is that, like what we wanted.
Yeah, but we don't need that. Basically, we have the upper bound. We need to prove the lower bound.
Yeah.
Yeah, exactly. Now I want to show that B can get.
Do you see why the upper bound was? I'll just tell once.
Oh,
So basically, A1, because we know A2k plus 2 comes from like 2 to the power n minus k. All the previous one, because that is also greater than 2 power n minus k minus 1, also must come from either n minus k plus 1 dot 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 to 2 power
or
n.
yes,
So this
yes.
sum is greater than
Sure.
equal to A1 plus A2 plus A2k plus 2.
Sure.
Because A1 is greater than A2, A3 is greater than A4. This is greater than equal to 2
Sure.
into A2 plus
Okay,
dot
yeah,
dot dot
clear.
A2k plus 2.
Got it.
And now we showed like by the our inductive hypothesis before A2 plus dot 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 A2k plus 2 is greater than this.
Uh,
Then 2 into this. So it's just contradiction because it is greater than and it is greater than. So 2 power n plus 2 to the n minus 1 is greater than 2 power n plus 2 to the n minus 1 plus dot 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 till 2 power n minus k. So we have contradiction.
I see.
This is the inductive hypothesis.
So what you have shown is the optimal optimal
We have shown the
construction.
lower bound basically.
What lower
Upper
bound?
bound.
There's only one
Upper
bound.
bound. We have done upper bound. We need to do lower bound.
There's only one bound. I don't get it.
We have
What are you
proved
saying, lower?
C is less than equal to, not C is less than equal to, C is greater than equal to 2 to the power n by 2 to the power n plus 1 minus 1.
So you're saying that we need to prove that B can make this happen?
No, we need to prove that, like, for any construction A does, like for A's construction,
Oh,
this
I
is the
see.
best. And like for
For
whatever
any
move
other
B does,
construction, B can get at least more than this one.
yeah, for any other construction B, there is some strategy for B such that B,
B
like,
will ensure
this is
A
less
gets
than
at most
equal to
leverage.
2 to the power n by 2 to the power n plus 1 minus 1.
Yeah.
Why? Okay, symmetry does not work for other strategies, so that is sad.
So now,
So what? I'm still a bit confused. So what you're saying here is that you're given the optimal construction, and
no, you
you
don't need
just
optimal construction.
then what is it you're showing? I'm not understanding.
Run it, wait. I'll explain. Suppose A does the powers of 2 construction.
Sure.
We showed that regardless of how B chooses to cut, A will get 2 to the n divided by 2 to the n plus 1 minus 1.
I see.
Yes.
I
And
think we
what
proved
we
C
need to
is
show
greater
now
than equal.
is
And
what
what
we need
Yeah.
to
what remains to be proved is for any cut of A, B will ensure A gets at most 2 to the n over 2
that
to n plus 1
difference.
minus 1.
Yeah, that difference.
Yeah.
Okay.
That is what you people were trying to prove.
Oh, this is very good. We're working in compliments. Amazing.
Yes.
Well, at least your compliment is done, so everyone can work on this compliment, which is good.
Yeah.
What
Or
was
at
your
least
idea?
that before.
Idea, by the way, like for
Okay,
anything
fine.
A does, B has to have some idea. So, what is your idea for B cut? I don't
Sure.
want to know the numbers, but just give me the idea.
There are no numbers. Don't worry.
It's
I
Look
see
at
only
everything.
numbers written here, though.
There are these are all variables. This is all you are doing practical physics, we are doing theoretical physics. Put it that way.
How did
Okay.
physics come? But okay.
I don't know. Like IPHO just one. Take it that way.
Sure.
Fine. If you don't mind, I'm moving some of your stuff away because we need space. And you guys have not been good. You're not giving us space. Okay, fine. So you're giving A's construction. A does whatever the hell it wants. A is done. You move that aside. So now what you're doing is first I'll give you some heuristic idea of what we're doing. You remember from before that when we ordered all the lengths after B does all of its cuts, we want that most of them cancel out with each other so that in the end we look at that last thing and try to bound on that because that is just simpler. Okay. So you got the heuristic idea for what I'm going to say. So now what it is that P's goal is to now partition whatever A has given it into equal pieces and then you can just shove them out. Okay. Just a minute, I'll just close the window. Okay. So now what you do is you take a set I and you take a set J. And
Okay.
I and J are a partition of the set of all the lengths A has given us. We are B. Okay.
Right.
So basically, intersection of both of these sets is null. Union of both of them is the whole set of whatever A has given us. Now what we do is we take all of the lengths of A, we put them together. Okay. Lengths of I, we put them together. Now we take all the lengths of J, we put them together. So we get these two massive blocks with divisions. So now is the time for some drawing.
But I have proved another thing. If A does any cut, which is an epsilon.
Just a minute, like Aritra, and just a minute. So assume that this is the thing. This is the I block, this is the J block. Okay. Okay, this one illustrates the idea better. Okay, so this is the thing. Are we clear so far? Like Arham, Aritra, and Divas?
I think
Yes.
so.
Yes.
Okay, so now once you've done this, remember that like B has a finite number of cuts, that's n. So what B does is it looks at the leftmost cut over here, which is in this case here, takes this cut. Okay, so you know what? I should use a different color.
Oh.
And cuts this. Okay. Now he does this again, cuts this. Do it again here, cuts this, and so
Okay.
on. So like
Got it.
this, this, and this. Okay. So you see, we have completely eliminated J. Whatever is left is this thing, which is basically if suppose I is equal to, like if suppose AI are like the set AI is are all the is what I is made of, and the set AJ is what J is made of, then the difference is AI. Wait, sorry, it's a summation now. AI minus AJ, right?
I see. I see. And you want to
That's it.
prove this is less than equal to that.
Yeah.
This this is such a good formulation. I see why this.
Arun, they were
Yep,
saying,
yep, yep.
did
Yep,
I?
yep. Also, what
Yeah.
about this part? Like,
So-
what happens to this thing?
That thing is like what's left out. We need to bound that.
That is
thing.
the summation of like
Oh.
AI minus summation of AJ.
Oh,
That
right. Yes,
is
yes.
equal to this. Aram,
Got it.
Yes.
Oh, this is
okie
cool,
dokie,
actually.
everything.
Yeah, I think I see.
Yeah.
Now everyone full reign on whatever the hell you want to do with this.
What is the all possible combination of AI and AJ? Like we can do some PHP argument maybe with some all possible combination. What you have done that
Oh, that's
AI
an
AJ less
idea.
than equal. Wait, did
Wait,
you prove
what?
AI AJ less than equal to 1 by 2 to the n minus 1 minus 1? Then we'll be done, right?
Yeah, we need to do that.
Oh, to prove. Okay, I see.
I mean,
I
like,
thought
shouldn't we just, for the sake of contradiction, surely we can do something like,
Wait,
what?
nothing.
see.
Wait just a minute, I'm like thinking.
By the way, another thing is I don't think it is needed for the problem. If A does any cut which is epsilon,
Yes.
then basically you treat it as the same cut. And what B can do, because there will be like n minus n segments now at most, what B can do is like basically half of every segment B has. So for each segment A takes, B takes the other segment. So like A gets half only. So A can't do any epsilon cut. That can't be part of the optimal strategy, some epsilon cut. But I don't think this is needed right now.
Oh, that is.
At least you have done progress.
Yeah.
I think we should try P4 for a while.
Wait, I mean, like, surely,
Like
I mean,
we're close. It's very close, I feel.
Ronit, how are you proceeding? Are you just adding stuff up or what?
how am I what?
Proceeding, like,
How am I proceeding? I am thinking of what Aritra just said, which is look at all possible summations of AI and then
So
just choose an AJ which works for you. Issue is AJ is
see
already
that
fixed when you pick
matches,
sort of
right?
AI.
Because all there are actually 2 to the power n plus 1 possible sums. Because after S cut, they're like B1 till Bn plus 1. So there is 2 power n plus 1 possible sums. So it matches with your argument of 1 by 2 to n plus 1. I don't know how. The number of
Wait, can you
possible sums
explain?
is that.
Aritra, what do you say?
So basically, after A cut, say the pieces are B1 dot Bn plus 1.
Okay.
And
After n cuts, wait, like how
after
are we
A
doing?
cuts, A cuts.
What is A?
Very capital A
Like
is
the
in the point
clear
of A.
A,
Oh,
capital
after
clear.
A cuts.
Like
Okay.
before B is cutting.
Okay.
Say this is the pieces. Now all the possible sums with these pieces there are like 2 to the power n plus 1 possible sums. That's what I'm saying. Then
Sure.
some might be same, but there are 2 to the power n
What
plus
do you
1
mean
possible sums.
there's that many sums?
Like subsets.
Like B1 subsets, some of the subsets. Like you take, say this is S, you take like G being a subset of S, such that summation of G belongs to G.
Wait, hold on.
Something
How
like
do you
this.
know they're all distinct?
They are not.
I don't know.
Like
They are
we know.
not distinct.
Yeah, they are
Wait,
not.
Take it as a
what are you saying?
multi-set.
Huh?
I don't get what you're saying. Wait, what just
Yeah,
happened?
yeah. What is this G summation G? Like I
And
don't
what's S?
See, S is the multi-set after A's cut, B1 till Bn plus
Okay,
1.
I see. I was doing exactly this, but like I was not looking at subsets. I was just looking at like removing one element.
Okay,
Just
now what are
that's
we
No,
doing
amazing,
this
right
Tanuja.
now?
But
doesn't
like,
like this. I don't know. I'm just giving the heuristic
what's
idea
BI?
why
What's
this is
BI?
what.
What's
BI
BI?
is the length after A's cut. Like B does not cut till now. After A cuts, there are like n plus 1 cuts,
Like
right? So
these are the lengths that B receives.
Oh,
yes,
how are you ordering them?
You don't
you're
care.
not ordering. You're just
The order
putting
doesn't matter. They could be in any order.
like it is a
Sure.
multi-set. Consider.
But like, how is it Bn plus 1? It's B2n plus
No,
1, right?
like A
before
has
B
cut
cut, after only A
and
cuts.
yeah.
So you're only looking the difference between two B cuts.
No, after A cuts. B has no nothing to do with anything right now. Only
So
A cuts till
B1,
now.
C1 to Bn is just A1 to An.
No, A1 to
Then
AN was the largest. Like, see, you have a piece here, right? See, like
how? Sure,
n equals to 3, right?
sure.
Then like A cut something like this. So this is B1, this is B2, this is B3. Like B does not cut
Those
till
are
now.
your A's, nah. What are you talking about? Those are your A's. That's how you defined A. These are the
No, my
pieces
AI is
after A
after B
cuts.
cuts. My AI is also after B cuts. Like AI and BI both cuts, then they are AIs.
So you're
Here
saying
only
after
A cuts.
everyone is finished doing whatever they're done, after everyone cuts,
No, like not for our case. Only A cuts. B does not cut till now.
B does not cut till now. So
Yeah.
this is all of the AIs. I don't understand.
AI is after A and B cuts, and B is after only A cuts.
Okay, you are working with your AI. I am working with my AI. My AI is whatever we've done till now.
Okay,
I
yeah,
and J are
your
kind of
AI.
AIs.
See, okay, your AI. You need to
Why do
clarify
you
your
make
AI and my
AIs?
AI.
Wait, first answer me this question. Why are you making all the AIs whatever B cuts?
That's like I thought of, and A is less than A comes before B, and I thought of that first. So A is like that. Whatever.
Ram.
See, your AIs, we take AIs, A1 to AN
Sure.
minus plus 1, okay?
Sure.
And now
Yes.
there are like 2 to the power n plus 1 possible sums of the subset of something, like AIs.
No, but
So,
they don't
so
need to be
might
distinct.
connect somehow to this and that. I'm thinking how to connect two things.
But they don't need to be distinct.
They don't need to be distinct.
Multi-set.
Multi-set.
Oh, fine. Multi-set, sure.
Okay, now what is G?
G is a subset of S. Like this is the formal way of writing. Like the
Okay, G is
subset
a
of some
subset of
sum.
S, but like what?
He's just picking a
Nothing.
random
G is any
I.
subset of S.
Aram is just picking a random I from before that I and J. He's just picked an I and J is like anyway fixed then.
Yeah,
I'm
working with
confused. I still am
sets
not.
like looks better. So
What do
Wait,
you
but
mean?
like,
What is
Yes, Tanishka?
is the reason you're working with just like AI? Okay, wait, you changed the definition again? What?
He's done, I mean, until now, the only thing Aritra means to say is that the number of possible I's that exist is 2 to the n plus 1.
what is I?
Is what?
You
the
know,
number of
remember our
possible
I's from
sum of
before?
subsets.
I's like the after we order them.
These multi-sets. Yeah, you remember this thing?
Yeah.
Wait, can you
That
explain
I.
what I is again? Capital I.
Capital I is the ideal. No, it's not.
Nah, ideal.
No, it's not.
Amazing.
It's just a random partition. I and J are a partition of the set made by all of the cuts of A.
But why is it random?
it can be anything B chooses. Now what we are doing is we are being smart as being B, and we choose an I and J such that that sum over there, that difference of sums, is the smallest. Aritra is just saying is that the number of possible i's there exist is 2 to the n plus 1. And I don't see
So
like 2
there
to the
might
n
be
plus
some
1.
PHP argument right now. I'm thinking if there is
See, like,
any.
why are we overcomplicating B's strategy?
Wait.
It's not
Okay, guys.
overcomplicating it.
See, B's
I-
strategy is B gets like n plus 1 blocks, right?
Yeah.
And B has to make n more cuts. So
Yeah.
for each cut, B looks at the largest block and cuts it into half.
That is not the strategy.
That's not the
Why
strategy.
is that not the strategy?
That doesn't work. So.
Wait. I think that. Wait. Okay. I think I did something similar to that. It seems to work. I don't
Why
know.
doesn't it work? Yeah.
Wait, hold on. So like by induction, you just cut the largest guy into half, and those you
Yeah.
will get 50-50, and rest you will do the like something similar.
No,
Like-
like rest is now again you look at
For
once.
the rest, assume that the rest things don't follow one like powers of 2. Then you can get something like just come here, idhar aa jao. Like I did random calculations. Suppose the entire thing is in powers of 2, then you take like
But I will give you a contradiction with that.
Can we do like some backwards induction?
like this is induction
Adam,
only.
that is not true. See, this thing, like you can't just halve the maximal thing. That doesn't work.
Why can't you have the maximal thing?
Not
as B?
maximal.
I'll say.
Yeah,
Adam,
wait, let her
see,
use
for
that.
the case for n equals to 1, if you do the
Sure.
curve, cut in like half. So this is half and this is half. If you cut the
Huh.
maximal thing, so it is not good because you can get half and 1/4. You need to do the epsilon cut now. So that's not how it works.
Wait, what? 1 के लिए there is only
half
one
and
cut.
1 के जो तुम्हारा कंस्ट्रक्शन है रिद्धिमान वो सही नहीं है. Point ये है.
3/4. And
Like A can do anything, right? If your thing is like do the maximal thing in half, then n equals to 1 doesn't work. It doesn't work for a lot of cases. So B can't use this strategy. That's
Wait,
what I'm
then
saying.
why does this calculation
so I-
fail then?
Like a
these
random case
strategies
might work
still-
doesn't mean that all cases work. I
No,
know
but
logic
then I
I
don't
says-
see where this calculation failed.
this calculation, which calculation?
Yeah.
Oh, I just realized it's Aram who's looking at the chat.
We can gain at least this many, and then
Really?
added half.
Yeah, this is okay, but like this is greater than equal to, right?
So like Tn plus 1 greater than equal to, like it is equivalent to this, which is like surely like yes, true.
What is Tn plus 1?
It's
But
like
you need 2 power n, like this is too weak, right?
no.
Okay, wait. Essentially,
it
the
is too
problem
weak.
is
I
if
agree.
B
I
tries
don't
to
see what is
half the
wrong.
largest
Don't care.
piece.
Just a minute.
No, like if even if this weak condition holds, then like it works. That is what this is.
Ridhiman. The problem is if B tries to half the largest piece, but there's 2 largest pieces, then A just takes the largest piece, but B gets half of that largest piece.
My point is that by induction, if you remove the largest piece, then the remaining part is just same. So like whenever A picks off the remaining part, B will do the winning strategy in that remaining part. And whenever B like A picks a half here, B will pick the half here.
Okay.
So like that is the strategy I'm suggesting. And that should work.
I don't think
guess.
that works.
Or maybe no, forget this largest. Okay, the
No.
issue is that this strategy does not really take advantage of 2:1. That is the only issue. But then I'm not sure why this fails either.
Just think of the Ronit case, like that is just work. That should work because like some PHP should have like 2 to the n plus 1 minus 1 in denominator.
Sure. But the point is for
Aditya, I
n
still
equal to
don't
1,
see
there is
where
no
you're
base
getting
case.
PHP 2 to n plus 1 from. Can you explain that?
Okay. Can you just explain to me like whatever progress you are making or whatever you're trying to do?
Yeah, what is this 2 to the n plus 1 PHP thing?
No, I don't know. So the possible number of sums is 2 to the power n plus 1, right?
Wait. Can you explain to me from the beginning
What is
Ronit
the number
doing?
of possible sums? What do you mean by that?
Form S, I wrote if for any subset G is summation of G
But
belongs
what
to
sum
G.
are we looking at? Why are we looking at
All
that?
sums, all possible sums.
Arey,
Like
wait, can you
A1,
just
A1 plus
Right.
A2,
इसके बाद
A1
क्या
plus
हुआ?
A3.
After looking at this sum, what are we doing?
Nothing. That is just an idea. I'm thinking
Can't
what
we
will mean.
just do like
We're just looking for now. We'll do something later. Okay, see, yes. Ronit, I think I'm done.
You are
See,
wonderful.
What?
see, this is there is 2 to the power n plus 1 minus 1 possible sums. Like,
Aritra,
if we
I
don't see
suggest,
zero.
Aritra, I suggest like you just confirm you're done. You think of a good way to say it. Because right now, what you see, you're getting very confusing. Just like
Right.
think it through once. I also
So
think that
we take
we are not
G
far.
being a
Just a minute, Aritra. I'm saying think it through. Don't worry, just take a little bit of time. I also think that we are not far from here. I mean, I don't think it's going to be far from here at all. But we still need to think. Just
okay,
think
wait,
about what you
before
want to say, and then
yeah, I'm
be-
sure.
before
Like,
before
like
we
AI
can
minus
do an
AJ,
honest
if we
process.
prove that is less than 1 by 2 to the power n plus 1 minus 1, we are done.
हाँ
It's
तो
okay.
why are we done?
Even
Like,
one
what are
sec, one
AEs?
sec. One sec.
Ronit, can you explain?
yeah,
But I'll just explain the part to Ronit. If this is correct, then Ronit can explain the full thing.
sure, fine.
Then we take S being A1 dot 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 n plus 1.
Sure. You take a subset of that G. Fine.
And now we take all the possible subsets.
Sure.
Now, because they, if we don't count 0, like the null set, then there are 2 to the power n plus 1 minus 1 possible these sums.
Yeah.
Now by PHP, there are two things which lies like AI minus AJ should be like 1 by should be less than equal to 1 by 2 to the power n plus 1 minus 1 by PHP.
What?
Not AI minus AJ, like
The
the
difference
sum.
between two of the
But the 2 to the n plus 1, you don't know if they're distinct. Only if they're distinct can you use PHP.
no.
If they're not
But then
distinct, the difference is 0. So like that is also less than 1 by 2 to the power n plus 1
But
minus
then how
1.
can you guarantee 1 over 2 to the n plus 1 minus 1? You still can't guarantee that. It's going to be something crazy.
0 is less than 1 by 2 to the power n plus 1 minus 1.
Oh, lekin you're
like he's saying
Like
कि
the,
if two of the subsets are same, then like just take that.
yeah, if two subsets
Okay,
are same, just take that to get it 0.
by
Then it's
this
still less.
PHP.
Wait,
My
people,
question
did we
is,
misread the problem?
अबे ये कहाँ से आ
No.
गया?
Bro, what?
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 Wait,
What?
okay. The problem says they make at most n cuts, not exactly n cuts.
What?
No way.
No, I have proved if it does not have n cuts, then B can do half. Like epsilon cuts are like n cuts only.
He'll just do half,
Epsilon
right?
cuts are like n cuts, so like less than n cuts. So we don't care about less than n.
हाँ,
They're
if
just
he does
epsilon.
fun cuts, then like each segment can be made half, and then like हो गया खत्म
How?
half. Like if B can make if I can make only one move and B can make two moves, then we are done now. 1 by 4 ऐसा. Just divide all the compartments
See,
into half.
no, the point is if you do like more than n cuts, you have a cut, and
Less than n cuts.
you want to do less than n cuts, like, and you do like n cuts, you can just do the epsilon amount besides one cut, and because the epsilon is small, that is chosen at the last, so that doesn't matter. So like
Okay.
if you want to do n
yeah,
cuts
that
or like
makes
less than n cuts, that doesn't matter because you can do the
नहीं.
epsilon cuts.
Wait, this logic is kind of
Just
flawed because you don't know who is getting the epsilon. That depends on the parity. I think
that
the
does
better
not depend on parity. Epsilon is there at the last, right? So nobody wants to take it. Like it's not who is getting an epsilon. Like it is at the last. Nobody will take epsilon.
नहीं, but if B gets epsilon, then it is actually beneficial for him to do less cuts because he's getting epsilon more than like if he did more cuts. I think the
point
better
is there
logic
is no
is that
epsilon. There is no epsilon cuts. Like epsilon is just same as no cut. There is no point of having epsilon cuts and no cut. There is no problem difference to the problem. Like how moves the progress? Because if you do like this epsilon, like if you have something and there are like 1,000 cuts like this.
but like that epsilon to B control करता है ना.
See, there is like one epsilon. Whoever controls.
Oh
Wait.
shit, I got the finish. Oh yes. Ritra, you're a genius. I don't know where the hell do you get a PHP, but like that works.
Can someone
Yes.
explain?
See,
No.
first, for Riddhiman
See,
thing,
Ronit, I
if there
think
is
you
an
understand
epsilon
what
thing
he's done.
here,
So
What
first
is
you
it,
tell us
Anand?
what he's done, and then you tell us your finish.
Bhai, I
Sorry.
don't even know what AIAJ are exactly.
Fine. I'll go through the
that's
whole
okay.
thing.
Like
Don't worry.
for the epsilon thing, like less than n cards, and if you have epsilon, then like at first, if you don't have this card, then you can just take this. Say you take this, and this. Some players take something. Now, someone takes epsilon at last. If the epsilon card was not there, then nobody would have taken like epsilon. Epsilon just matters like 0 and or like 0. So it
No,
doesn't
but
matter to the game.
the point is that
Yes.
B is setting the value of epsilon. So if epsilon B is getting, then he will try make epsilon big, na? Like slightly bigger.
There is no point B is getting. It's not like you're replacing epsilon with some other number. You're making another epsilon. It's not like you're making a big number epsilon. It's more like you're making 0 epsilon. There is one extra cut.
I
It's not
mean,
like if A does less than n cuts, then B does more than n cuts. The number of cuts get reduced. So there is nothing to the problem which
I
makes
mean,
I see
my
why. I
logic
see
was
why that's
simpler.
fine.
Just like B will just half each compartment because now he can't do that.
right. But like there is nothing difference to the problem statement what I'm trying to say. With
Sure.
A doing less or more.
We
Sure.
technically misread, but it's okay. Bach gaye.
Do you see why G minus G dash is less than equal to this?
Wait,
I mean, like,
let
why
me
is
try.
it 1 by
G minus
Let me
G dash
try.
is like
Let
what?
me try. Okay, wait,
I
hold
think
on.
I see,
Ronit,
but I'm
explain,
not
sir.
sure if what I see is what you want. Oh, I think I
Ronit,
see. Yeah, I see.
explain.
I see.
Okay. Well, Rithiman, being better, I'll say, do you see? But I'm not sure if you do, but I think you do.
I see, but I'm not
I
exactly sure what AIAJ are. I'm not sure how this finishes.
okay. My question is, before when I explained, you said you understood. Now you're not. So what
I
exactly
thought
have
I
you understood
understood.
until now? Like I'll ask all three
I
of
don't
you.
know. Like while you were explaining, I was just working on my own.
Wait, Ryan,
When I was
it's
explaining
like
to you, you
open
were working
this.
on your own. Okay, sure.
I
No,
know what
yes.
AIAJ are, but what after that?
Okay,
Okay,
you know what?
these
Capital G
are
minus
after
capital G
A's
component.
cuts or B's cuts.
Okay, you know what? I realized that like having four people say that whatever they understood is not a good idea. Let me just start from the start.
exactly.
Yeah, please.
Okay, so look down. That's where I'll write. So you have A. A has done its cuts. He's done his job. A is
Yes,
gone. A
yes,
is
sir.
given this to us, B, and B is thinking because of whatever heuristic argument I gave before. I will not get into that because if you fail it, you didn't listen. Then like it's fine.
Sure.
Just trust. It's magic now. Okay. So what B wants to do is he wants to cut it into pieces such that you always have two pieces which are the same length, okay? So that at least max, so that you can just shove them away.
How
A
do you
will
always
choose
have
that
two
and B
pieces
will
of the
choose that.
same?
Sorry?
What do you mean you always have two pieces of the same?
So basically, you're given whatever A has marked. B
Yeah.
wants to mark, which is us. We want to mark points on the stick such that whenever we cut it up finally, what will end up is A will take a piece and B will take a piece which is exactly the same length as that.
Okay.
And then last mein one by at least this guy will be this much will be left, and then that
So we're
E
looking
will
at the
get, and then the
smallest
difference.
possible difference between the two, whatever,
Two
their
those things.
sum
Huh.
of the thing. We're just looking
Okay.
at the minimum possible difference between the two. So that thing now, the way we do this is we look at the set of, what do you call, divisions that A has given us. And now
Okay.
we take a partition of them. Okay. We take a partition of the set of these things.
A partition of what?
So how are you
A
exactly taking
partition
the
of
set? Are
this.
you
I just first say what that partition is. A partition of the set of the lengths A1, A2, A3, A4, AN plus 1.
so like
What is
A1,
a
A2 are
partition of
like
the set?
are they the compartments, or are they from the beginning? So like is A1 this, A2 this, A3 this, or is it like A1 hai, ye A2
It's
hai?
from beginning, I think.
It is
It's
from
from
the
the beginning. It's from the beginning. Okay. So
Oh,
basically, it's like instead of A marking it and giving it to you, A has cut it and give it to you. And then you're partitioning the sets of small sticks you have left. Okay. Everyone got so far?
Sure.
Okay.
Yes.
Wait, what do
One-
you, I still don't see what you mean by partition. Like, what are you going to do?
He's part.
Assume that instead of A giving you the stick with the marks, he has
Yeah.
cut it already for you.
Okay, fine. That's
It doesn't
okay.
make a difference, right?
Yeah, it doesn't, obviously.
So now you've got this sack of very small sticks. You make a partition between them. You have one set and another set of sticks, where no
Sure.
stick is in the same.
You could have just
Bang.
said divide those sticks into like 2 groups. Okay,
Bro,
I
sure.
that
said
is partition
partition.
only. Go
Partition
on.
should have been obvious to you. I don't understand why you think divvying up is
Okay,
a better word
fine.
for partition.
Fine. Okay.
Okay. So one of those sacks is I, one of those sacks is J. Okay.
Okay.
Now you take I and you put the sticks side by side each other so that you get a long stick, which is basically the sum of AI. Okay.
Sure.
You do the same thing for J and you put them together. Obviously, since both of them are broken, you can see where the divisions are.
Okay.
So let's assume that it's this thing and this thing.
This thing and what is this thing?
Are these are the sticks of I
The
and
sticks
sticks of
made
Ah,
by
okay.
putting I side
Fine.
by side.
Yeah,
Okay.
yeah.
And these are your partitions. Like we'll just assume it's this.
Oh, now I sort of see what Aritra meant by the sums, but I'm like still not fully sure. Okay.
Right. Don't worry, I'm here. Okay. You look at the left. Now you look from left to right. You look at the leftmost division you have, which over here is this one. Okay.
Sure. Sure.
This is the cut which B makes.
Okay.
Then उसके
Okay.
बाद ये and then ये.
And then this one, and then this one, this one, this one, this one. Notice that does two things. Actually, yeah, it does two things. It
Equation.
makes sure that every piece has another piece which is the same length, which have the same length, and it also ensures that what do you call the number of cuts that B has made is exactly the number of cuts A has made, because you're literally just
Yeah.
copying it.
Right.
I
Literally,
agree.
like what we've started all along, the copycat idea. This is one part of the heuristic of why you do
That's
this.
crazy.
हाँ, but
Okay.
like, what if one stick goes like आगे चला जाता है? Like one stick is I. अच्छा, you get to pick I and J, right?
I get to pick I and J. I have completely free will on that.
Sure.
Okay, and if there's like two
And then if
of
the
like
difference
I
between I
cuts
and J,
in between
okay.
J, and then you just do both of them, right?
Two people speaking at the same time. I don't know.
Wait, like, okay, wait. I will draw and show. If you have like something here and you have something here, if your cut
Just a
in
minute.
J is
Just a
here,
minute.
and if you have two cuts here,
Just a minute.
okay, bro, we make both of these cuts here, right?
Yeah,
Like for this also we make one, and then we make one here,
right,
and then we
right.
make
We
one
made
here.
all the cuts.
Okay, fine. Then all right. Aritra, do you want to continue, or should we wait for Ran?
I think
Uh,
I think
you
I see the
see,
finish.
this is like you see the symmetry part, but there is only one extra thing left,
Yeah.
which is the summation of AI minus the summation of AJ. Do you see that?
Exactly, that is extra.
Yes.
So you want to minimize that.
So I
Because
have to
Yes.
minimize this. And to minimize this, I use the sums idea.
Oh, okay. We are clear? Yeah.
Yes.
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 Wait,
And
Ron,
now,
I think I got
like
that.
I take some subset, take AI to be some subset, as AJ to be some subset. Because
Okay.
there is 2 to the power n plus 1 minus 1 proper subsets. When I like put this in a number line, there are like 2 points at least. 2 points can be same. In that case, it's 0, and that's great.
Exactly. And then if not, then you divide them into
If not,
intervals
there
of 1 by.
is some g and g dash such that g minus g dash less than equal to 1 by 2 to the power n
Oh,
plus 1
bruh.
minus 1, which just
And then-
proves our thing.
And then like
Oh, wait, this is nice.
That's nice.
oh, yeah.
Dun,
So
ta-da.
we are done with P3. That
This
we
is
That's-
took
so
four
that's
of us.
2.5
took us
hours.
four
We
hours.
took
2.5 hours.
2.5.
2.5
With
hours.
6 people, 2.5
Wait.
hours.
Wait,
I'll
count
just like
me out.
think
I did
about
not
this
do a
for
single thing.
like 2 more minutes.
Sure, you have until 8:30.
Look, there is no way four or five of us, whatever, took
Wait,
4 hours.
Aritra, what do you mean put the 2 to the n plus 1 subsets on the number line?
Why don't
Like a
let me
sum
try?
of the subset.
Some of the subsets.
Like
The
A1,
sums.
A2, A1 plus A2, A1 plus A3, A2 plus A3. You put all these numbers in the number line.
Okay.
And now you want to find this distances.
But
And because PHP, you know the number of points, so you know there is
yeah.
some distance
Which
which is less than equal to
than
1 by 2 to the power n plus 1 minus 1.
But then how do you know
But
like
do you
those
need
two
to
are
say partition?
disjoint? How do you
It
know those
doesn't
two
Why
matter
don't we
if those two
disjoint?
aren't
The R
disjoint.
can be
if
same.
Then the sum is
the
zero.
same, then we just remove them.
If those two aren't disjoint, if there's one coming on top of each other, then the difference is anyway zero.
No, I don't mean the sum is the same. I mean
Ha,
this
ha, ha.
sum
Wait.
subset.
But we actually don't care
Yeah,
about
if
that.
there are two subsets which sum up to the same thing, we can take that, and that also gives like summation of AI minus summation of AJ, which is 0. So in that case, that is 0
Okay,
is the
wait.
lowest.
I think I figured out the answer to my own question. I don't know if that is what you were saying. If this is like AI1, AI2, and like AI whatever, and this
L.
is AJ1 and then whatever.
Ha.
If something is common to both of them, you like remove it,
Ha,
and
ha.
the
You remove and
difference
the
still
remaining
remains
have
the
the.
same.
Exactly.
Okay,
The
fine.
difference is same. Yeah.
The
Yeah.
difference is still the same. Okay.
Like you
So
can make two disjoint then. These
sure.
two.
Wait,
Great.
did
Can someone box this?
anybody
I'm
sweep the
boxing.
IMO this year?
7 people.
Not
Seven people have swept.
That is insane. It took us 4 hours. Is
see
it
one
Seven
five,
people.
China
six,
person I
whatever?
think did P3 and not P2. So like
I mean,
Fair.
one China person, like three people from China did complete perfect score, and one
China.
person got 32. That person's gonna get properly sliced, cut up when he gets back to China.
Why?
we should not say that.
I mean,
Wait,
did any of you
it's on
guys see the
YouTube.
YouTube video about the Chinese IMO team?
No.
Yes.
Wait, guys, check chat.
Basically that. Wait. Who did this? Who did this? Oh shit. Wait, hold on. Like, just give me a second. I'll do this. Okay.
Okay.
I assume you guys are checking the chat because I am boxing this.
Chat as
What
in
chat?
Zoom ka chat. I'm not saying YouTube ka. Wait, I haven't even checked YouTube ka.
Aram is doing that, don't worry.
Wait, let me also open. I want to open and see.
Archit message for like he sent one message and then I don't know if he's still there.
I mean, okay.
I hope P4 will be a little bit easier than this.
Yeah, Tanishka, after
Like
before.
probably.
Wait. I have to go then. Like I wanted to before.
Oh, you have
Tanishka,
done
it's just
this.
dinner. Come on, you can surely do some adjustment.
Yeah.
Okay, then I'll probably just bring it here. But at least can you wait for like 5 minutes?
Yeah.
Sure.
Let's all take a 5-minute break, drink water because my stock is out.
Sure, still.
We'll just have a snack and come back.
What did you say?
I'll just
No
have a
idea.
snack and come back.
I have no clue what he said.
It took us 2.5. Tanishka was actually correct with the time. How much time it will take us.
Aritra, do not start working on the problem until we all are there.
I'm just doing P5 a little bit.
Nah,
You
that's
no
cheating.
no
See,
no no
okay,
no
so
not
Nah,
happening.
nah, you are not allowed to do that.
Bye bye.
no, it looks interesting. Okay, I have seen the problem. That should be enough.
Sure, bro.
Okay,
I am back. What's up?
Uh, uh, whoever is back, turn on their camera.
No, I want until you all come back.
Ronit, you turned on your camera. That means you're back. You're
I am back. Oh frick.
yes.
Are we taking a break or not?
We are. Whoever is back from their break can join in.
Okay,
Can
so
turn
what
their
happened
camera.
over here? Why is everything weird?
Oh yeah, I'll take care of that while I'm on my break.
Okay.
We'll now do 4, right?
Sorry?
Or 5. Which one will we do? 4 or 5?
Order में जा रहे हैं ना? So like 4.
Okay,
Wait,
works.
wait. What is the probability we finish
Before
everything?
12:30?
Before, like, yeah, at this rate, it'll take us 4 more hours, which is 12:30.
Bro, that means 8
I
hours
mean,
done.
I mean, if you look at the scores, people have coped on P3 more than they have coped on P6. So hopefully P6 is not as hard as P3. So we've taken 4 hours now. We should
Push to
surely
4
finish in
hours.
4 hours.
Yeah, hopefully.
It's actually we swept day 1 within 4.5 hours.
Bhai, 6 of us did day 1 in
Count
4.5.
No
me.
write up. No
I
write
didn't.
up.
Oh,
Oh,
no
yeah.
write up.
Works.
And then actually,
I mean, that won't take much time.
Bhai, people actually have also swept day 1 on their own in contest. This is absolute cinema. I have no idea how people are doing this work.
Wait, what are you saying?
He's basically wondering how Chinese people are so good at full solving.
Are they just
Uh, wait, who has made like a bunch of random scribbles over here?
Where?
Wait, is my meal cooked? I will reload 1 second.
And anyone who's back, turn their camera on because then we'll realize you're actually back.
Okay. Why is are people already starting with FE?
No, just Aritra being Aritra and not waiting for any of us.
Okay.
no,
Uh,
I was not being. I just saw like one substitution which looked good, so I put it.
We are
so
doing P4,
essentially you
right?
did
We are
I
exactly
not
was
doing
not
FE
doing the
right now.
problem. I just like put one substitution.
so you did exactly what Ronit said you did.
That's not the case.
It's not the case.
What?
I'm like, sure, okay, that's not the case. I agree.
Putting one substitution is not equivalent to doing the problem, working on the problem.
So 2 substitutions should also not be. So working on the problem is not working on the problem.
Contradiction.
Uh,
Great.
This shows that IMO day 1 can make us all high. I forgot this is recorded.
So
Shit.
I think like doing both P2 and P3 in contest is I think very challenging, but yeah, like both are
I think
quite
P2 was
hard.
I think P2 was doable. P3 was just hard. Like.
I think P2 for geomains, like, see, Riddhiman wanted to do isogonal conjugates, he wanted to do MMP, he wanted to do Linpop, he wanted to do Barry. When you're having all those thoughts in your head, you will
I did not
overcomplicate.
want to do Barry, MMP. I just mentioned once. Isogonal conjugates.
I am
just
so surprised. Ridhiman did not mention invert once. This is the first time in eons.
Where do you invert in this problem? This is just pure POP, like kuchi bhi.
Don't
Invert
care.
is also
Like,
POP only.
I'm looking for angles in the problem. I don't think I can find one.
I can find one angle. It's angle BAC. It's a very good angle.
yeah, exactly. That's
Hey,
so true.
why
So
are you
true.
blaming me? Those are the best inverts.
Okay, wait, like if we're all back,
But
then
I
we
think we
should
should
start.
start now.
Or
Okay,
This
yeah.
would
we
be
should
like
like
I'm back.
actually take a proper break.
Yeah, like this is not supposed to be a proper break. Or
Okay.
Tanishka, can you type how long
I
it
exist
will take
now.
for you?
Let's go.
I mean, we can't do the YouTube live stream like start again, end it, start again, right? We have
We cannot,
Oh yeah,
bro.
I am officially
yeah,
back.
unless we do like day 1 and day 2, two different things. But yeah,
I mean, I'm
Nah,
pretty
two
sure
different.
people
We
are
do it
not
in
watching.
one sitting.
I'm pretty sure people are not watching the Livesolve in one
Wait,
stretch.
there are 10
So they
I
are
don't
people.
think
also taking a
anybody's.
break. We know you people pause and take breaks. Okay.
Can we just hide random Easter eggs here because people are not watching anyways? 10 people. Who was
There are 10 people.
one of them is Arham, I guess. Bro,
Damn.
that is just insane.
And I am pretty sure like 5 people are just they've left the tab open.
Ha.
No
Oh,
watching
you
Wait,
too.
wait.
There's like 8 people.
There is a
okay.
person watching.
I think we should start with
Please
P4
let
now.
us
We have
start.
wasted enough time now.
Okay.
Yeah,
Oh, wait,
please.
one of those people was also me. That was also in my tab.
Oh,
Wait,
I
also
see.
opened
I
it
told you.
now.
One of them
I
was
think
you.
we should just farm for engagement at this point.
Wow, there's lots of people
Where are
who
the
are watching.
problems?
I am
Ron,
just
where are the
teaching this.
problems?
Thank
Come
you.
on. Where are the problems?
Oh,
Ron
मैंने निकाल दिए थे. I mean, I was in fear that Aritra will do something. Aritra,
I did not do anything. Like don't have
you did not
time.
do anything like Aritra.
No,
Yes, see, whatever is.
I just saw something. I wrote it. It doesn't mean I was doing the
He
problem.
put
It's just I saw
triangle
something.
measurements of his choice, and then he does random things. This
Okay.
has
Wait.
Wait, we're doing
Oh, yeah.
P4 or like
P4,
because
P4,
P4 is also
P4,
coming.
P4.
P4. Yes.
Sure.
What?
Theta is an
Shanyu
angle.
nahi. Like, what is Shanyu?
Change the name to A and B again. Abel and Vairav.
No.
Yeah.
Abel and Bhairav, yes.
Alo and Barata is superior.
Nah, bro.
Ron,
Hey.
someone wants you to fix your mic.
Someone wants me to fix my what?
Your mic.
Mic.
Yes.
My mic is
Ronnie's
not
mic
existing.
is fine.
I don't see any problems with it, but like still fix it.
I have no clue what to do.
Okay.
Right.
Paper triangle.
So it's just like you are
So who the hell is
drawing
doing this thing?
lines.
Wait,
in
so we
between.
have like a triangle. If one angle is theta, then the game stops.
So surely it's something like rational multiples of
Hmm.
pi or something.
Okay. First
What?
of all, the easy thing is like
The
you can
easy
just
thing
do
is, Aritra,
perpendicular and
this is-
90.
Aritra, not everyone is
Indra,
finished reading
please
the
let me
problem.
read the problem.
Not everyone's
bhai,
finished
sorry.
reading the problem.
Oh, okay. I thought you guys already had the problem.
Okay, finally managed. Sure.
Okay, let me read again if I understood it correctly.
I
Excellent.
think pi by n should work, maybe. I'm not sure.
रिधिमान तू भी सबने नहीं पढ़ा अब तक.
Oh, sorry.
It's okay.
Hmm.
Right.
Pi by n works. I think as I say, rational multiple of pi should just
Pi
work.
by 2 to the power k works. I don't see pi
Where
by.
did-
Okay.
where
Pi
are
by
you
n
getting
will
all this
also work.
from? Where are you?
Because you just
What?
dividing like
Basically,
pi
okay,
by
no,
3 works, no?
yes, pi by n works. You can just do injection. Yes,
Exactly.
I
Just
see.
do like pi by n, pi by n.
What?
Like that. Pi by
Can
n.
people
Okay.
explain?
Should I explain the things we are discussing now?
Yeah, please do.
Yes.
Say we have a triangle. The first thing is we do 90 with this perpendicular.
Okay. Oh, right.
Sure.
So we have 90. Now
Okay, yeah. We are granted.
So- we have this. Now I want to prove that we have pi by n.
Pi by. Sure.
In order to do that,
Okay.
say we want 60 degree, okay? Then you draw like a 60 degree here basically. So this is 60, this is 120. He can't choose the 60, he has to choose the 120.
What do
And
you mean
when
you
he
can't choose the
chooses this
60?
triangle,
Why can't
like
he
he can't
choose
choose the
60?
triangle which has the 60.
Why?
This is because then we win, like we want
Oh,
60,
we
theta
want
is 60.
pi by 3. Okay. Cool.
Theta
No,
is
so
pi by
he
3.
does choose the thing which is 60.
No, I mean he chooses 120 because if he chooses 60, we are done. And if he chooses 160. Oh, I get it.
Chooses to keep or chooses to discard? What do you mean?
Chooses to
I
like
got it. Yeah,
discard, like he chooses to keep 120.
Yeah, okay, fine. He will
And
choose
now
one.
you like do the half with 120, so you have 60.
Oh, this is nice.
How do
Like
you do
angle
half?
bisector.
Oh,
Angle
okay.
wise, like both
Okay,
are
sure.
now 60, right? So
Similarly
Fine.
for 90 also. Like that's obvious.
Okay.
So 90 we have,
wait.
60
No,
we have.
Aritra, you cannot do pi by n.
no,
You
I
can
think
do.
I am saying now how to do pi by n.
No.
Now,
Like it
We
depends
have
on the
pi
triangle also.
by
Take equilateral triangle. How can you do pi by 10? How can you do
You
18?
draw perpendicular. That's
I'm
all.
saying how we'll do pi by 10 in
Okay,
equilateral.
sure.
Okay, you have this, right?
what do we have?
Like this triangle. See the triangle I have drawn. Okay, I should
Yeah.
take a
Okay.
darker
Different
version. Let
color.
me take a right. And we draw something.
Oh, okay. I see again. I see again how to do. No, that is just insane, but sure.
Right. So say this is theta. We want theta. Theta is the divisor of
How
like
can we
theta
like
is 180 by
ensure
n.
that this is theta? How do we know this is theta?
We draw the line such that this is theta. We can draw it. We have the
Exactly.
liberty to do
It
it.
can be outside. That's the point.
Oh,
It
are
can
we
be
allowed
outside
to
the
draw it
triangle.
that way?
Why it can be outside?
Like my 1/8 by pi by 1000. How are you drawing it here?
Pi by 1000. What?
Yeah, pi by n. No, I'll take pi by 1000. How will you do it here? You
Let's.
cannot do it. Like it will be something like this. But
I
my
mean,
point is, we can make it work.
no.
Listen how.
We can make it work.
Listen
Oh,
how. We first make this. Okay, first we take pi by 1000. No, pi by 2000. Make this pi by 2000.
Wait.
So
First
what
of
are
all,
you
I'm
trying to show now?
confused. Can we just like say choose the point P so that this will be theta? Are we allowed to do that?
yes.
Yes. Wait,
Like
what are we
Wait,
showing
why
now?
are
in
we
normal
doing that? Why
geoconstructions,
are
you
we
can't
doing
do
that?
that.
We can just take this theta or
We
something.
can take anything theta,
No,
but are we
we
Oh,
allowed
can't
to
really?
take that theta because
But
we
Oh,
the
want
other
like what
triangle can
use
be
the
chosen.
180 fact. Like the
Wait,
statement
yeah.
has 180.
okay. Aritra, guys, listen to me. I figured out pi by n. Like even without that thing. So basically, for example, pi by we want to construct pi by 1000. Our issue is ki it might be outside the triangle, right? So what I'm
No.
saying is that first take this angle as pi by 2000.
No, we don't want to take that angle. Like we
Wait.
want
No.
Just one
Let
sec,
me
just
Ridhiman,
one
explain.
sec.
Ridhiman has an idea. Let's start.
Okay.
You divide into pi by 2000 k here, and one of the triangles he will select ultimately has to have one of the angles as pi by 2000.
No, why?
Why?
Because first you like if he selects this and this
But
triangle
who
then
says
square.
What is this, a
this
90
thing is
degree or
divisible by
something?
by 2000? That is not an integer multiple. You can't say that.
What?
I have an
Yeah.
easier way to do it.
No,
Like
like angle smaller than pi by 2000 is what I want. Angle
I
smaller
see.
than pi by 1000 only.
Okay.
Like one of the
Yes.
this angle will be like theta, which is will be alpha
Right,
less than
right.
theta
That
now.
is true. That
And
is
then
true.
Hold
Yes.
then
on,
you can
hold
pick
on.
this angle theta because by external angle we have that theta is
Oh,
greater than alpha.
Right.
So we can
okay,
pick
that makes
this.
sense.
So we can, and then from here onwards, we just keep doing like that thing.
That makes sense.
First, I'll say if it doesn't lie like outside, if it lies inside, like what you can do is like take it theta. If it lies inside, like after we do the Ridhiman shenanigan,
Wait, so
we do this theta.
we can do every angle greater than 60, right? Because at least one of the angles has to be less than equal to 60.
Why? No, but like it will be random. 60.001 कैसे करेंगे?
So we can choose a theta, right? For whatever alpha we have. We can like theta is increasing continuously from that point. Oh,
We can't sum angles.
wait, no. Like the first player can choose the other triangle. Why? How do we address that? Like, so they can choose this triangle and not this one. So in that case, we won't have an
हाँ
angle
नहीं
which
नहीं
is
नहीं.
theta.
Wait. What? Wait, tell again. Huh?
Like what
हाँ
was the
sure
name?
ना.
Wait,
And then
Okay, if he choose
after
this
that,
angle, take this to be
Shoshanyu.
theta.
हाँ
Now take this
exactly.
to be theta.
And
And
then
like, because
the
180 is divisible by theta, after a point, the two
Oh,
triangles you will
okay.
get
Right,
will be
that is the
divisible by
point.
theta. That's
And
why
to
you use
make
the
it
fact theta divides 180.
Yes.
Yeah, Ritra, like let's have Riddhiman explain, sometime.
हाँ
No,
नहीं
no,
नहीं.
I
I was
understood.
saying exactly. I was saying exactly that. And the question of can you do this? Yes, you can.
You can do it, but now we need to show that 180 divided by n.
So like
Not
we want
happening.
to show that this is the only thing. So okay,
How
first
do
of
you
all,
show
irrational
that?
multiples will never occur. Like that should be trivial to prove. Like irrational
Okay,
multiples
see,
is not possible.
I understand why if theta doesn't divide 180, it can't happen, like a heuristic understanding.
Okay,
What
sure.
is? Can you
Should I
provide
tell
us
that?
that? Yes.
Just a minute.
Yes. Take this triangle such that theta doesn't divide any of the angles. You can do that, right? You can take such a triangle.
Yes.
Right? Now you do induct.
Oh, I see.
See, he chooses some
Oh.
line.
Oh, I got it.
One sec.
How do you
You
induct?
choose. I'm saying.
Okay, that is
You
smart.
want
That
you
is
induct
smart.
that none of the angles in the triangles you choose will be divisible by theta.
But the angles can be anything, right? Even irrationals.
Yeah, like divisible means theta divides alpha means alpha by theta is a positive integer. Like theta can be irrational here. Like we can
Yeah, I understand that.
sure.
But how will you
So
apply
we define
induction?
divisible by that, and I induct on the claim that theta can't divide any of the angles in the triangles we choose. Okay. So how can this be false if both the triangles have some have two angles? Like if this triangle has an angle which is
I got you.
divisible by theta, if this triangle has an angle which is divisible by theta, that is the only way to have contradiction, right?
Sure.
Say if this is divisible by theta, this is divisible by theta, then this is total divisible by theta, which
Yes.
is a contradiction to our induction hypothesis. If this is theta, this is theta,
That is
then
impossible. External angle.
then this is also divisible by theta because this is this
Right.
is this is this.
Exactly.
Oh, yes.
What if theta
And
and this theta?
this can't be divisible by theta because of induction hypothesis from the original triangle. And this both can be divisible by theta because that means theta divides 180. And like we choose
Then,
theta
like-
such that it doesn't divide 180. So we are done.
Wait a second. Oh yeah, we are done. That is good.
Can you summarize the solution?
It's like
Both
Yes.
one-step induction.
Should I summarize both the
Yeah.
construction and this, or should I
Yes,
summarize?
both.
Ridhiman, can you do the
Okay.
comment?
You just said do this.
Okay. Do you understand the construction for pi by n?
No.
Okay, देखो. Look, what we want to do is first take this, like suppose pi by 5 hai. So take this
Fine.
as 180 by 5. This is 4 by 5 of 180.
Fine.
And then if the guy chooses this, then he's lost, so he will choose this.
Yeah.
And then uske baad I'll make this 180 by 5.
So we are done, right?
We are done. And then this will
Yeah.
be 3 by 5 of 180.
Summarizing.
So the guy cannot choose this triangle because then he'll
Okay.
lose. And then we just keep doing this. Like we will just at every time we'll just make 180 by 5, 180 by 5. And then eventually this will also be 180 by 5. This will also be 180 by 5.
But we haven't shown that 180 over n, anything other than that isn't possible.
No,
What
that
I
is
have proved,
that's
I
what
have
Ravindra should. Okay, wait. By the way, like one sneaky, like probably people lost partials over this. Is the case where if we had like pi by 1000, that
Bhairav
will
lost
come outside
partials
the.
over here.
Huh?
Bhairav lost partials
Yeah,
over
I
here.
didn't also see the case, so Ridhiman figured that out.
Like Bhairav got 6 out of 7.
That is not the meme, I'm pretty sure.
Like
no.
if this is
Aram could
outside.
have stopped when he just said partials. It was
Yes,
definitely
exactly.
correct.
If this point P is like outside, then we are kind of cooked. Except we are not, because what we essentially want to do is make one of the angles of the triangle very small. So we will just take this as
Yeah,
a
so
very
the other
small,
one is
and then very small angle, and then eventually one of the triangles will be selected with very small angle. and now we can take like pi by 1000 or something.
Okay, yeah, I
Because
didn't get
external
this part.
angle will.
I didn't get this part. Like, what do you mean very small? Like,
Like, dekho, suppose we want pi by 1000, right?
yeah.
The pi by 1000 point will lie inside the triangle as long as this angle theta is less than pi by 1000.
Okay.
Sure.
Yeah.
So essentially what we will do is like first
Oh,
we
we
will
keep
make
subdividing the original triangle.
we'll keep
Okay,
subdividing as
fine.
until we get a small angle, the smallest
Okay.
angle.
Yeah,
And
I
then we are
got
done.
it. Okay. Yes, nice.
And then Aritra, you can explain your construction. Induction, whatever.
So we induct on the fact that theta doesn't divide any no,
Induction is
theta
the
doesn't
wrong
divide
word.
any of the angles of the chosen triangle. We induct on the
Huh?
fact.
Induct? Well, like,
I
what
mean,
are
you
you?
can't induct.
So
right?
the point is that he's saying ki the first guy will choose a triangle where none of the angles is divisible by theta. And then
Okay.
he's saying ki how no matter how the second guy partitions the triangle, he will always be the first one will always be able to choose a triangle again where none of the angles are divisible by theta. So he will
Sure.
just
Yes.
keep doing this
How?
So
induction thing and then
where can't this happen? If both the triangles have two angles, like if the first triangle has one angle which is divisible by theta, and and also the second triangle has an angle which is divisible by theta. But I will disprove these two things can't happen together because
by case
I
by.
think I got a different proof of like why 180 over anything other than
it's
180 over n isn't
What
possible.
do you mean
one
divisible by
second.
theta, first of all?
So say theta divides alpha if
Then
alpha
alpha
by
by
theta
theta
is a
is
positive integer.
Okay, fine.
Like it can be root 2 divides to root 2 in my
Yeah,
sense.
I see.
So just come where I am writing, Aram.
Yeah, I am seeing that.
Oh, okay. Say theta divides this and this angle, right?
Yeah,
So theta divides this angle
theta divides this
because
angle.
this plus this is this angle. So
Sure.
this angle plus this angle is this angle.
Yeah.
But by induction hypothesis, theta can't divide any angle of the original triangle, like of the previous triangle. So theta
Okay.
can't divide this. So it's a
Okay.
contradiction.
And what if theta divides this? Then
So theta
then
divides
it's 180 by
180.
n. Yeah.
Yes.
Yeah. Okay.
so
And if
we
theta
are
divides this, then also theta divides the whole angle.
I
Sure.
just
Yeah.
love the
So we
fact
have
that
placed that.
whatever you have written is just triangles. See how
bro,
many triangles are there.
this is such an IMO problem. I don't even know what to say.
Nice. Let's put a
The
box now.
only hard part is like not getting your partials cut because you drew it out of the triangle.
Exactly. That is like
Then we have 16
P2,
triangles.
P2,
So
P5.
Okay, I think I got I have a different proof, but like yeah.
What is your proof?
okay, sir.
Or do
I
you
mean
just want
basically it's like you take ABC and you assume that all of the angles are like uh of the form 180 over n. You can do that, right? Like it can
yes,
happen.
yes. 180 by 2, 180 by 3, 180 by 6.
Exactly. So like anything like that can happen. Basically some Egyptian fraction times 180.
Yeah, 90, 60, 30, 90, and then uske baad you cook. I assume.
इसके बाद now like basically we will show that wait, I should remove this. Basically we will show that if you have ABD and ADC, both of these
Oh,
triangles
sorry.
may both of them cannot have a cooked angle, and a cooked angle is like basically when you have that it is not equal to 180 over n.
Oh,
That's
so
what
exact
Aritra
opposite
did.
of what rather.
It's exact what I did, right?
It is
Yeah.
almost. No, you
It's
did. You did basically.
He's DB7, he also is kind of doing that, like he's going to that area, just
I
not
did
defining
also.
it.
It is very similar proof.
So like
Okay,
ADB
now
you can
P5.
find is equal to the sum of difference of like one of these
Yeah,
angles.
exactly.
Same case, Vash. Same case, Vash.
Same
Okay.
case.
P5. Let us P5.
Wait,
Can
just
you
a
make it
minute.
a box and move it? Yes. That is the most interesting part about this problem.
What?
Making the
Wait,
box and moving it.
okay, Tanishka, are we like back?
Yeah, I'm back.
Okay, we got it out of Tanishka that she is back.
New name.
What is that supposed to mean?
Never mind, don't ask.
Okay, great. So like we want to prove QM, AM.
Wait, how
PM.
long did it take for us to do this thing? Less than half an hour.
Abhi, half an hour nahi, it
Bro,
was
10
like
minutes, not
10
This took
15.
us
then like
15 minutes, I guess.
10 or
Like,
15.
We started at 8:40.
हाँ.
Okay,
And
20
then
minutes.
like 5
20 minutes
Twen-
anyway.
Let's start P5. I'm so
P5.
excited about that.
You are
I'm also
excited about
excited about
any
P5. It gives APMO P4 vibes.
Oh
No,
it gives me
actually not.
nice vibes.
APMO P4 was a Geo.
R greater than 0.
Oh,
Yeah,
P3,
P4 was
P3.
a
P3.
P3 was
still
yuck
did not
problem.
solve that.
P3
Like, it
was
was
real
a
analysis.
iffy unique, so
Oh, that FE was cool. Did
Wait,
you
where
do
is
it
the
in
box? I
contest?
don't see the
That
box.
was
I
a
am making
terrible.
one. I am making one.
Okay.
No,
like
APMO
we had a
P3
FE
was
unique in
good.
Lama Revenge. I think they copied us from there probably with FE uniques.
Totally not the
damn.
other way around, right?
No. Obviously, you can't. We didn't see IMO problems when he made Lama Revenge.
Wait, is anybody making the box?
I
Yes.
made the box and I moved it.
Move the problem, man.
We need
Oh
to
yeah, move the
copy.
problem. Yeah,
Can
sure. There you
you
go.
take X equal to F of Y or something?
Yes, that means f of y plus y is like 2f
Let's
of
just
y.
list
So
all
it just
the
gives us
like
that.
Like-
substitutions we are doing.
Hi,
Just put
that
x equals to fy, the basic substitution.
Yeah,
What is this?
that is not basic, but fine.
No, that is basic.
No,
because
that is
it
like
squeeze.
you see x for x square plus
Yeah, I
fy
got
square.
that,
That
I
is the
got
But
that.
x
substitution.
squared,
What do you
Oh
get?
my god, I
that
so
just is
misspelled my
x,
brain
x,
pad.
x.
Fy greater than equal to f of
This is the
x.
only alg problem. I think it's the only alg.
I mean, since it's about functions, they're literally like when it comes with Arithra's writing, there is a function between F, E, and A. His F's look like E's, his E's look like A's.
That is
Great,
true.
great.
That is a
Wait,
belongs
okay,
to
so like
symbol.
F is already like injective.
Wait, why?
I
Oh
mean,
yeah,
just
of course, of course. Sorry.
so it will be inductive.
Stupid question.
Wait, is this? Wait,
Also,
what
what
does the
works?
substitution
Like which function works in my
Fx
opinion?
equal to x, I think वही होगा. Like there is no way any other function satisfies something this specific. Like I will give up life if that happens.
Wait, if
Yes,
x is equal to
exactly.
x
It would
plus
be
c.
like the AMGM thing. It's exactly.
Yeah,
I mean,
but
it does
only the
look like
middle
that a
part
lot,
is
yeah.
Wait,
weird.
C will also not work, right?
No, it's AM,
Will it?
Like
It's
It's
QM,
QMAMGM.
AM,
QMAMGM.
Yeah.
that's it.
Isn't that called RMS? Okay, whatever.
Yeah,
It's
that's
also
not-
called RMS, but yeah.
Same thing.
J.
Okay, we know
Quadratic
efficiency.
mean, root mean.
Geometry.
Wait,
Geometry.
x plus c works because of again it is
X
RMS
plus C.
AMG.
What's C? What is C?
What?
Any constant like fx is equal to x
FPC
plus
works.
c.
Okay, works. So,
C is greater than 0.
Yeah, obviously.
oh yeah, works.
Does it work? Wait, let me just verify.
Like x square plus y plus c whole square by 2 is
We
greater
can
than
just
equal
take
to
y
x plus
plus
c plus y, and that is just
Oh,
fx,
acha,
and
you
that
can
is like
write it
again
like
you do
y plus c.
GM.
It
It
does
works.
work.
Okay, but wait, does 2y or something that will surely not work.
Let's try KX.
No, 2y doesn't work because you have 4y square here, but you have
Hmm.
fx here. So you have 2x plus y and you have x
like
square
it
plus
is.
4y.
Yeah,
So it
surely
doesn't
यही
work.
होगा, यही होगा.
Then वही होएगा. Then like f of x is equal to
X plus C. C
So the
positive.
point is like f of y minus f of y is like y minus f of y minus y, right?
Indeed. And then you can
So we
keep
want to prove f of y minus y has like can take only one value basically.
it's constant.
Can't take two values.
Can we,
It's a
define
constant.
fy like fx minus x as another thing and try to rewrite?
yeah.
Yes, gy. That is probably good option. C is greater than equal to 0, not greater than 0.
Wait, hold on. What did you sub for this? X equal to f of y what?
Yes, x equal to f.
Yes. Like the RHS and the LHS will be same. So fx plus y by 2 has to be equal to like fy.
G of y is equal to f of y minus y. So g of y is equal to g of y.
So
Yes.
just need to prove g of y takes like can't take two values, takes only one value.
Wait, can you rewrite is the condition bad with this? Or
Wait,
I
what
think we
is
might have
C
to
of-
extrapolate.
Don't
more.
write the actual condition with GOI. I don't think we need all those info. Like we have two inequalities, right? We need one inequality probably.
Wait, what did you say? Are you talking to me? What?
Not
G
Not
is
really.
fx minus x, right?
Yes, G is f
Can
of
we
x
put
minus
like
x.
x equal to 1 or something and try to do
I
something?
mean, how do we show surjectiveness? I'm wondering. I
We
think that
can't
would
show
be hard.
surjective. It's not subjective, so you can't show it.
Like
It's subjective
expressive.
after a point.
After 0, we're not wrong. I mean, surjective on the range.
Yeah.
What's the first substitution we made?
X
X equals to fy. I'll
X
just
equal
write
to-
it here. P
Okay.
x f.
Also, we can do G as many times as you want. But should we just substitute G in place of F everywhere?
I don't
We can
think.
actually, we
span.
can probably prove ki f is like continuous or something.
What?
No.
Let's.
Don't go into Lamau P6 ideas. I don't want to go there.
What is
Why
that?
APMO?
There
what
is no way IMO P5 will give continuous.
Okay.
Arithra was in the
APMO
probability
P4 was
selection committee.
continuous.
I mean, there are solutions without continuous.
No, it was continuous only. Great.
What does switching these give? Like x?
It should
It's
give
different.
us nothing much. Like if one thing was symmetric, then it would be fine. But there's no symmetry here, so like I don't think it will help.
Do you substitute x equals to y? Does that give anything? Unlike using the other fact.
Yes, x equal to y gives us that it's always true because of AMGM.
Great.
QM, whatever.
That is funny for some reason.
It probably is. I don't know.
What if we put y equals to fx now? Because okay, that might help because you know
Y equal
ff
to
of
fx is
fx.
actually good. Yeah,
Y
that
equal
is.
to
Guys.
fx is such goated.
Guys,
Yes.
like y,
Oh.
comma f of y, comma like whatever f and
Wait, no,
y.
I don't think y equals f of x.
This is an AP.
What?
Right.
Where
That is
it?
a AP. We
That
have
is
showed
AP
it.
because like of what we showed.
That is an AP, right? Oh, yeah, of course.
I see.
So we have fx is between x root of x f of x and also between this guy. Okay.
My body is substituting tic tac with food. Sorry, food with tic tac.
What?
Like it's taking care of its hunger that way.
Oh, interesting. Okay, like square to remove bad things.
Where? So you get that thing. So then equal to
Right. We can substitute f of x as like x plus fx, right? We can substitute that.
Yes.
We can do that,
Before
yes.
that, एक बार square कर दो or something like square both sides.
2fx minus x.
It's also. Wait, where are you writing?
FF double F is equal to
Yes, square.
2fx minus
fx square.
2f.
Riddhiman, where are you writing? Okay,
Upar.
Yeah.
Wait, I don't even know what my cursor's name is.
Simplicity.
Oh, that is fine. Is greater than equal to 2 f of x squared. And that is like irrelevant. Okay, नहीं, irrelevant लिख देता हूँ.
Okay.
Now like cook. We have x squared.
Wait, someone is asking what we did to square root.
We squared it. And the 2 also.
What did you do to square root?
And like we can
We
square
put
because
x
positive
equals f of y and that gets rid of the square root.
Yeah.
Oh, acha, in the first one. Okay.
That won't help Riddhiman. Like,
Wait,
it
there's
will give us a very loose
there's something like, do you work in f of n or do you work in g of n? Because like by subtracting f to the power n whatever, you get like g of y, and then like g of y is just nice because it's basically
because
constant. G to the power n is g.
But the equations are too bad.
But we need to get some more info, like with how to get the more info.
Okay,
Like-
okay, fine. Did you get anything with that sub?
I'm
Ridhiman
just
is doing the
trying to do the
calculation and
algebra.
I am waiting for him to
Wait,
finish.
Ridhiman, are you
Wait,
just
what-
expanding
what
like
is-
after square?
Ridhiman, proof you are, you know what,
Proof I am what?
Happy. But
J person.
Oh,
Wait,
I
Ridhiman,
just
are
bought
you
my
using-
Ridhiman, can you write in a, like, it's actually
Straight line.
slanted. I have to bend my neck to see.
Bro, I have to bend my
Right?
fingers to write, bro.
Ridhiman, are you
Okay, you're using
They're all-
stylus. I should have done the calculation.
Are you
They're
using
also
2f to
flexible.
represent f of fx?
Nay, I replaced double f of x with 2f of x minus x.
Oh, okay.
Okay,
Fine.
So
this
shouldn't it
part,
be like 4xfx instead of 4fx?
yeah, it is x fx. Wait, I think this part is just useless or something. Like you take it here, 2 common law, and then it's a perfect square only.
I mean the other direction I did, that's also not working.
Huh,
So that's
wait, the
basically
other
useless.
direction. Wait, other
You-
direction might be
You
more.
just get A and GM for f, x and f of
Oh,
x.
yeah, I see. Both the directions are useless. Yeah, this is useless.
Yeah.
Fx square is xfx. Oh, fx square plus x square is greater than equal to
Like,
2xfx.
This
That's
always,
just MGM.
this just always holds. Like, kuch, we don't have any info.
Yeah. We need some more good info.
इसीलिए बोल रहा हूँ continuity कर.
Let's do x plus epsilon.
yeah.
Let's
No,
not do
like,
x
I
plus
know,
We can
epsilon
do
for
y
the
plus
sanity.
epsilon.
There are other substitutions we can do before x plus epsilon.
Bro,
Y
like,
plus
देखो, as
epsilon.
x approaches f of y, f of x approaches like that thing.
But why can't we just, why is epsilon so bad?
But
This
people are
just goes
getting the
away.
Miro and like sending me request to join the Miro.
Wait,
What
Because
the
like
heck?
I'm sharing screen.
Dude,
I got like 8 requests to join the Miro.
Bro, why are
Bro.
you scaring this?
why?
Oh wait, from the
But like
Do-
it's a Miro boat, so they can't join. Like I need
Do
to
control shift
accept them.
F. Do control shift F.
oh the URL.
Oh
Yeah,
my
they
god.
get the
people-
idea.
Oh, that's
People
bad.
have too much brain.
Why? Holy joblessness, bro.
Yes, Tanishka, we can.
That is just insane.
Yeah.
Like, Aritra, just press control.
I mean leave it. Bro.
Wait,
No, it's okay.
I'm taking the risk in doing epsilon.
Huh.
And,
I don't
just
think epsilon will be too
epsilon
bad
shit.
either. At least.
Let me stare at the IFI for some time for some
I'm
construct.
actually doing the same.
So
Literally same.
Give me this problem again.
So if like if f is continuous at y, then it's also continuous at f of y. F of y is how way.
by the way,
We need to show that the common differences of like all of these, like for any y, the sequences that we get, the APs, we need to show that their common difference is the same.
by the G of Y is greater than 0. Otherwise, like we can just add multiple of them and finally it will be negative. So GY is greater than equal to 0. We can say that much.
Yeah,
Yeah.
that's
Wait, if it is continuous, we will get monotone because if it's injected.
What?
okay, monotone. Wait, no, that does not. If it's continuous and injective, then it has to be monotone.
I mean, can't we just like do some injectivity argument? You know, just
Yeah,
Oh,
it
by
is
the way,
injective.
people,
It is injective. We have
4.5 hours are over.
no. Like take an
It's
injective
dated.
argument such that let the like we take a x and we take a y and we show that the common differences of both of those are equal.
common differences of
Like
both of them.
fx minus x equal to fx.
Basically, show g of x is equal to g of y for random x and y.
Oh,
By the this is true also. Like
What is
we can
true?
do this with G.
G of y is equal
Oh,
to
means
Like we
the
can
entire
add
thing.
GYs in the between of Y. Like in
What?
like in the middle we can add.
Are you sure?
why so?
How do you get this?
I see.
Like that is just normal. Like GY minus Y is equal to G of Y plus GY minus like right to the F you will it's true, I think.
Why do you
Nay.
write
Why
g
is
of
it true
GCD?
actually?
But
Wait,
it's not
that's
true.
G of y.
That's not true, right? F के साथ I think it would be true.
It is true.
How?
How is this
How did you
true?
get
It is
this?
इधर ही लिखा है.
हाँ
like it's just write it with F's, I think.
हाँ sure. So g of y is equal to that. Sure then.
Then nothing.
Wow.
I didn't have anything. What did you think?
So
That's
proud. So proud. So basically, we need to show.
Wait, hold. How did you?
Then-
I still am confused. How did you get this?
I am also confused. How did you get this?
Because gy plus y is f of y, right? So g of f of y.
Wait,
Like
how?
what you wrote is not right, g of n of y, because the function inside g should be f and not g. I think.
Actually, then Ronit
Oh.
wrote wrong. I just copied him.
Oh
What did I write
no,
down?
f n of y is ap, but the function inside g is f. So
Ah,
it should
so
be g of y,
GF.
g of y plus gy. Like the function, this is fy. Like g of y is g of
Aritra is
fy.
right.
What
Okay.
did I write? I don't
Ah, I see. It is true.
Ronit, you wrote this.
Like
What?
the y fy dot 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 fny is ap. Like this in terms of g will be like gy g of y plus gy, g of y plus 2gy. This is constant, something like that.
G plus KY, right?
Yeah, kgy, I'll write it. G of y plus.
Mm,
But like, why are people thinking of like injectivity? Like, in
It
the
is
end, we
proved.
just. Oh,
Like we proved injectivity. Like if we use it, then it's good, right?
oh, you proved. Okay, wait.
I mean, it just comes from the fact f of y plus y is like 2fy. Because you do y equals to y dash, and like f of y is equal to f of y dash, so everything cancels out instead of like y equals to y dash.
Yeah.
You will have inequalities. I mean, like maybe I'm not sure.
By the, if I share Discord, is that also shared screen?
Yes.
Yes.
just try. Why not?
I
Why
don't
don't
want to
you
try.
Yeah.
I don't. I'm getting pings. I don't want to open them.
Open Zoom. Let's see if you can see that. Or like just try.
Oh no, I don't think it will be visible.
Are you seeing Discord right now, Aritra?
I mean, we can just see his Chrome window maybe.
You can see my Chrome window.
Yeah.
That's it. Yeah, we can't see your Discord.
No, I didn't open Discord. That's why.
Try opening Discord then.
No, we'll be able to see it.
Now,
Yeah,
No, we can't see
we can't see it. You're
wait, you can see Discord or no?
We
No.
can't see Discord. We would have like
Wait.
screamed if we saw Discord. It's fine.
By the way, the IMO Livesolve is like some seconds lagging, so we might be able to see it, right?
No, I mean I don't have anything that it can't go there, but
Do you?
probably shouldn't.
I
Yes.
know it's
Wait,
not
what
there.
progress do we have right now? Can someone tell while we are doing like that?
Okay.
So what, I am substituting y equal to 2x minus f of x for some
Riddhiman,
reason.
you've been very quiet. You're going to explain Arham whatever progress we have.
There's nothing to explain. Like the Mbappe special.
What?
What?
Okay, bro.
Okay, I know that. Not a good one.
देखो
When
देखो देखो.
Riddhiman tries to make an elite boy joke but fails miserably.
No, you failed miserably, bhai. You don't know elite ball. It's okay. Let me explain. First we put in x is equal to f of y to get
Yeah, I got that.
this.
Yeah.
thing.
Yeah.
Nice. So we are calling this thing. We have this thing, and we are calling it g of y because it's like
Sure.
kind of recurring. So g
Okay.
of y equal to g of f of y.
Okay.
Sure. And then uske baad, what we are doing is that now
Oh, you
uske
wrote
baad,
g of y equals g of y. I'm pretty sure you didn't mean that.
Hmm? G of y is equal to G of f of x.
Darshan, can you move your cursor?
Yeah, we
You wrote
like
G before.
Where is my
that's a mistake. Anyways, उसके बाद we tried to do random substitutions, one of which was putting y equal to f of x, but it failed miserably.
Yes, I can
That's
see that.
about it.
Okay.
But I'll do some
Yeah,
of
I
my
got
calculation again.
Yeah, I got fx greater than equal to x.
Fx greater than equal to x. How did you?
Yeah, that is
Y-
true.
Nice.
That
y
is true.
equal to 2x minus f of x. Yeah.
That is
Because
true
like
because
g of x
G
is
of-
greater than 0, f of x has to be greater than x.
greater than or
No.
equal to greater than or equal.
I mean just
Yeah,
that y
yeah.
equal to 2x minus f of x. That's all it is. I can write it down. Can somebody write it down? Like that result. You know what? I'll write it down.
Wait,
I
so
don't.
why is g of y greater than 0?
Uh,
Anybody?
I
Yeah,
think it's
yeah.
because of the square root or something.
Because if g of x is less than 0, then like we can take multiple, like f of x is always greater than 0, right? So we can increase, and because it's a AP where the common difference is negative,
Oh,
then
so we just
after a
keep adding
point,
or
all
something.
the values will be negative, but it's r plus to r plus, so you can't have negative values. So the common difference has to be positive.
I see. Okay.
Wait, what happens if the common difference is negative? Like, what's the issue?
Then eventually f of something will become negative, which is not possible.
But it's r plus to r
R
plus,
plus to R plus.
Okay,
surprise,
fine.
surprise.
Makes
Can
sense.
we not do x equal to 0 something? It is r plus to r plus.
We
Oh,
can do
wait.
if we prove continuity.
But like we don't have that.
Wait, my substitution does not work if x is like less than fx by 2.
If x is less than,
I
I'm
mean,
basically putting y equal to 2x minus f of x. So that has a condition which I don't want to be there.
oh, wait, what are you plugging again? Can you tell?
I put y equal to 2x minus f of x.
Yeah. Not sure if that is allowed.
I mean, we need to show this, right? Like, I mean, here we need to show that what these two are equal. C and D are equal. I don't like this. Like, Ridhima, can
But
you
what
do
I
that
did
again?
was, I took fx is equal to gx plus x and like did the right side of inequality. And I'm trying to calculate what
fx
I
equal,
get.
oh, acha, you're putting gx in the expression. I thought like we
Yes.
agreed it was very
For the
hard.
right part, left part is worse. So I'm only putting at the right part.
Wait, people, can you look at this expression? Chaiva. We need to basically show C equals to D here.
Equal to d.
Where
Interesting.
did you write?
So, like, can someone do my algebra?
I see
But we can
binomial
just do
theorem.
negative of this. Wait. I might have something. I don't know. Let me just finish with the calculation.
How can
What
you
is C?
do negative
What
of
is
this?
C?
C and D are the like common differences of f of x and f of y.
Oh,
Right. I do have something. I have some square greater than equal to 0. Okay, that is
Amazing.
true. That is
That is just amazing. Wait,
you laughed.
what is you doing?
Who, me?
I don't know what should I do at this
Run it.
point. Some square greater than equal to 0. Great.
Who
Run
are you asking?
it. What is
Oh,
in
me.
progress?
Basically, you need to show over here C is equal to D.
This is for all x or random x. Like some certain.
Random x, random y, random C, random A, everything's random.
Wait, no. So like c is a constant or does it depend on x and y?
Everything's a constant.
Yeah,
See,
x.
wait, listen to me. See, f of no, x and y need to be are not constants. So basically, look at this. We need to show that if you take basically if you take of f of a x and f of b y, You see the sequences which they make, those the APs which they make, f of x AP and f of y AP. We
Oh,
want to show that their common difference, which I call C and D, are the same. Yeah.
Wait, no, I'm wrong. I'm wrong. Sorry. It's not a square greater than equal to 0. I'm messing up signs.
You get that, Ridhima?
yes, we want to show the common difference.
So basically, I just subbed in them directly. I took f of x a times and f of b y times, f of y b times, and just like boom.
Sure.
So you need to show this.
Are so C depends on X and like, B depends on Y. D depends on Y, right?
No, a, b, x, and y. They're all random.
But C and D are not random, no.
C and D are not random. C and D
So
you have
that
to
is
show
the
equal.
that is the issue.
C and D you have to show equal. That is true.
Then it's hard doing it. Like I'm not sure if it is possible.
It's hard to invert.
Doing it, I said.
Invert?
Invert कहाँ बोला?
Or I think what Ritra is trying to say is if Ridhiman is doing anything, it's invert.
No, I heard invert for some reason. That's what I was saying. Uh,
Anyway, yeah.
It's just
This is-
downright ugly.
Exactly.
okay, yes. I have a grid square less than equal to 4x gy minus 4x gx. Perfect square.
कहाँ पे हो? Oh,
Where?
okay. Did you just put in? Oh my God, ये कितना बड़ा है? This is a perfect square.
Yes.
What did you do?
I'll explain one sec. I'll just. Right.
Yeah, right.
So I took the right inequality and substituted fx is equal to gx plus x.
Okay.
I'm confused. What are we doing right now? And is that a U or an X?
X.
It's
Everything
an
that
X.
you see as x is u, everything you see as u is x.
Okay.
And everything that you see as x is also x.
Every A is a E, every F is a E. Also.
Right.
Sorry, every
Great.
E is F.
So I just squared this part and then I like do some simplification. And now because I want to make this a perfect square, I do this and I get the factor of 4x gy minus 4x gx on the right hand side.
Sure.
Okay.
What's your conclusion?
Is greater than equal to. I don't
What
know,
is-
like we'll have some inequality which is like not obvious. I don't know if it helps.
Wait, I don't understand.
Everyone
Why
may
did
have an
you
inequality that's not obvious.
There is this term, there is this term.
Like
And
it's not obviously true inequality. That's what I'm trying to say. It's not a square greater than 0.
Yeah,
that would result into nothing, right?
Yeah, that's why it's not that.
excellent.
It's like
See,
gx plus y minus x whole square greater than equal to 4x common gy minus gx.
What is that supposed to
seems
mean?
nothing.
I have no clue. Let me think if this means something.
Wait, you can fix gx and then you vary
This
y.
doesn't mean anything except for
Wait.
the problem restated in terms of G, right?
Yes.
But like we have to restate the
Oh
problem
no,
in terms of
wait. You take y to be gx minus x. Then this side is 0, this side is never mind.
but you don't know if gx is greater than x.
Yeah, gx has to be 0 as per all we know.
GX is a constant.
But I am thinking if we can make the right hand side like very large and the left hand side like not so large.
But the
Okay.
right hand side is the LH is always greater than RH is by QM GM.
No, not here. Like the equation I have, like come down later.
Oh,
But you
did
can
you just take the
replace G
second
with
one?
F, right? You can replace G with F now. I
See,
guess.
great. Okay, I have something. You know that g of y is equal to g of y plus kgy, right? And you can take k to be very, very large.
Hmm.
So
repeat that.
you can have very large numbers while g is small.
Wait. What? Wait a second. Also, how did you get this? Like, what?
This is just calculation. Trust me on that, or you can verify it.
Wait, hold on. That is insane. We get this because we had like this, and then like different squares. Oh, we should have that. I guess.
Okay, actually
Like
we
I
have
did the
this.
positive square and made it negative and
Wait, I
put some
actually
stuff.
don't. Okay, sure.
Skip that part. Come to the part we are. Okay. I'll explain the part if needed later. My idea was because we can make like y large and gy small, right?
Hmm. Why is that true, by the way?
Wait, how can we take GY small?
Like we take gy to be something, we uh compare to y, and now we can do like gy is equal to g of y plus kgy. We know this thing, right?
Yes.
Okay, and
So we can make like k very, very large. So if gy is something like gy is something
Wait,
like
Aritra,
a log,
we won't have KGY, right? How
we have
like,
kgy. We have done it before.
no, we
Yeah.
had K equal to 1. It's not, it won't
what?
like,
It
Oh,
extends, like you
wait.
can do this multiple times.
are
You
you
can
Does
kidding?
just
it?
How
put,
would you do this multiple
It
times?
does not
I don't
extend.
think. Like, इस
It
पे
does not
apply करोगे
extend.
तो फिर the Y will change, right?
Yes.
I'll show why you can do it multiple times.
Go on.
No, but I bet you can't do.
I don't
Okay,
think you can either.
yes, listen. Like if you do like f of y minus f of y, that is again gy, right?
Huh.
So just write as g of y plus 2gy, right?
What? Why? Where do we get
I want
2GY?
to prove like this is I'm not saying this is g of now.
Oh, you want to
If we
prove
write this in a
something?
term of f's, this is g of y plus gy, like f of, like you just get the same factor. Minus uh minus what? Y minus gy, right? Equals to f
Oh,
of minus y minus 2gy.
Okay, I see the proof.
it's like taking G of f of Y and then like substituting.
But I don't.
So g of y gets cut out, so it should be plus gy. So f of y plus gy is like f of y, and this is like f of y plus y.
Wait, the sign of it will be 2FY minus Y, no?
What?
So like it's not exactly the same. Wait, take a second. No? Y.
But why is it g of fy? I didn't get what you do.
Like we have this equality.
Oh yes.
So you replace f of Y is equal to G of f of Y. Right.
Wait, wait,
So
wait.
fy minus y is like 2gy plus y.
Is that true? Wait, F5 is oh
Yes,
exactly
fy is
true.
like gy plus y. So like this is just that g of
Wait, but
y
it's
plus
not
2gy.
obvious. And it's also not obvious कि K आएगा and not some random way. Like you have to prove that. Are you
It's
sure
induct,
KGY
right?
आएगा? हाँ, okay, wait.
No, I like you just see like how gy moves is like
Like it's not exactly obvious. It's like you have to do it. You cannot just state it.
I think you can do induction.
You can probably do induction. Like just use G of Fn of Y is equal to like that thing. Replace and then you have to go entire down.
But I'm
Can
still
someone
confused. How do you induct on that?
can someone fill me in on like whatever this is? I realize
You're
my
trying
thing
to
is like a
prove
lot of
that
code.
g of y is g of y plus gy dot 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 g of y plus kgy.
What?
What are you replying to?
Ronit.
Sad.
Yeah, like what did you say?
G of y is like g of y plus kgy for any k positive integer.
Ridhiman, can you write that down? Whatever like he's saying.
Wait. I'm just proving the thing.
I wrote down here, Ronit. This is the thing we're trying to prove. This.
Why?
Hmm?
Why?
Like from the f when we come to g, this is how it behaves. Like f n of y is f of y, right? So from f when we come to g, this is the equivalent statement of that.
Oh,
At least
I'll
remove
tell
the
you
blue
this.
thing.
Wait.
yes.
Let's just.
Yeah, Aritra, Ranit, whoever is having doubts, come here. But observe that this thing holds.
You need to show that, don't
It's
you?
true.
No, we have shown that by can this is equal to g of y, this is equal to g of y, dot dot dot, and then when you add these
Oh, you do cancellation. That's
telescopic,
That's
telescoping, yes.
that's good.
and then like once you have this, observe that g of f is equal to g of f squared equal to g of f cubed and so on. So you have this. That is not at all obvious. I don't know how we got that, but yeah.
Bro, it's just crazy.
No, it's
Yes,
just like you have g of y equal g of y plus gy, right? So you're basically adding the gy value. The gy value is
I
constant.
agree,
So
but
you
like,
keep repeating the gy value.
I didn't think it was
But
functional.
Tanishka,
It
if you
was not
could
obvious.
run.
Okay, never. Okay, whatever. Random side quest. This thing is true. So basically, we can make.
Like large enough things might like have smaller g's. So we can like make gy constant and make y very large. We can do that. We have that freedom
Yes,
of
we
choice.
can do
That
that.
is
We
true.
can
So
indeed do
that's what
that.
I'm
True.
trying to think.
Wait,
This
we do
is
not want that,
so.
right? Because
Is
the
this what you have?
LHS.
That's it. This. Look at this. F of
Wait,
n y
Right,
is equal
right.
to n f of y minus n minus 1 by.
but like, I wait. I do not. Something. Yeah, something like that. I think. Yeah. Wait, Aritra, but like, here we have to figure out बढ़ाना क्या है? Like, if we make y bigger, then like the
So
inequality is
basically we want to
looser.
make this small. So we want to make y close to gx minus x, right?
No, wait, gx minus x is f of x, right?
So
And
Oh,
right.
don't think about f. We change the problem to g. Like
No,
like
we
let it
don't
be
want to
f.
go to f again.
Let it be f. But then we can again increase g on the RHS. G of x. Oh, acha, no, sorry, I get the problem. That's
but like gx minus x might be negative. So like, how can you even get close to? Okay, sure, you can.
So
But
I
gx
don't
gx
minus
think
minus
x.
this
x being negative,
particular
we want
inequality
gx
is
minus x
nice.
to be there. Like it's
Gx
minus
minus x
x,
is
right?
positive then.
Minus 1. Oh, so basically we make like x large and y both large. Then like we
What
can
are
do
these
this.
size arguments? Hold on. I'm not getting why we're doing any size
Ronit,
arguments.
we'll come to you. Just one
We
sec.
are trying to.
Just let me be clear first. We can make x large and y both large without changing the
Okay.
gx and gy value.
No. Okay, fair.
We can make
And
both
then
large. Yeah.
and like do if we make both large, then gx plus y minus x,
Huge. It becomes huge.
it doesn't become huge. Like we make the gx minus x like very negative by making x larger and making y larger. We make this like close to 0 basically. Basically, we make x and y both large, but both large are the same proportion such that their sum is kind of 0.
So like you want kgy equal to lgx. So like k by l, you approximate gy by gx with rational approximations.
Yes.
Okay, you can do that.
Exactly. And now because x is like large here, we
Oh,
must have like this
that's
0. I
good.
want to make this argument kind of.
But still
But
that
we
is,
still don't have the
I
one
mean,
sec.
g of
Just
x is
okay.
great. G of
हाँ,
x squared you have, right? This term is still there.
But the point is that we
I
are
mean, you can
making.
make this 0. That's what you're doing, right?
We don't want to
No.
make
We
0.
are
We want to make this close to 0. Like
Yeah, that's same thing.
the
everything is
entire
bound.
thing close to 0.
I
So
get
what
it.
we are doing is we first make x huge without changing g of x.
Yeah, and now you make y huge.
And then we make y huge, and like we make it like this. Now the g of x minus x is very negative, so we
See,
slowly increase y.
another
Guys,
thing
if you
is,
like, please, like, maybe now is a good
Wait,
time to let me in on what's happening.
okay,
Okay.
I'll explain Ronnie to once. You guys can
I'll just
think
work it
like
out.
in
Like
mind.
we are just done at this point. Like we just have to work out the do it
Wait,
for
explain to
Ronnie,
me.
did you get the? I'll explain. Did you get the equality gx plus y minus l plus y
What?
minus x whole square? Did you guess? Did you
Which
get this inequality? I mean, by algebra. This is true
You
by
would have
just
done it. You
algebra.
would have done it. Okay, sure. You did it. Fine. Then what?
Now we are trying to make like you see the point that we can make y huge and g of y to be small. Like we
How?
make g of y constant and we can increase y such that g of y is constant because this is true by making k
yeah,
large.
What
Okay.
was
sure.
it? Repeat? Repeat?
By making k large, we can do like making g of y constant but the y to be large because this holds.
Wait, why is g of y equal to
What?
g of y plus k with gy?
We proved it.
What's
When?
K?
k can be
What's
any natural.
K is any
wait?
natural number.
We have g of y is equal to g of fy. How did you prove that? How do you prove this from that?
I
Not
just
g of
showed
y is
that.
equal to g of fy. We already spent 10 minutes on that before.
Okay.
Hold on, wait, Aritra, can you explain? I'm just
I think
doing.
there is an easier way to do this
I don't
because
understand. Like, what?
Wait, this finishes, right?
Yeah, this almost finished. We just have to work out the formalities. Like we have to
wait, you
formalize
guys work
What
on the
format?
formalities, I'll explain them.
Wait, we should work on what?
formalities. Like we have to show
Formalities.
that this tends to that, and like
Wait,
we have to show it.
do
We
you see
have
why g of y,
Not
g of y plus
needed.
kgy like holds, or should I explain that
I
part?
mean, Ridhiman, are you listening?
Which wait, which part? This part or this part?
G of
Jigar
y
Chandra,
equals to g of y
This
plus
part.
kgy, the only
Jigar
the
Chandra.
this part.
Yeah, so
Yes, I
basically
proved
by
that.
rational
Yes,
approximation, we
Ronit
can
and
get.
Adam, are you fine with that?
Which part?
This
G
thing.
of y
Wait,
equals
I'll
to g
write
of
in
y
chat.
plus kgy for
No,
any k belongs to rational number.
I don't see that.
Do you
Like
see
we
why
have
g
the
of y is equal to g of y plus gy?
g of y is equal to g of fy, and then
Fy is y plus gy.
y plus gy. Okay, yeah. Okay.
So
Um,
basically,
sure.
if we have the g values to constant, what we can do is add the gy value in between. This is heuristic proof. There is like a better proof with demanded, but I'm not gonna go over the same proof again.
Okay.
But I think
I
this
think
proof
I
should
have
work.
shorter proof, but yeah.
Oh, and gy is positive, so we can make y large, and we can keep gy constant.
Yes, we can like make g this large.
Sure.
And now
Okay.
we've like
But there is
adding
one
gy
more
because
You make Y large. Wait, what? I am so confused.
I make gy constant. Okay.
Sure.
Wait, no, call this thing like z. You make z large.
Yes,
By
I make
how?
z large. This is called say y plus kgy is z.
Sure.
Now I can make z large such that g of z is equal to g of y.
Sure. That means
Yes.
you're making K large.
That is what I'm saying, yes.
Sure. That's
Now
okay,
what we
fine.
want to do here is basically like let gx be constant and we make x and y both large such that g of x and g of y are constant.
G of
Yeah,
x
sure.
is constant, g of y is constant, and x and y are large. Okay.
And we want to make this small, basically. Like
Okay.
if both are large enough, then we can make it small, basically, in comparison of the RHS. Because
What can we
RHS
make
has the
small?
x term and RHS is large enough.
What do you mean? What can we make small?
The LHS.
Okay. And how?
Because it has y minus x. If we like both large enough, then like because we have y minus x, it is small. Like it's not y plus x
Okay,
or
so you want
something.
like some k, we want like some n, y plus
Like there
k.
to the formalism. I'm just saying the idea we are using.
No,
Wait,
it's fine. Aram, continue.
I'll just like write it down. Y plus n gy is like roughly equal to x plus mgx. This is what you're trying to do.
Yes.
Okay, and this is possible because why? Like, how close can you make it?
Because we can increase by gy, right? So I think
Yeah.
we can do it in the gy
Like,
or
I
gx.
heard you saying some rational approximation, but I didn't get it.
No,
I
I
don't
don't
get
know
it.
how to approximate it. Like they're doing it. This is a heuristic argument. I don't know how close we can do it.
Okay, so if these two are like relatively close to each other, then what?
Then like this is of the form like gx. Like this will be kind of like
This is some
something,
constant.
some
Aram,
cgx type of thing.
Aram, like after the fact that we've made this like this large by making k large,
Yeah.
what happened after that? I am not understanding what it means.
Okay, wait. So it like I think we have just come here. We have this inequality gx plus y minus x, I think. Is it y minus x? Yeah. Square
Okay.
is greater than equal to 4x. And then gx minus gy. Wait, is it gx minus gy or gy minus gx? Yeah, gy minus gx. Okay, so this is constant. Like the 4 is constant, the gy minus gx is constant, so forget about it. And so we have like gx plus y minus x square. We
Wait,
can like
Haritra,
forget
we
the
are done.
constants right now.
We are done. We are done.
This is greater than equal to 4x. And then what Aritra is saying is we can make y and x both large, and we can make them roughly equal to each other, or we can make y minus x like bounded by something.
Sure.
And so this whole thing is bounded, but x grows infinitely large, so you have like some sort of contradiction.
Oh, Aritra, I got it. Guys,
Okay,
I got
can
it.
you
Wait,
show
Riddhimar, can you
the
just tell?
formulas?
Huh.
So
So
like what
basically,
exactly are we doing?
by the way, this under wala thing, it actually like may not tend to zero. Like it actually may not tend to zero, but like we
No,
can get
it is
Yeah,
some
we can
constant of
bound it.
cgx type
Basically,
of
we can
thing.
bound it.
exactly. So we can keep this part like less than equal to like. Basically, we don't even like we're just grossly overthinking it. The point is that this y minus x wala part, we can just keep it
Yeah.
less than equal to 1, and then this is basically constant, but this
Sure.
guy just keeps increasing, and this is also constant, which is a contradiction.
But
Why is
okay,
g of y
what
minus
did
g
the
of x a
contradiction come
constant?
from? Like
Because
if
g of y and g of x is constant on its own.
Like
No, but why are they constant?
no, because of like the
because
transformation we are
of
doing
this.
is y naught ke jagah we are replacing y naught plus k g y naught.
Yeah.
Not क्या है?
Oh, but then gy not equals 0. Okay.
Exactly. So
So
like this thing
okay,
has
so
to be
the
equal to 0.
contradiction is if gy is not equal to 0.
Okay.
Yes.
So we got gy equals 0, so fy equals
Oh,
like
no, we
Yeah,
don't get g
yeah.
equals
We
to
get
0
gy
because
equal to
we're
constant.
also
We
using
get
the
gy
fact
minus
that
gx equal to 0.
gx and gy are different. Like if gy equals to gx, then it's 0. So we get if there is 2, then one is 0, one is non-zero. Like then we also have to do the pointwise step.
what?
We have to do pointwise or you have to take the square and
Oh,
make
bhai,
equals to 0.
wait, एक second.
Wait, no,
Because
we
we
don't
get
get
if
g.
there are two
Where do we
non-zero,
get
listen to me
pointwise?
once.
Huh.
Listen to me once. We prove that if there is two non-zero values that
Of
g
gy.
takes, then there
Yeah.
is a contradiction.
Yeah,
So
yeah.
there can't be two non-zero positive values that g takes. So it
Right.
might take 1 0 and 1 c.
Or it might take
It
like
can't take two non-zero values. So we
So
just take
all
pointwise
zeros
step
and
on
like
that,
c's.
and we'll be done.
yes. Okay.
Wait, I'm actually not sure.
Oh.
Why are we getting 0 and c?
Because g of if like g of y is
Okay, wait,
0,
like
then g
Riddhima.
of y is equal to g of y plus kgy
Wait.
can't be large enough. Because
Arith-
the idea of large enough only holds when gy is positive.
Oh, अच्छा, g of y.
Like
Oh, I see.
see what
Aram,
Aritra
yeah,
is
go
saying
on,
is
Aram.
Got it.
Yeah.
Go on. Aram.
What Aritra is saying is if you have gy and gx,
Yes.
both of which are greater than 0 and both of
Yes.
which are
Why are they
not
greater than
equal to
0,
each
by the
other.
way? Why are they greater than 0?
Okay, so what we have here is like this sort of recurrence sort of thingy, g of y is equal to g of y plus kg of y. Like we were making x and y large while keeping g constant. The way we could do that is if this is greater than 0.
Sure.
And so like if g of y is greater than 0, we can make y arbitrarily large while keeping g of y constant.
Sure.
So we assumed both, like there's two values gx, gy, which are both distinct and greater than 0.
Sure.
And then we were able to show that that leads to a contradiction.
Because
So
I mean, okay, go on.
wait, hold on. I'm thinking.
Go on.
so then basically what that means is if gx is greater than 0 and gy is greater than 0, then gx equals
Okay, I
gy.
got it. Yeah. Okay.
So what I'm saying ki here from now it should be simple because here we put in like x equal to x equal to 0 or something. Like put in x equal to 0.
X equal to 0 is 0 marks
gx equal
because
to
it's
0.
R
No,
plus
I'm
0,
saying
R
ki
plus.
suppose g of x not equal to x not a, g of a is equal to
Oh, so
0.
g of x is 0.
Suppose g of a is equal to 0 and g of b is equal to c. So you put x equal to a, y is equal to
b.
So like y minus x the whole square is greater than or equal to 4x into c. And this is
just
false because you can vary
don't do
y.
0, right? Just put gx equals c. Like c can also be
You
0,
can't
so
vary
that's
y.
fine.
Wait,
can't
hold on.
vary
We
y.
cannot vary anything now.
See,
Hold on.
just put g of y equals to c for some y. We don't care like what c is. And we will show g of x equals c for every x. That's what we want to do.
Yeah.
Yeah.
I
But like
think if we prove this is C in some neighborhood, then also we can prove because if this is
Neighborhood.
true like this, yeah, say
Okay.
this is g of y is C for this range, okay? For something here, it is true for some neighborhood of it. We can go like a little bit x direction and also do like this thing. Then it's like true in this range. And we can go a little bit x direction and it's true in like this part. So if we prove this in neighborhood, we are also done. Like we
neighborhood
don't
ke
have to
liye you
prove
need
this over
like
all domain. We can
lim
just prove it over some
limit first.
positive neighborhood.
Oh, but like the positive neighbor, okay, sure, some constant length positive neighborhood. That is like insane. How I have never used this idea. How are you even thinking of this?
Exactly.
Like
Wait, I
neighbor,
don't get the neighbor. Like, how is that true? I get the idea, but
like if you
Aditya,
xk.
can you repeat your argument?
So basically, what he's saying, कि if you neighborhood, मतलब example like x, if x is g of
Epsilon.
c, so g of x plus minus 1 के बीच में everything is c. So if you can prove that, then like you do the same for x plus 1, x plus 2, and then eventually you cover the entire number line.
no,
Okay,
but
wait,
like
so
I see, but like, how are you proving
We had no.
that?
I don't know. I genuinely don't know.
the only
Yeah,
case where we have an issue is there exists g of y which is equal to c which is greater than 0 and g of x equals 0. This is the only like case with an issue.
Yes, the point wise, stupid point
point
wise.
was trap.
Yeah.
Wait, can't we just plug it into the original? Like surely it does not
Sure,
work.
yeah.
Yeah, let's
Original
try.
I think now we can take like fx because like
So
gx
wait,
expressions are bad.
in
Can
this
you
case
use that
in this case we
expression
will have
again?
fx equals x
x
and
plus.
f of y equals y plus c.
Oh, don't do y. Do x naught and y naught.
Wait.
No, x not, like it doesn't matter. We can do y not, sure.
X naught ठीक है x.
Like x is constant anyways, so it's fine. Okay. Yeah, and now plug into the
this in.
original FE. Plug, like, okay, what are we getting?
Plug and chug.
Plug it.
Wait,
X
I'm just
plus
copying
y
this. Wait,
plus-
hold on. I'm copying this down here. People come back to where we were.
What?
Okay.
Wait, the
X.
neighborhood idea might work. There is why. That is just insane. Okay, do the calculation. I think neighborhood idea might work.
Okay, fine.
Like
So,
this part is true, sure.
Like
The
in
other...
some range we have to prove it. If any positive range we prove, we are done.
Wait, it is actually not necessary. Like we can have fx equal to x for some x and y naught plus c for other, and then it will still always just work.
Aditya, can you repeat your neighborhood argument? I missed it.
Okay, see, okay, we have not proved that it is true in neighborhood, but say for some constant positive, not constant, some positive neighborhood is true.
Yeah.
Say
Okay.
for x naught,
Aram, come
What
here.
do I mean is true? Is like it's some
Down,
x
down.
plus c for all this neighborhood area. It's if x naught is x naught plus c. Then we can go
Yeah.
from here to like here because it is true here, we know, and we have proof that it is true in positive neighborhood. Then we can like do this box, and it is true like for this
Oh,
part
AP.
also now, and we can do
Okay,
this
so
here,
basically
and
AP.
it's true here. So we
Basically,
can like cover the whole number line like this.
Okay, got it. Fair.
So if it's true in some neighborhood, it's true over all R plus domain.
But for neighborhood things, you need like a continuity notion, something
Okay,
like
but
that.
we still like need to cook.
I think
Yeah.
we are close to done because देखो like
It's
here
just
we
one
cannot
pesky case here.
हाँ देखो here we should not be like this ये तो inequality छोड़ ही दो तो है this inequality will
रिद्धिमान नीचे आओ, हम सब नीचे.
Yeah.
अरे तुम लोग ऊपर आ गए प्लीज
अरे भाई यहाँ सब कुछ है.
यहाँ पे वो वाला नहीं है मैं जो कर
वो
रहा
वाला ही है. नीचे आके देख तो सही.
ओके मैं इधर ला रहा हूँ उसे धीरे क्यों चल रहा है यार
Wait, hold on. Why are you like doing x plus epsilon?
we
Oh,
are
that's
not
because
doing-
we are going to be using the same Aritra neighboring idea.
Wait, don't do x plus epsilon. First, just take x naught and then उसके बाद like try to see what x can do.
I'll
Wait,
just
why
do
are
this.
people asking which class we are in? Like, this is not a class, this is a Livesolve.
अरे भाई वो
I
हमारी
think he means
Standard
standard.
पूछ रहे होंगे with
standard
standard.
पूछ रहा है.
Okay,
Ignore.
of course.
Wait, don't discuss mine at least. Few.
We're all
Wait.
younger than 18.
Yeah.
That's what.
Wait,
Not
no.
Not me.
Like this Buddha is here. I don't know why he's here.
अरे भाई freaking अंक bro क्या
Yeah,
कर रहा है?
Aritra is 2 years older to me.
I'm not 2
Aritra
years
is-
older. I'm 1 year 6 months older.
For a
He's more than
while
3
he
years
was
older
2
than
years
me.
older than me too.
Wait, I think
Why is
I
there
have
no
like
E over here and why is there an E
Yeah.
over here? What?
It's C. It's C.
y is 0
See,
x
wow.
Oh, okay. That's
x plus
C
okay,
and E are
fine.
also
That's what I was
isomorphic in my
talking about.
writing.
Aram, that's what I was talking about.
You'll
Okay.
know. You'll know. You don't do much solves. You'll know.
Like, just look at this. Is this a C?
Yes.
No, it's an
Okay,
E.
Aritra,
It's E.
Aritra.
It's Aritra.
Yes.
It's Aritra.
Yeah, so okay, so assume you have some y for which g of y is 0, right?
Wait,
And then-
Debarchan, can you wait 1 sec? I think
Okay, I'll
And,
wait.
Yeah. 4x.
I think this just gives something. I don't know what it gives, but this gives something.
Yeah, I'm doing almost the same thing. I mean, I can
But you
tell
have
one
this,
thing
huh?
for your turn.
Is this what you have,
I didn't
Aritra?
explain.
Exactly.
Wait, how do I solve like how do I solve उसका नाम क्या था?
Aritra, you don't need to expand.
Bro, I forgot. I'm not relearning.
Okay, yes. I think I proved this is true in a neighborhood.
Yeah,
nee, I
because if
also
it's
have this.
not, you
Just
can
have to
choose
solve
x
this.
and y to be very close.
हाँ,
And
exactly.
that's true.
No. But neighborhood के लिए you need to show कि the neighborhood has a constant length. Otherwise, you cannot just say कि smaller.
Yeah, I am thinking
I mean,
it's
अरे it is
you
just
can
like solve
get-
this inequality like हो जाएगा.
wait, x minus y whole
wait,
square is
yeah.
greater than equal to that,
Yes.
right?
4x.
So
You do have
if
that.
it is less than equal to that, it can't happen.
No. Like
So-
x का factor है.
So it is greater than c square, yeah.
Oh,
So
अच्छा.
x minus y for greater than c, yes. It is greater
Oh
than
wait,
c
that's a
square.
C. Damn it. I
No,
still
इधर
think
x and y का
that
क्या
is
हुआ?
it.
For
This
x
one
minus
is-
y less than equal to c and like minus c, it is true. So I have proved it for a positive neighborhood, which is c.
Like okay,
Yeah,
I am
so we are
also done.
done,
I'm just
right?
We are
not doing
done?
the calculation.
Wait,
Yes.
can you summarize how you prove for positive neighborhood?
Wait,
So
look here.
we
Wait,
assume
Aram, wait. Let me just tell him
Okay,
what
you
I'm
did
doing.
some algebra, then we got this, and then what?
You just bound
2x
x
plus
minus
y
y.
x minus y whole
positive.
square greater than equal to c square. If like
2x plus 2y is positive.
हाँ,
Basically.
exactly.
Plus
x is
2y.
like of the first type and y is from the second type.
So
Okay.
like x
But-
minus y is going to be greater than or equal to c.
So if it is less than equal to c, then it's like of the same type. And if it's of the same type, and we proved it for a neighborhood of c, basically.
Oh, okay.
So
Okay.
like so x minus y less than equal to c के अंदर it has like the f value has to be same and then
And
hence
c is
you're done.
constant, so that neighborhood idea works.
Bro, what is this black magic? When have
How did you think of this? Like,
How did you ever think of
No, I
this,
just
bro?
saw you don't have to prove over whole domain. Like if you prove somewhere, it's
Never heard that.
because
is
you can like
insane.
shift it.
And that now it is 10 o'clock. We are left with one problem.
Good progress. We were thinking
Does
12:30.
anybody know how to end the Google
Wait, we are
Zoom?
like 1 hour, one
And-
problem. 5 hours, 5 problems. Wonderful.
भाई whatever
No,
है
we are
मुझे
4.5
12:30 तक
hour,
जाना है.
right? No, we are 5.5 hour. That's crazy.
5
we
hours,
ending
15
it?
minutes.
No. We can finish the last
No,
problem. We have to like last year
we
they
probably
posted.
can't, but we can try.
It's bro, it's NT and we have 3 NT wins over here. Come on, we can do it.
Arithra constitutes all three of them.
Wait, who are the three? I know two.
Then we have 6. Sorry, 5.
But
No,
Aram is
me,
intimate.
Riddhiman and Arithra.
Yeah,
Aram
those
is
are
anti-win.
two.
Aram is anti-win.
Oh.
Oh, अच्छा, then also NT. Nice. Okay, नीचे लाओ problem को. Or first box this up.
Yeah, I'm doing that. Chill, buddy.
भाई, this is like, I think the
This is-
shortest one is obviously the Geo because it's just 1, 2, 4, 3,
P1
4.
is
No,
short.
it's P1 by
P1
P1.
was the shortest.
Bro,
Like
P1
No.
we wrote like
The space
unnecessarily,
bola.
like
Acha,
you can
P1
delete all of this.
P4 was the easiest.
P1 was the dumbest thing
I
there
think
is.
P4 was dumb because like you can miss the case that Riddhiman figured out and you
P1
use
is very
partials.
like,
Okay,
I
yeah,
think
P1 was just like, okay, fine.
you can potentially head solve it in 10 minutes in contest.
Not
Yeah,
I
sure
think
why you
both
would want
P1,
to do
P4
that.
you can head solve in 10 minutes. Like,
Some China
If you
fellow
are-
will do it.
except write up.
Oh my god, why is
P1 you
P5
can do
so
write
long?
up in 10 minutes also. Like
Now it makes sense. Like they just like China people just farmed like P1, P2s and then give infinite time to P3s, P sets. Like,
Basically, yeah.
okay, but P2 wasn't that farmable. Like
P5
Oh.
was easier than P2. P2 was like hard.
P2
I
was
don't
40
know.
minutes. P2 was 40 minutes.
bro, P2 was hard, but it was
Also,
standard.
we
Like
cope,
doing that and
we
then
coped on the
G is
standard
not
like
anything crazy.
power of
But the
point.
only crazy part is neighborhood, and that like China people cooked.
Neighborhood
Yeah,
is
the
not
neighborhood
crazy.
is
Like
good.
if you didn't think of the neighborhood, I did the first also. After you
No,
get
no,
this, you
Aritra,
would
neighborhood
have
is
think the
Actually, I
neighborhood
agree.
idea.
I agree. Like once you solve the inequality, then you will be done. Like you don't have to think of neighborhood.
Yes.
yeah, like Arithra was
Yeah.
thinking about neighborhood before, but
Wait.
you would have done that inequality either way. And
Exactly.
If you
once
do
you
it
do
in
that,
1
Like
hour,
you could have figured it out after
wait.
the inequality too. Like you get the square
No,
thing.
like once you figure out the inequality, once you try to think about it, it's like natural. Like I'm
I mean, it's
assuming.
kind of point-wise trap. I don't think they will cut much for the point-wise trap.
they will.
They
That's
will,
easier
like,
2-point dock, surely.
People, like it's
P6
10.
it is. Okay, we can wait 1 minute for good measure because it's nice.
Yeah.
Wait, if you
9:59.
finish this in 1 hour, I'll catch a nap
What is
before
it,
the
Shanti?
finals.
Let's give this 1 hour. Whatever progress we have, we'll stop there.
Yeah, then
Oh,
I'll
it is
sleep.
10 o'clock. Enough of like.
I don't care. We're solving this in meeting. Baat khatam.
No. I have to go before like 2. I cannot spend 2.5 hours, bro. World Cup bhi
No,
dekhna.
this will not take 2.5 hours. Touch.
Okay, let's start.
Like I'll also go. I have to have dinner. Let's give this 1 hour, then we'll see.
Sure. Dekho, trust. We have Arithra with us. Ho jayega.
Yeah.
Where is the
Yeah,
problem?
yeah.
Just a
I hate
generating
the
function.
problem. Its statement looks so good.
I like wait.
AN is the smallest 20. Bro, what?
Wait.
Oh. So it is basically like random stuff. Oh, it is periodic module or something. Not quite actually. It's just random. Like, yeah, hai ye. It's in the
It does seem
smallest
standard.
integer.
See, let A1 be prime because
When it
why not?
exists, yeah, it's like we can
It
do
seems very
something with the
standard.
primes that are in common, like some VP argument.
Okay,
Wait, no,
wait,
it's
look.
oh wait, no, it's
Let
equality.
A1 be prime, then A2 is 2 times that.
Why?
If A1
why-
equals
wait.
P, A2 equals 2P,
Small solution. Oh, I see.
Prime
and
is
then
done.
Yeah.
A3 is equal to 3P. Oh,
And
It's
then
just
all-
No,
KP.
no, that's not
A is
necessary.
KP.
A is 3.
Wait, A2 is
Wait,
not.
no, that's wrong. Wait,
No,
yeah,
because
it's
GCD
3.
everywhere is like P, right? Because A1 is
exactly.
P, so
Yeah.
GCD has to be P.
Huh.
Yes. It is.
Wait, why
So-
is A2 2P?
Because
Oh,
uske
no.
pehle it's not divisible by
Yeah,
2.
yeah.
But what if P is
So,
3?
yes.
What if
what
P
if
is
P
3?
is P?
Then we have
then
3
what?
there. Then we
So-
Then
have
also you have
3
3, 6,
there.
9, 12. What's the issue with that?
Yeah.
But what?
By the way, any even number is
3,
also
6,
done
9, 12
because
times
like
two. No issue.
6, 9, 12.
If
It's
like
not
if it's
increasing. They can be like we can repeat. So like it can go smaller. Like.
No. It's smallest positive integer
Greater
greater
than
than n.
Oh. I see.
Yes. Okay.
by the way,
What if
like
it's
if we have
even?
any even number A1, then like A2 will be the next
Yeah.
even number, A3 will be the next even number, A4 will be the
Oh,
next even number.
okay.
Bro, is it like prime?
That's
Like just take
true.
the smallest prime divisor.
Sure.
It is not that easy.
No
It's
way.
P6.
No way it's that easy.
E2 is 2k plus 2. I think we're done from prime and even.
Wait, what about 3?
Aditya, can you like show the screen properly? Because I don't think others can see it.
They can see it, I'm pretty sure. At least I'm
They're able to see it.
Okay, yeah.
Okay, this is like component.
because
Yeah.
it can't be like 2k plus 5 because
2
the
is the
last
smallest
number
prime divisor, yeah.
it is like GCD is 1. So
Okay.
But
Sure.
like
so
k
we are
is
done
not
with
k is not divisible by 3.
wait, by the way, I think we're also done with prime powers because if it's p to the power k, then
Then
also
p
it
to
will
the
repeat
power
by
k.
p.
Oh my.
P
And
to
you
p
also get the same thing. Okay, prime
What?
done, prime powers done.
prime
Then
and prime power are same.
Wait, so where is the difficulty in this problem?
So
Let's
Rukona.
so
okay.
go to
Let's take an
so
example.
directly
Na.
go to
Let's take
15.
the point where
Directly go to 15. It's
A1
the
equals
smallest
15.
number.
yeah,
A1
3
equals
times
15.
5.
Wait, why is even done?
Like
15
A1
is
is
the
2k,
smallest
A2 is
odd
2k
number.
plus 2,
Just.
A3 is 2k plus 2.
Oh,
GCD is
Why
always
not?
2.
oh, never mind,
Okay,
stupid.
At any
18.
point, it can't be two consecutive numbers, like
Because
because
co-prime.
GCD is 1.
Oh, 20.
Wait, this is exactly like that SL. This is like for PQ at least. That's exactly like what I said.
Wait, this is an odd number. Every other number is even. We must get odd number again somewhere there.
What?
Wait, after 20, when is it 24?
It's
Okay,
45.
20.
Okay, it's like 30.
Okay.
48,
Is it 48? Okay, it will repeat after that. Yes, it will
50,
repeat.
54.
No, are we sure it will
You can
repeat?
stop writing. I'm pretty sure it will repeat.
Oh, sure, fine.
Is
Like
it?
we can just see the odd numbers. After the point odd numbers repeat, it will probably repeat.
Yeah, but probably is not equal to Schultz.
Like you do not prove, obviously, but like
Sure.
heuristically it will repeat.
I agree.
I mean, wait, let's just quickly try. Na. I mean, 50 and 54. Chalo.
50. Wait, like 60?
Oh, I think so.
It should be
30,
divisible by
30.
5 or it should be divisible by
60
3.
there.
3.
Does 57 work? 57 does
Yeah.
not work. Yeah, 57 doesn't work,
57
so it's
works.
60. And does 60 work?
Yeah, 60 works.
Yeah, it does.
Wait, why? Okay, everything else is even, so you only need to check with 15.
Oh, so it's like mod 6. It's like mod 6 jaisa ho raha hai.
No.
It's not
Okay,
mod
okay.
6 because like you have 20, right? So it is like somewhere in mod 6, somewhere in mod 10. Wait, see 20, 30,
You're
40. It
adding,
has a
right.
distinct mod 10 chain. 18, 24, 30, 36, 42. This has a distinct mod 6 chain. And there is like a 15, 30, 45. There is like a mod 15 chain. So it's like 3 chain combined together.
Wait, wait, hold on. Do you guys see something? It's just like multiples of 5. So you have 15, 18. Okay,
3.
that's a 3. And 3, that's a that. Huh.
Wait, did you hear what I said?
Yes,
Yeah,
the
it's
three
like 3
chains.
different
What will
chains
you do with
combined. I
so
agree.
many chains?
So I'm saying
How
like
will you
there are
combine
3
them?
APs mixed together. Like
Oh, but then
see,
they have to like
Okay.
meet at some point.
yeah, like it is
Chalega
A
na.
union B union C. It's not A kind of.
Yeah.
Wait, see
Like
here.
one is the
Like
15 mod, one is the 6 mod, and what is the 10 mod, and there it is A
everything is
union B
either.
union C.
It's like, wait, isn't this just the list of numbers? Which is either a multiple of 6, 10, or 15.
Yes,
Ah, yes. That is interesting.
that is what I said.
It
Wait,
is?
but like
It
Oh,
is.
it is. So फिर it will be like क्या बोलो 6, 10 and 15, right? So
6, 10, and
it will
15.
be
2 times 3, 3
LCM will
times
be the
5.
period. Yeah.
Huh.
Like
But
eventually.
15 makes sense because of 3, 5. Why does 6 and 10 make
हाँ,
sense?
where are we getting 2 का? What if 2 का factor हर में आ रहा है? Like every time
2
there's
का
a
factor हमें 8
Probably
लाख
it
से
is
आ
like
रहा है.
less than equal to.
हाँ,
Because we have
all
3,
the
5.
primes less
Yeah,
than
yeah,
equal to
yeah.
it.
Yes, it should be all the primes less than equal to. Yes.
Oh, what?
You have to
Actually,
get 2 because like as soon as you get an odd number, if it's like
Wait,
if the
why are the
GCD
primes less than the thing?
Exactly like
Oh,
Yes,
because
GCD
That is
will
here,
make
strict
it
all the times
make
that
it
the
gentlemen.
repeated
like
Wait, can one
no.
person
many
speak?
people.
Okay, fine. As soon as you get an odd number, since the GCD must also be an odd prime, which is not 1. So,
Yes.
sorry, it's just an odd prime. So then the next number has to be like odd plus odd even. So like you always want
Oh.
to have even. So 2 is definitely going to be there.
Right.
Wait, I think this idea kills. Like,
What?
Does it?
It
How?
doesn't kill. It's not.
No,
How would
no.
it kill?
no, I'm confident it will kill actually.
Okay,
Like,
wait, let's try
Yeah,
with
but you have to
21.
prove it. But I don't see why this is true all of a sudden. Like,
no,
why
no,
this
no.
should be true.
I get intuitive feel.
Okay, after 21, you have 24.
Like, why can't there be like large primes and stuff?
28. Is it 28? It should be 28. Yeah.
So like I mean, wait. This is all.
Wait, it's 27, right? Not 28.
oh, right, 27. My bad.
And 27 is a power of 3. So it will be like, it will go by 3 now.
Will
Wait.
it?
Because it is a power of 3.
No. You can have stuff before that.
No,
can-
like 27 is a power of 3. Like to make the GCD like not equals to 1, you have to have the GCD equals to 3.
Yeah, that's true. Oh,
For prime.
Wait.
Like if
I
we
see.
ever have a prime power in a sequence, this must happen.
Okay. So now you'll have 30.
Just it must be this thing. The
Oh,
numbers
and
must be
all
this
of
thing
these are
mod.
also divisible by 3. So
Yes,
Okay,
so
this
this is like a
mod 30.
3 APs.
now it's just AP. Yeah.
Wait,
So
yeah, you can
it's
look at
like
this as well. It's
after
just this
A1, all the
mod
numbers
30.
which are multiple of 3.
No,
Like-
but we got lucky because these two are also divisible by 3. What if they were not? Like, I don't know.
Take a number, another number, then I don't know.
Yeah, we should like
Wait,
check more cases.
How
Like,
did you get APs? Like, see, I got this thing. It's like this stuff mod 30.
what is the next odd number? 35.
Yeah, take
35.
35, 7, yeah.
Yes.
No, 33. We didn't take 33.
Then 40.
Oh,
33
I
33.
think-
is again divisible by 3. So
30,
that,
but let us take not 3 and 5. Like, let us do something with 5 and
Let's
7.
do
not
5 and
take 3.
7.
35
Let's
ही
do
करते हैं
33.
एक बार.
Let's do 33. Right.
Let's do 35.
35 करते हैं,
No,
35.
Okay, you
35
do
is better.
35.
We
I'll
don't
do
want
35.
3.
Because you have
We
to-
don't
Okay,
want
bro.
three.
People, like, if we show this, we're done. Because,
If we
like,
show
it's all
what?
just
Wait.
multiples mod 30. And then just go step.
Wait.
You'll be done.
But Adam, you can do 33. We can do 35. Like,
Fine.
both can be done, I guess. We have too much manpower to do it.
Yeah, too much manpower.
Crazy.
3 times
Wait,
16.
44, 45 can't happen together. What are you coping on?
Oh, हाँ,
Ah,
right.
yeah. What?
Wait, 35
How is
after
44 and
what?
35 GCD is like
That's 5.
44,
right?
35 GCD is 1, right?
Yeah, wait.
Wait, for
Five.
It's not only last 2 terms, like think and right.
Aritra getting.
Is it 48?
40.
Hold up, like, why can't it be
5,
44? Did I
45
misread?
Okay.
Make
48,
45. That should work.
49, 50.
it should be 70, right? Oh, no,
Does
wait.
50 work? No, 50 does not work. 51 also. 51? No, 51 and 44 don't have anything.
5, 7, 8.
48 does not.
Write the primes.
49.
Write
I'm writing the
primes.
primes.
So
No, like 5, 2.
does
I guess.
52 work?
5, 2, okay. You mean this?
It should work.
Yeah.
Yeah, 52. And then
Oh, I don't say aloud. I'm
54. Wait, no, 52. Never mind. 52 does not
6,
work.
47,
54.
48,
Yeah, 54.
49.
Okay.
55. What? Yeah, 55,
No,
33.
55. No, not 55. What?
Works. Does it work?
55, 33. What?
Wait, 50.
Oh,
How
you
does
are talking
50
about
work?
your list. My bad.
How does
Yeah.
50
Wait,
work?
55 is not with 42. No,
6.
Wait, how does 50 work?
56 should work, right?
50 doesn't. 50 works because it has 2 5. Okay, another thing. Wait, it is also giving me the GCD vibes. Because
Yeah.
like the radical, if we take it,
Oh, okay, 50
like their
works.
GCD has to be non-1. So you can like work with the radical and not with the actual number.
Yeah, that's what I was like.
That is true.
thinking.
Like, just write out the prime powers. Sure. 56
What?
works.
I don't think it works.
No,
Like
3
56 and
and 5 does
45.
not exist.
45 the works.
It's
Wait, are
either
you working on 33 or 35?
Our case and our claim is
We are
that
doing both.
2, 3, 5, 7.
No, I'm
like
asking Aditya.
Okay.
2, 1, 0.
51, 52, 53.
Is it 52? It's not 52, no.
No, it has to be divisible by 5 or 7. So like next is 60.
Yeah.
60 works. 60 works. 60 works.
Why
That's
does
60 work.
56 not work? 56 works.
Oh yeah,
right?
60 works.
Because like
No,
3 and 5 is there, right?
like
Yeah,
Uh,
Okay, so 60.
63 काम करता है क्या? 63 does not
नहीं
work.
63 नहीं काम करता.
65.
So 3 and 5.
65 does not
Wait,
work.
63 does not. Yeah.
65 does not
65.
work. 70 should work. Yeah.
No. How do you get 3?
Oh,
You don't
right.
get
We don't have 3, right? 70 does not work.
Hey,
So
But
2
why do you
times
want
3?
70? 70 works, right?
no, we
How
don't
does
have
70 work? You don't have a multiple of 3.
No,
You
but
don't
we
need a
have
multiple
bro.
of
You don't
3.
need a 3.
Shit.
I don't think you need a 3.
Wait,
You need
everything
like either.
at this point we can just repeat it like multiple of mod times 2 times 3 times 7 times 5. Like whatever the hell this is.
No,
Which
but
is
like
what?
smallest.
2
Like there
times.
is a big n after which it.
But did you check all possible cases between 60 and 70?
I did. Like it has to be divisible by 5 or 7 because of 35.
Yes.
So 65, 63. 63 does not work because it does not have
65 does not work
56.
either.
70.
No, sorry. 63 does not work.
75.
Because
And
of
if it's
40.
not divisible by 5, it has to be divisible by 6 because of 40 and 45.
40. So like it's not.
42.
72. 72.
72 work. Okay, this is getting a bit tedious.
No, 5 and 7 does
No,
not work.
72 doesn't work because 5, not 5, not
35.
7.
Okay.
73.
Like just take multiples of 7 of 5 or 7.
But I'm trying to understand what is going on here intrinsically.
Same.
Wait, my question is, do we need this? Once we hit mod 210, can't we just like look at that? Do we actually need to look at this?
We don't. Well, we need to hit
But
mod
for
2
now,
then,
we
na?
need to know which numbers appear, right? Because we are trying to guess which pattern it follows. Like,
Okay,
I
there
mean,
will
can
be
you
like
show
some
that
issues
any
at
other
some
number, like the prime does not increase? Like you won't get a prime greater than 7. Can you show that?
Will you have 99? If we have 99,
Wait,
then
by the way, another thing is for a general sequence, like in the sequence of 35, we have 40 and 50, right? So you don't need to check the GCD with 50 because the GCD of 50 and GCD, like the 50, the primes that 50 is made of and the primes 40 is made of are same. So like if GCD with 40 is like non-zero, then GCD of with 50 will also be non-zero. So all the numbers are not relevant.
True, but like, sure. I think it will only help in case batch.
And if it is the divisor, then also like if it is
No,
some
I
2,
mean,
5 and
Wait.
like 3,
How do
then
we have
also it's
this?
not relevant.
How do we have this?
Dekho, I
Excel
agree,
number.
but like my point is that is probably helping only in the case batch and not.
Should we actually try to prove that the thing that there can be a prime bigger than the
But
largest
I'll
prime
try to
I think we should
prove.
do a Tanushka's thing.
I
like,
think
that's
it's like
probably helpful.
the version reminded us, but
But
I
what will you
think
try to prove? What is the claim?
Like
for the
in
sake of
those,
contradiction,
like the
like
smallest prime divisor of any term is at most 7, like in our case. Say.
I
so
see.
like
That
the
makes
way you
sense.
could probably do it is like assume ki there is a small.
Bhai, but just consider
What
the
happened?
first number. Just consider the first number with a prime factor greater than, with the smallest prime factor greater than all of these. That is a contradiction.
What?
Just consider the smallest AI such that all the prime factors of AI is greater than the largest prime factor of A1. And then that is a contradiction. That's a contradiction.
What?
I still don't understand.
देखो ना, consider the first place where all the like 35 में 5 or 7 है. Consider the first time where like all the prime factors are greater than 7. So like 11, 13, whatnot. So like these just cannot be divisible by any of the guys here because
No, but like the
primes
real
are.
problem is like suppose you have something like 4 times 11 and like 11
Yeah, but
doesn't
like
come
A
there.
is the first time. A is
Oh.
the first time 11 appears.
Yeah, that's
So
what I was saying. Like,
it
Or
will have to
any-
work with 10.
and we want to
Right.
prove that there exists something before that that has all the primes.
No,
that
no,
we
just we
want.
can just look at the smallest one now. We don't even have to do anything. We just consider A to be the smallest one such that all the prime factors are. Wait, does that
Okay,
Sure,
okay.
work?
but like,
Oh, wait, it
yeah,
does
but
not
that
work.
doesn't prove the claim.
Ah, wait,
We
it does
have
not
to
work.
see, like, we have to
It
prove that
works,
there
right?
exists something between A and the right.
Wait,
What's
wait,
the
hold on,
claim?
hold on.
The I
Should
plus
we-
one and then the term that we have. We
What's the
prove
claim?
that these things have
Okay,
primes.
what idea do we have
Oh.
written?
Wait, what's the claim?
Yeah.
Oh, I see, I see. So
Hello?
basically, if this is
Anybody?
the last term, okay, the claim is that you don't have any primes. In the whole sequence, you will never have any primes that are greater than the largest p that you have at the start.
What?
So, like
Sure.
in this
Like
case, you don't have any p greater
Okay.
than 7.
Okay,
Not any
What-
P, like the smallest prime divisor has to be at most 7.
sure.
The smallest prime divisor of any number has to be
At most
lesser
7.
than or equal to the largest prime divisor at the start.
Yes, exactly, exactly.
Okay, wait. So you're saying I will write that down.
Did I
Well,
mess up then?
Well,
Like,
No, you're on the right track. I kind of missed up. But it's okay, I think it's fixable.
But are you sure that we are on the right track?
I
8
think so.
minutes.
Like, this feels very natural and good and motivating. So,
Yeah, this feels too natural.
I mean,
We are working natural numbers.
oh my god. Okay. That is.
cringeworthy statements.
Proof Tanishka has officially gone
I
live.
have plus
I am thinking,
7.
can we prove like large enough primes doesn't contribute to the GCD? Like, say in the case of 15, we have 42, right? We have 7. So I want to show that
Yes.
if we have some number later down the line, then like it is
I
because
think
of 2 and 3 and not because of 7. So even if it did not have the 7 part, we did not like the sequence will be the same. Like
See, like
after
the
a point, we
idea
only care
is,
about
I
the small
guess,
primes and not the large primes.
I think Aditya,
How will
what
you
we can try
distinguish
and say
between
is,
large and small primes then?
if
Yeah.
even if some large prime divides it,
Okay.
but
It will not be a prime of the GCD, I'm trying to say.
exactly, yeah,
Yeah.
like, there will be some other number smaller so
Hmm.
that that prime does not divide that. And so like
Exactly.
you will have some like other prime, how do you say this?
Other smaller prime dividing both of.
Yeah,
Okay.
That is what we're trying to prove, right?
Okay.
Isn't it?
Kind of, yeah.
I'm confused now.
Which primes are they though?
wait, so let Q not equal
My head is actually hurting right now.
same
Oh.
largest prime divisor of A1.
Is anyone live right now? Let me check.
There is no way people are
There are
watching.
10 people.
There
One
There are?
is
people.
One is
Yes.
me.
Hi.
one is Anirudh Padigal.
One is me.
Wonderful.
One is not me.
That is just Wait, how many views did the previous Livesolve get?
Oh, there's like 2 more viewers now.
We have 35 likes. I'll do the 36th one.
Wait, should I
I'll do
should have
37.
Wait, Mahotsav is here and Paras. Crazy.
Hey, like the video. There are 17 likes.
Yo, Paras is what's up is here? Crazy.
Paras. Why do I randomly come in and I hear the word Paras? Let's not
He
say
is
that
an
randomly
online
like that.
I'm back.
Wait, it shows 12 people. are
Aditya,
watching.
someone's calling you sir. What do you want to say to them?
Can you zoom
I'm
the
not that
person?
old.
No, you're old. He's old. He's old.
Wait, there are 42 likes right now.
That's crazy.
No, there are 17 likes, right?
We're 33.
Mohotsav
Om is
there.
here. Om is here.
Oh,
damn.
my
Wait,
dear.
no,
Oh,
wait,
we-
no.
we have
He
Om.
just has the
Okay,
Okay,
same
everybody
one
is
here.
joining. We wanted
It
No,
Om.
doesn't
that's
mean
the
it
home
is
PFP,
Om.
but is it home?
I don't think
What's
so.
that?
Oh,
What's
but
up,
it is
guy?
Om.
Other people have Om PFP.
Wait. Whoever is like, yes, Aritra is extremely old. Thank you for clarifying, Paras.
Okay, let's just focus on the problem.
Wait,
Yes.
but
Not
I
on
want
my
to.
age.
Whoever user BN is, are you or like what's your name? I shouldn't have asked. Are you? Shit. What have you got till now?
We're
I think
having
It's
ideas which we can't prove.
Right.
True.
Any progress on the claim? Like 7 is the largest prime divider.
Hello.
Oh, Om is here.
I
Hello,
think we can
Om.
prove
Zoom
that.
here.
Om is
Hello,
there.
Om.
oh hello.
Okay, the stream is going
Hi.
like a bit late. Okay, yeah, that was me only. I just
Hello.
joined. We are still
Oh,
solving 6.
P6.
Yeah,
P6.
P6.
Did you guys did P3?
We
Yes.
did everything.
Yeah.
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 Aritra, like zoom in on P3. Go left and zoom in on P3.
P3 was
This is
low-key kinda insane.
this is P3.
Wait. I can't see zooming. Okay, I
Like
think
there are
you guys
much more writings from here to here.
nice. Okay. Yeah, P3 was crazy problem. P6
It was.
P6 also beautiful.
Beautiful, though we can start agreeing on. Yes.
Yeah, it
Yeah.
looks good.
I think there might
How
be some touch on analytics. Like we can do
obviously.
like gap of primes that and some analytic NT. I don't know.
We might.
Oh,
No. I
wait,
actually
I
don't think. I
I was
don't think.
waiting for Aritra to call in analytic anti, of course.
Can I call an
Like we
algebraic?
can
I'm
make
just
the
waiting
difference
for
of the prime.
CD.
The difference of the numbers
Okay.
can't be large enough because of some size bounding. I don't
Wait,
know.
I think that has a very good, like, elegant elementary solution. This reminds me of that one, like, China MOP5.
Oh,
Like, the C
Okay,
of,
I
like,
will go
A
now. Bye. Have fun.
I own.
by Ohm.
Bye.
Wait, is Ohm back from.
Bye,
Yeah.
Om.
Why would he be? Why it ends in
No,
August?
I'm in USA. I'm
Oh,
going
you're
for
still in
filter.
USA. That is peak.
Om, don't
Update.
remember your
Wait,
goal.
Why
you're
are
in
you in
USA.
By
Why
the
USA?
would
way,
you
it
not
is
go
in
towards the
YouTube. You
World
know
Cup?
that, right?
Wait, are you going to FIFA or something? Where in USA?
Home left.
Oh, okay, I'll message
Wait,
him.
wait. What? Wait, why did Ohm not go to any FIFA match? Like, क्या हो रहा है? कुछ भी cope कर रहा है.
Bhai, he's in a camp. For heaven's sake.
तो FIFA is much more important, bro. That is like
That's
silly.
not true.
It's okay. We will now work on the problem.
Good idea. Best you had all day.
Wait, is it true that after a point the times will decrease or something? Like you shouldn't have like two large primes, obviously, or else the AP thing does fail.
I'm thinking how to introduce size.
How to
How
introduce?
to introduce?
Size idea.
Oh,
Let me try some stuff.
It might use like CRT stuff as well, but I'm not very sure.
AK plus 1 minus AK. So this is like the GCD we had minus that thing. Okay, no, no. I don't think there is good way to do it. It just seems random.
Oh, wait. Did we prove the claim that no prime above like A1 may exist?
Okay,
How?
I can like loosen it to A1 and not just. No, I'm not sure.
Like A1 is like, see, okay, like you can probably do that, but like in the end, you just want a bound. And that, oh, wait, after.
I think like, if we get a bound, that
Every
is good enough,
possible
even if
bound.
it's not like 2, 3, 5. Like if it's not too good of a bound, if we have any bound, that will probably work.
I didn't see that
Constant.
it was for every end. Let's see how to make that.
Wait, I think I have a proof that the smallest
Claim?
prime factor of all the terms is like at most the largest prime factor of the first guy. So we will
You
prove
have a
by.
proof?
For
I think.
The
Wait. I think.
smallest or the
Wait.
largest? The
अरे no, smallest भाई, largest तो like कुछ भी हो सकता है. देखो suppose this hypothesis is true till like some AL. So the smallest prime factor of this is P, which is less than like A1 ka largest prime factor of A1 is Q. So P is less than
Sure.
equal to Q. Now consider
Sure.
AL plus 1. Observe that it has to be it has to have something in common with this.
Yeah.
Okay.
So the gap AL plus 1 minus AL has to be greater than equal to P, small p,
Yeah.
because the GCD. But then if you take the smallest prime factor of AL plus 1 to be larger than Q, then this gap will have to be larger than will become strictly larger than P. Wait, no.
Wait,
Okay,
what
hold
did
on,
you
hold
So
on.
that doesn't make it can be larger than Q, right?
Wait, hold on. I think it's probably something along those lines.
Okay.
I just have to bring in
Just formalize your thoughts, I guess.
You know, that is true, right? Like if okay, like fine, like both of these terms have to have like GCD greater than 1, then consider the difference. Their GCD is also divisible by the GCD, and the GCD is divisible by P, which is P is less than is like the obviously like it should be pretty small. Wait, no, I see.
Oh,
Never
but
mind.
I
That is
think
wrong.
I have the same thing as Riddhiman,
but more stuff.
but not with
Wait, that's
A1, but
just
with the
GCD, right?
not with the largest prime of A1, but with like A1.
Oh, okay, A1, sure. Like
A1
a slightly
itself.
looser bound, sure. Go on.
Say AK is CP. Okay.
Yes, CP, yeah, sure.
While P is
Guess
the
what?
prime, I'm saying P is the prime. It comes for the first time. Let's say P comes for the first time, and AK is such a number.
Okay, P comes for the first time, sure.
P comes for the first time. Now, GCD of AI, AK is something that can't include P. Basically, divide
So it has
C.
to be like
He
C,
does not divide this. Yeah.
like serious to
So
alpha.
say it is some QI.
Sure.
Okay.
Why is it supposed to be a prime?
It is not prime.
The Q high.
But like we can take the primes. We only take the primes, but
This
it can't be prime.
can't be.
But I'm just thinking, can we prove Q is less than P? Okay, I think I want to prove Q is less than P. Then I might have something
What's
I
Q?
have to prove. Q is like let's say the smallest prime divisor of C. Let's say that.
Wait, what is C?
C is
C
the
is something
AK
AK
divided
into
by
CP.
AK divided by VP of P to the VP of. Okay.
Okay. And what is
Okay,
P
yeah,
then?
CP to the power alpha. That is better. I didn't think of alpha.
Wait, what is P here? Oh, so the
P is
non-GCD
the
part,
prime
right?
which comes first, like a prime,
Got
and
it.
AK is the number where it comes first.
Hmm.
Okay, no, I want Q to be less than P. Okay, let me
Oh,
think.
wait. So basically, P to the power. So you from here you get that AK minus 1 is less than C. Right.
Not, do we get it? Why can't it be something
Yeah,
like CQ?
because if it is not less than C, then you can use AK to be C times P to the power alpha minus 1. So, right.
Right.
So AK has to be less than C. AK minus 1. So you could bound it sort of.
So it is
Wait.
CP. It can't be CP to the power alpha, right? It is CP. Like
Wait,
if a
what?
prime
Yeah,
comes, it
exactly.
square come from.
What?
I see what Devarchan is saying.
Wait, can you repeat? I was thinking of something else.
Yeah, wait.
See-
I what I'm no, it can be CP per alpha given that AK minus 1 is less than C.
No, if
If it is
AK
greater
minus
than
1 is less than C, then why will CP power alpha comes? Because like CP
it
also
cannot
does the
be, I
same
see.
job
I mean we need CP
because the
per alpha
GCD
to be
is like,
greater than got it.
and it is greater than AK minus 1 because of
Yeah.
CP it is greater than that. So the power alpha, we don't need the
So,
alpha.
yeah, because if CP squared works, then AK equal to CP also works. So
Yeah,
like CP is
exactly.
the smallest.
Also, C is less than like P equal to 2 words, right? Then just.
No,
So
I'm
we
saying
can-
like we are fixing the prime and like
Yeah, so
varying
we can
k.
fix prime to be 2.
We don't
not
do p equals to 2. Like we are taking large enough primes. I want to work with p is large enough.
Oh, no, so we get a contradiction there because we are taking AK with the first one where a larger prime occurs, and then we can show instead of that 2, or like P, we can use 2, then that prime could never occur in the first place. So we get a contradiction. Right?
Okay, but by the way, how did you prove AK minus 1 is less than C? I didn't understand that part.
I mean, okay, you considered CP to the power alpha, whatever, CP minus 1, like P minus 1 in bracket. So if this
But can you
is,
write it?
I don't have a stylus. What I'm saying is
Okay,
C
okay, yeah, can
and then P minus 1.
it doesn't
If
have to
this
be
is,
of this form always, right?
I mean, no, just consider this thing. If this is
Okay.
greater than, oh wait, that is not exactly what I want to say. Like what I'm saying is if this is greater than this, then I can say this is my AK. Oh, so this is P
Okay, this
minus
is
1.
C into
my
P
bad.
minus 1. Okay, that I
Yeah,
see. C into
P
P
minus
minus
1. This is not good. This is not correct.
Not C. Yeah, yeah.
Yeah,
That
not
makes
C.
sense. C into P minus 1.
So from there, I wanted to do some other bound.
Yes. Yeah, yeah, yeah. That makes sense. I think now we are actually doing something because like we have
Wait,
numbers.
so what did you prove right now?
Nothing.
CP minus 1 is less than CP minus 1.
AK minus 1 is less than CP minus C into P minus 1.
Why is that true?
Otherwise, we could have just taken C into P minus 1 because P comes for the first time. It
Okay,
doesn't contribute to any GCD.
I see. Sure.
Less than equal to, right?
But AK minus 1 should be greater than, right?
Greater than, exactly, yeah.
Uh,
And equal to, huh?
yeah.
Oh,
Yeah,
right,
greater
right.
than and equal.
Wait,
Yes.
if Q divides the GCD of A1 and AK, then like from all the numbers from 1 to AK, there must be like a number AI, like sorry, not AI, some number, which is basically equal to Q to the K times C. Huh? Some K.
I agree. We are just hoping like there has to be some prime factor of AK common with A1.
I mean that is obvious.
Okay.
Sure.
Yes. I got a great idea. Thanks to Ronit.
What's
You're
that?
very welcome.
See, Q divides GCD of A1, AK,
Huh.
and
Yes.
then Q is less than P. Can we say that?
Q is, what is P again? Oh, acha. Yes,
This prime.
Wait, which
P
prime?
occurs for the first time. So P is what prime? Is it a random prime occurring for the first time or?
Okay, because
Like
it occurs
Q
for the
over
first
P.
time. It's
If
not
we-
random prime. It's like a large enough prime occurring for the first time. Let's say
Then
that.
Q is obviously less than P. Like Q is like,
Okay, yeah. Large enough mean because otherwise Q divides A1. So Q is less than A1. We can say that much.
Exactly.
Okay.
We forgot about that.
And P take P to be large enough. So P is greater than A1. Then we can take Q to the power KC, and it is we can take Q to the power KC such that it is between AK minus 1 and AK, and it does the same job of the GCD.
So you're saying there exists an AI which is of this form?
Yes, like we don't have to take AK, we can take something less
Then
than AK,
like
which does the same job.
Then like AK over AI is greater than or equal to P over
But I'll
AI.
come in 2 minutes.
Oh no,
Okay.
not I. 1.
Wait, what? I didn't get it.
Hold
Wait,
on.
Ronit, what was Q? Can you just brief me once?
Q is any prime dividing the GCD of A1 and AK.
Okay.
And what's K here?
I mean, how that just wait, but
AK
like
is some number of the form CP.
AK is
Where
the
P is
first
the
term where
first
P divides
prime.
AI.
Okay,
Wait,
listen. Start fresh.
Okay.
AK is equal to PC. Okay, like we really don't care if alpha is
This
equal
is
to
the first time P is the divisor of the sequence.
First time, yes,
First
first
time
time.
P is a divider of
Yeah.
this. Exactly.
So basically, what we are saying is what Aritra is claiming, based on probably something what I said, is that there exists an AI where I is like one less than this, such that AI is equal to Q to the K. Okay, no, we're using K twice.
Q to the C, yeah.
L is C. Same
I
C,
see.
same C.
I
And
see.
Q is a prime which divides the GCD of A1 and AK.
I don't
Okay.
think that is what he was. Okay, might be what he's saying. I'm not sure.
Why is this true?
GCD of A1
Who
We
knows?
do not know.
versus
We do
GCD
not
of
know.
A1 and C. And that means Q divides C.
I am
So what is
actually, I
the
have zero idea why. I don't know if this
why-
should be true.
Wait, but like, how is this motivated?
I'll just let Aritra
Aritra.
confirm if this is what you are saying.
Aritra will come back. Okay, Aritra's back.
Like, it is kind of.
Okay, yes. What did you guys say? I wasn't here for some time.
What exactly were you conjecturing?
Or like nothing really. I'm just working with it
Oh,
and see
Aritra,
where
this
I
is what
go.
you were conjecturing, no? This is what you said.
Oh
That
yeah,
like
like I
QI AI is equal to Q to the LC
yes, I
for
was
some.
conjecturing that there will be a number Q to the power LC if P is like large enough and instead of AK. So
so wait,
which
it will appear
does all the
before.
What
job.
do you mean instead of AK?
It
Okay,
will appear
fine.
before
We
AK.
can take
Like
this.
I'm saying CP can't occur because this is greater than AK minus 1 and the GCD with Q to the power LC and all the terms before AI is like non-zero. So like CP can't occur because CP like directly after AK minus 1.
Okay.
Wait, wait,
How
what?
are
How
you
does this even
guaranteed to
help?
have
Like,
such a
we
L?
already had P minus 4 into C.
I don't know. Like I don't know the proof. I'm like thinking of something along
Okay, so
those
like
lines.
we know AK minus 1 is greater than CP minus 1.
Very good, yeah.
Yeah. True.
CP to the
By
alpha
the what you
minus
can
1.
do is take
Alpha,
AK
yes,
by
just
A1,
one, just
right?
one.
So what you can do is take the prime to be greater than.
Wait, why
Wait,
is
you
this 1?
want P
Why is
by
it not
A1 to
alpha?
be greater than Q. You want P by A1 to be greater
No,
than
no,
Q.
wait, Arham, alpha is 1, we know that.
How?
Oh, because if CP squared works, then AK equal to CP also works.
But you could have skipped over it. That's not how it works, right?
I mean, we are assuming ki C verifies with everything else before. So, like, CP
Okay.
but also verifies with everything else before.
I mean, but no, that doesn't make sense. Right?
It does, right? Because, like, C handles all the GCDs before AK, like, before AK.
Yeah.
You are saying कि CP like CP squared like CP was skipped and CP squared पे चले गए, but then CP भी तो like verify करता है ना. CP works with all the GCDs before, even some GCDs which are after it.
Yeah,
But how
see,
do you know that
because
is
all the
greater
numbers
than
that have come
AK
before
minus
with
1?
CP,
Are like
if there is CP square, the GCD with CP square is like not equals to 1. Then the GCD with CP also can't all be
Okay, I
equals to
see, I
1.
see.
Then
I
we
see.
can't skip CP
Fine.
But how do you know
if we
that
have CP
CP
square.
is greater than AK minus 1?
By the way, like there must exist some number between A1 and like AN. It need not be in the sequence, but it
What do
must
you
be a number such that it's like some Q to the UC. Just because of this thing.
But did you, how did you
Okay.
wait,
say P by
AK
A1
over
is greater than
A1
Q?
is greater than equal to
Because
P
we
over
know that
A1?
AK is equal to PC, na?
How
I
did you
see.
get this? P over A1 is greater than Q?
This thing is greater than A1. Like just take a huge P.
Okay.
Look, okay, by the way, like
We
we
don't
don't
have
need
control
huge,
over
like
P.
doing P greater than A1 square does it because we know Q less than A1 and P, this is greater than A1 and like A1 greater than Q because Q divides GCD of A1 comma AK.
Greater than and
So
equal to
Q
Q.
divides A1. So taking P greater than A1 square also suffices.
Basically. Yeah.
Okay.
So we get a fixed bound of what large primes we're talking about.
That is true.
No,
But
but then what does
I
this
didn't get your
relate to
argument. Can
this?
you again repeat, Rani? After that, what you do?
This just shows now that there exists some number, like on the number line, there exists some number. If this is A1 and this is AN, some number. It need not be in our sequence, but it must be of the form like Q to the something C.
Right.
Okay.
Okay.
That's what I
So
said.
Q to the power KC occurs. Okay. So what I can say, AK is such a number that it is irrelevant. What do I mean by irrelevant? That say a number AT comes later down the line, okay?
Okay.
A number A
Then
what?
AT
80, sure. After
comes down the
A
line, then GCD, like if all the other GCDs with AT is greater than 1, then GCD of AK comma AT can't be 1 just because AK, like AK is kind of a subset, like the radicals of AK is like us,
fixed.
not fixed. Like say Q to the power KC is AI, okay? So it is AI, right?
Yeah. Wait.
The rad of
What?
the rad of
What
some
is-
number divides
How
the
is
rad of the
AI
next
equal
number.
to Q to the
Forget
power
everything.
K?
I'll tell from scratch.
Okay,
We
we
know
are
Q to the power K into C occurs somewhere.
Yeah, but
Okay.
not in the sequence.
Say
We
that
don't know
is
that.
somewhere in the sequence. So
No, we
say
don't know if it exists in the
Wait.
sequence.
Why does it exist in the sequence?
or don't we know that?
We don't.
No, we know it
No.
exists as a number somewhere between A1 and A1, but not in the sequence. That we don't know.
Oh,
But
okay,
why are we
okay.
even going down
I
this
thought you
path?
proved that.
What are we trying to do?
Yeah, exactly. Like, why are we bounding one term? Why are we fixing it at
No,
one
I'll
term?
say because if we prove it is in sequence, then AK doesn't matter.
Wait,
Like
what?
AK doesn't matter means there can't come any number later.
Oh.
That's that.
Like because of AK, the number changes. Like AK doesn't influence that number in any way. Because if we have AI, whatever GCD AI has with that number, AK will have that same kind of GCD. So it can't influence that number. Like if with AI, it has a GCD is not equals to 1, then with AK also, the GCD will be not equals to 1. Like what I'm
Makes
trying to
sense.
say, GCD, I'm
I
just
see.
writing with numbers. GCD of AI, comma AT not equals to 1, AT down, like subscript, implies GCD with
AI comma AK is not equal to.
AI not equals to 1. Exactly.
Yeah,
Sure.
So this is what I mean by irrelevant. If we prove Q to the power KC is there, then AK is basically, if any large prime comes, that is irrelevant.
Wait, but Q to the power KC, but like
I
Q
don't know why
divides
it
C.
comes.
So,
I need
like,
to
this
prove.
seems much more stronger than this.
Q divides C, right?
no.
No, Q does not divide. Q can be any prime.
Q can be any
Q
prime
divides
divided
GCD
by
of
Q is
A1,
C.
a
comma AK.
prime.
It's smaller than AK. It has appeared before basically.
Oh, wait, wasn't that P? Wait, Q is different,
No.
but what is Q defined as?
No, that P is different. P hasn't appeared before. Q can have had appeared before. Arita is claiming Q has appeared before, and not only has Q appeared before, when it has appeared, then like then like AI, if it has appeared there, then AI over the P to the V, Q to the VQ of that of AI
use will you get?
is C.
Like how will it
Okay,
be
but what
helpful?
does that tell us?
We don't know.
I
That
think we
is
should be able to prove Q to the power KC comes in the sequence. I don't know
This seems
exactly
too
why.
So
random.
then you're saying that the factor of P in AK is irrelevant.
Exactly. I'm just trying to prove that large enough primes don't matter.
Like
So we
no
can
new terms
only
are
work with
coming
small
because of that
primes.
P.
Yes.
Okay.
Also, can you define what you mean by don't matter, like irrelevant ones?
I wrote this. Like for some I less than
Yeah.
K if this holds. For some
So for
I
all T, is it for all T?
no,
P greater than K.
for all T, yes.
Oh, okay.
For all T greater than K. And
I
for
see.
some I less than K, AK doesn't matter. But A not AI AK, AK AT.
For all I less than K less than P basically.
Oh, okay. Now it makes sense.
Basically, this happens when radical of AI divides radical of AK.
Yes, that is.
Basically, the primes that divides AK is like a, and the primes that divides AI is like a subset of the primes that divides AK.
Got it.
This is if and only if to that, which is stronger to the prime radical condition I told.
Wait, do you think multiples will, it's literal multiple will occur, not just rad? Or is that
I'm not sure.
unlikely?
I'm just trying to prove q to the power kc occurs. Like, I'm pretty sure some q should occur. Like,
I agree.
then we have like very strong bounds on that.
Are you trying to show P is not like P is not one of whatever in our example was 2357 for like some AKA?
I'm trying to show for large enough primes.
Like if you
P.
take 35, if you take the sequence starting in 35, then like are you trying to show that P is not any one of 2, 3, 7, or 5?
No, I am assuming P is a large enough primes. Large
that's
enough meaning
fine.
greater than A1 square in this case. If such a number comes, then that number is basically irrelevant. And irrelevant is defined by the previous notion.
Yeah. What is a cooked?
By the
So
way,
you're
like
trying
for
to show
A,
something like P exists. You're trying to show something like P exists.
Okay, wait, but
If
now,
it exists,
okay,
then it's irrelevant. I'm not trying to show
if
it
P
exists. I'm trying to.
exists and if it's irrelevant, like how does that help us
Because then
in
we don't
showing
have
the
to care
cycle?
about those. Like we will have to only look at small primes then.
Yes, like we have to look at only finitely many primes, which is like easier than looking at every prime.
I agree. Oh,
wait, hold up. Like for the AI thing, like Q can also be less than the Q can be less than the primes in A1.
Q is a prime of A1.
like
Q divides GCD of A1, AK. So Q is a prime of A1.
Yes.
Oh wait, no, I mean wait. Okay, wait. What was okay? You've changed the definition. Which was
Wait,
the definition for like the first time a prime occurs?
that is P.
Okay.
Okay, you scrap P.
I'll reload. Bhai.
No, that there is still P. P is a large enough prime where it appears for the first time. Large enough, not every prime P.
Okay.
Like in the case of 15, like when 18 2 came, but we are not counting 2 as a large enough prime, obviously. So this thing does not like work with P equals to 2, but this works with P equals to 7 or something like it.
If you think backwards, then what you're trying to show is that you're trying to show either one of two things. Wait, let me increase thickness. Yeah. Either QC divides AK. You can show that, or you can show that GCD of AK and A1. Sorry, no. AK and like QC. Q to the KC for like not K. LC for some like L large is greater than
It
100.
doesn't have to be large. L can be anything. For some L.
Okay, sure, yeah. I mean, fine. My LD is failing me. Okay. I'll be back 1 minute.
Guys, it's been pretty late for me and I have to go and have dinner. So I'll probably finish
That
this.
makes sense.
10:50 already. Do we end or something?
Yeah,
Let
I
us
guess I
wait for
have to
like
go.
11:15 at least. I think we're close. I have a vague sense of feeling that we are close.
Okay, I guess I'll have to leave now, so probably
Bye.
bye.
Okay, bye.
Yeah, it was very fun though. Good night, guys.
Bye.
Good night.
Bye.
Why can't Q to the power KC occur? Like, see, right. But yes, I think I have proved that Q to the power KC occurs.
Q to the power KC occurs.
The
Why
same
is
proof
that?
that we did, like if CP square occurs, then CP occurs. We proved it, right? The
Ah,
same proof that
Yes.
works for Q to the power KC because the GCD is like same. So with CP, the GCD is greater than 1 for everything. Then with Q to the power KC also, the GCD will be greater than 1 for everything because GCD of AT AK is like divide C
Oh, but
and
then it
GCD
will go on.
and like Q to the power KC is less than AK and the GCD works for everything. So it must occur because the GCD works. And if it is less than
Q
and the
raised to
GCD
the
works, then
power.
it must.
Wait, Q to the power KC is less than AK. What?
Yes, AK by A1 is like Q greater than Q, right? So we just said Q to the power KC is less than AK. Like Q is small,
Oh
right?
my
So
God, I was thinking it's greater. Wow.
What do we get
So
until
just
now?
I prove Q to the power KC occurs in
Oh,
the
it is,
sequence.
bro. It is the
How?
same as CP squared, bro.
How?
It's the same proof
Wait.
as CP square. Yes,
Wait, hold on. How?
I'll explain. See, AK has CP, right? And
Yeah.
so if any number AI you have GCD of AI comma AK, because AK occurs, GCD of AI comma AK, this is not equals to 1.
Okay.
So GCD of AI comma C not equals to 1 because P is
Okay.
comes for the first time implies GCD of AI comma C to the
Oh,
power.
oh,
You see?
oh, AI divide. Oh,
This is
shit. Oh,
this is like
shit.
so dumb. This is
It's
so
the
dumb.
same thing.
So
Wait,
dumb.
Aritra, this means for all L, by the way, like Q raised, like
Oh,
CQ, CQ squared, and those are, as long as
Yeah,
it's
this is for all. This is for all.
Okay.
We should like
So
just die.
I actually have stronger, like we don't need to choose Q, any Q works. So we have strong.
Exactly. Any Q dividing AI works.
We
Wait,
should just like.
so we actually prove that.
Not even dividing AI. It's just like
I
any
think
Q
the
works.
idea of
The
irrelevant
GCD,
is
that's
good.
enough.
See, the idea of irrelevant is good because AK is irrelevant. That's why it works. So I think we can extrapolate the idea of irrelevant in much bigger sense than just doing irrelevant.
Aritra, if like PC, like AK is PC, then like all the multiples of C must have had appeared, right?
That is not true. Like,
Why
I
is
don't think
so?
so.
Because like CP, because like you can perform this thing with everything, right? You can perform this logic with every. Like you
Wait,
don't
but
better to use Q to be a prime.
wait, but what is L and like what is R? What have you said?
Like anyways, C is like C and A1 have stuff in
Okay,
common.
Q doesn't need to be prime. That is also true.
Wait, can we just check it in our
What?
examples whether this is true or not?
But yes,
Oh.
I think Riddiman is
No,
actually right.
Q just needs to be co-prime to C. And
No,
P.
Q does not even need to
Q
be
doesn't
co-prime
need
to
to be
C.
co-prime
It
to
can be
C.
anything.
What?
It can be anything.
Why we are just cooking? Why कुछ भी हो रहा है?
You just need to divide GCD of A1 comma AK and that works. It doesn't need to be anything else.
Hi.
Doesn't need to be prime. It doesn't need to be co-prime.
The GCD proof anyway holds. Oh my god. We are so dumb. See, first the GCD proof was so trivial. After that, the GCD proof told us so much more.
Wait, actually, Q can be literally anything. It also does not have to divide like GCD of A1
Q
comma
can be like
AK.
any small prime. In some sense, Q can be any small prime. And like small prime compositions.
Surely
Wait,
we
so
should
like
be able to
essentially-
construct some kind of period like L.
Wait.
We can surely
Let
construct.
me now. Let us think in for like 2 minutes and think again.
No, wait. See, we are ideally we want the period to be like what? In that case, it was 30. Basically, it's the product of all those primes. Point is, we need to show that works. And now it should be like it shouldn't be hard.
Wait, can you
Now-
like repeat this part for CQ to R? What did you cook?
Oh.
देखो.
GCD of
Okay.
AI comma C is not equals to 1. Then GCD of AI comma C into Q to the power also not equals to 1.
But how do you know C for this you need CQ to the R is less than AK?
Yeah, that we
is
have
your
proved.
assuming.
That we have proved for P greater than A1 square. We have proved here.
There exists some, yeah.
Okay.
There exists some. That's why we need P to be large enough, P greater than A1 square, in some sense.
And then that P will basically.
I
So
think we
like
can do like better bounds, but we are doing P greater than A1 square, like for some reason.
wait, if that's the case, let's just
Wait,
look at all the,
Aritra. Okay, wait.
let's look
okay.
at all the primes we've had, like the examples before. Let's just look at all those primes and we'll see what if the number of primes are how many of the primes less than A1 squared come under here.
Ronit.
We don't need the A1 square bound because A1 square is like very
No, because then
like word
you know
bound. We can
why?
do much
Because
better
then
bounds.
it's trivial. You know why? Because then we're trivial. You just take all the primes less than A1 squared.
No, but you're not guaranteed that they show up like in that sequence.
Exactly. That's
So
why we
we
want
know
to see
if
how
they
many of
show
those
up,
primes are there.
they are irrelevant, but we are not guaranteeing that they show up, right? Like if it's like if they show up.
Wait, guys. I think now we are like
Yeah,
getting
like
close
for
to the structure
15,
because
for 15,
like if AK is
7
equal to
never shows up.
what?
For 15, 7 never shows up.
Wait, like why is that a contradiction?
Like you are saying everything less than AI square, something will come.
No. If it
Not
is
everything. AI square is
like
a words
multiple,
bound. Like
if CP exists, then C ke all multiples before CP will come, is what you're saying.
Correct. Yes.
So,
Yes.
so there you go. Like there you go. It's like what you said now, union of APs. There you go. You have AP of like multiples of C. So like thoda
what,
structure.
Rhythm, I didn't understand you.
Like you had like you said like while we were working out examples, we said ki this is a union of APs.
Yeah.
So if AK is equal to CP appears, then we have proved that all the multiples of C before P also appear. So like we have.
Why is that true? I don't understand.
Isn't that exactly what we did now? Like
No,
suppose
I
C.
didn't prove like all the multiples of C occurs, right?
Wait, okay. Let
Oh,
me.
no, I prove C into Q to the power R comes. That doesn't mean that all multiple. Okay, it does mean all multiple.
It does mean
I'm
now. So like
yeah.
What
I'm
do we
just
get?
you get like
little
AP,
bit dumb.
you get your AP. So like it's just
Wait, what AP? Wait, hold on.
देखो like perform the same. It's the same thing now. If CP AK is equal to CP appears, that P comes from the first time, then all the multiples of C before CP will also have occurred before CP and after A1 will also appear in the sequence. Is what I'm saying.
Oh wait, then you're done, huh?
No, we are.
So it's
It's not
basically
like
a bunch of APs combined together. We got that right. But
Oh, we
finite
got,
bunch of
but
APs.
they're not infinite yet. We don't have that. Okay.
No, it's not infinite because like we know P is like we have a
P is
bound on P.
prime.
P is greater than A1
Correct.
square. So we have a
Yes.
like good bound for Q. And because we have a good bound for Q, then like it's
Surely then
we have a finite amount of APs clubbed together basically.
then just take
have you got
any subset of primes less than
I think
A1
it's just
square.
trivial from now on if it's like finite APs clubbed together.
exactly. That AP slapped together. Yeah,
Clapped.
it's okay. Both work.
Slap is better.
Yeah,
Just
slap is
objectively better. Okay. Like surely this is trivial. We need to like construct L-lines.
Wait, can somebody tell me what you want to prove right now?
That finite APs clubbed together follows this property.
Yes.
Basically.
Like
It's not a good
basically, wait. Let me
description.
just give her a like the overview. So we showed that observe that if AK is equal to CP is in the sequence where P is a prime which appears for the first time in AK in
Yeah.
the sequence, then we have proven that all the multiples of C must have appeared before AK. Like exactly the same logic works. So like we get our like AP of C's. So it basically wait, Aditra, after that, how do we show ki all the multiples of C appear? Like we should be able to, right? We have shown that all the multiples of C before CP appear. We want to
Oh
show
yeah,
that.
that is the part.
Ah.
It should not be hard to.
Yeah, it should
But
follow
see,
simple.
because P shows up, right? P
Yeah.
shows up, then like CP plus. Okay, no.
No, it's like C into P plus 1.
C
Like
into
not
P plus
C,
1. So okay, P
P
plus 1
plus
has
1 into
factors which you already have from before.
Yeah, P plus 1 has factors which already have before. So like CP plus C into P plus 1 also must occur because like the GCD we know because
Oh
it has
yes.
from previously. C has the GCD from before. And P is like the first prime. We do
Then
inductive
ideally we're
hypothesis
done,
that
yeah?
P is the first large prime that comes. We do the inductive hypothesis. P is the first large prime that it comes.
Wait, Aritra, again.
See. Wait. Let me see if I got it right. So
Yes.
you have AK and like that is C times P, okay? And like basically we want to show that it's C times P plus 1 also exists, yeah?
Yeah,
T times P plus 1 also
Okay.
exists.
Yes, in the later in the sequence, yeah.
And P plus 1, okay, since P plus 1 and P are co-prime, P plus 1s, all of its prime factors have come before.
Correct,
Yeah.
P plus 1.
All of P plus 1's prime factors have come in the prime factorization of other AIs before.
Why
But
is that
p
true?
plus 2
No,
can be,
no.
but for p plus 2, p plus 2 can be a prime itself, right? So,
No, we're doing P
so
plus
then we
1.
apply the same logic again.
Wait,
Oh no, but it might
Sure,
not
yeah.
come.
P plus one.
Yeah.
Okay, no, we are wrong. We are not. We are wrong.
No, why can't? Take P
Wait,
plus 2 D
wait.
prime and finish.
P
Ronit,
plus 1
Ronit,
comes,
Ronit.
but how do you know C into P plus 2 comes? Because P plus 2 can be prime of its own, right? P plus 2 is a prime. So none of its prime
Sure,
factor has
then
to come again.
oh, but P is the first prime that exists. Okay.
Yeah. I think there is something other than that. We can do it. We can do it.
Wait,
Yes.
Ronit. Tell me C into P plus one. How?
Huh, so feel like, okay, so since you have the others, you have like other AIs, where basically AI is equal to C times some prime factor, some factors, the factors which divide P plus 1, yes?
Shaka, wait, what? Why is that? Why is AI divisible by C? AI is like, it has some
No,
common
AI is
kind
not
of.
divisible by C.
So
C is
then
divisible by AI.
C is divisible by AI. That is also false. Like, they just share
Wait,
rad
someone
as
wrote in the chat, no, but C handles all AI ka GCD. So why P plus 1?
No, but
Then
then
C,
uske baad
C
there'll be
handles
some
all
new
AI
terms, right?
GCD. It
There'll be
doesn't,
some new
right?
terms which may not
There
be
will be
handled
new
by C.
terms.
Yeah.
Yeah.
Oh, Krishif had joined some time ago. Lamo. Keep up the good work. Yeah, bro, we are coping on P6. Yeah.
No, it isn't coping. We like took 1 hour, 3 minutes till now. It's good for
Yeah, true, true,
P6
true, true.
with 5 people
Yeah.
without writer.
With 5 people is insane. Wait, let me reload to see how many likes this feels so dumb. Bro, it is still exactly what it was. Oh, it went up. It's like 49 or something.
How do people do 31x? Like, are we even that famous?
We are just random people.
I mean, Aram is right.
What?
Aram, like, get everyone at MBL to like do
Oh,
this.
yeah. Wait, yeah, around.
No.
Get all of your MBL friends.
Aditya is famous.
That is random.
I
But
agree, Aritra is also famous. Like, Aritra is the
what is the
only.
proof C into P plus 2 comes?
Ah,
Like, I think if we
Aritra, can
APs
you
are not
prove?
hard.
Can you
If we
explain C
prove
into
this,
P
we'll
plus
be done.
one?
APs will part will not be hard.
Wait, can you explain C into P plus one?
See, all the prime factors of P plus 1 has come before.
Why is that true? Like,
Because we, by inductive hypothesis, we let P is the first large prime which does not appear.
Oh, I see.
oh,
So
So
like,
the other primes
is
aren't.
this P? Oh, acha, okay. Sure. Then sure.
But P plus 2 might be a prime itself, so you don't know.
Sure. P plus 2 might be a prime itself. I agree. So it may not.
Do we want P plus 2 though?
Like if we need AP, we have to prove P plus 2 somehow.
Sure,
Wait,
we need
even
AP.
after this, C into P plus 1 is not justified. Like,
I'm pretty sure we can get a better period. Like, why C or
But
why
wait,
P's?
see, I have a good thing. Ridhiman.
oh,
हाँ भाई, only
Now
reason.
P divides AK, right?
P divides
Okay,
AK,
no.
yeah. CP, sure.
Okay, no, it is irrelevant. We proved it, it's irrelevant. No, doesn't matter. So we don't need to think about P because it's irrelevant.
Exactly. Like, why we can surely get better periods than C. Like, why can't we do our periods from before? Like, A equals 15, A15, we had mod 30. Surely we have better stuff for periods.
We can't cope on this like right now.
Surely
It's
not, bro.
I'm still a bit confused, like, what are we doing? But okay, it's fine.
we are trying to prove the AP with C occurs basically, like CP, CP plus 1, CP
But
plus
why
2.
is C so special? Like
Why?
what?
Yeah,
Because
exactly. I don't like C.
Not C, like it is for any C, like not this C, like some bunch of APs. So we want to show like this bunch of APs come together for any such C, not only this C.
I mean, that's the point, now. I mean, showing it's for random.
Like C is made with like low primes, right? So there are only finitely many Cs. So if we show it is for finitely many things, because there are only finitely many Cs.
You only need one C to prove AB.
Yes. If we
Point
prove
is
one thing,
that
we'll get. If we prove this, we'll be done. That's why, like, we're trying to prove this.
yeah,
But the point is, if you take C, it will be C R, where R is like any prime. Showing it for all primes will be extremely hard.
I
We've
think we
already
will have to
deemed them
use some.
irrelevant.
I think we have to do some size bounding thing like prime नहीं देखना है हमें. Like we have to just assume कि suppose CK तक everything has appeared. So CK plus 1 has to appear
I
irrespective
still
of whether
don't know what like the relevant primes are. Like what are we? Which primes are
Can
we?
you like, get
Relevant
us to know
primes
what
are
we are
like
doing?
less than, there are very small relevant primes, but we bounded it to A1 square. But it is
They're all
surely not
less
till
than
A1
A1
square.
square.
It's less than A1 square. Like we have a bound on that, but we don't have an exact count, which are the relevant primes. Or
But does it
we don't
matter
need an
if we
exact
like
count.
don't know which ones they are, or does it not
Yeah,
matter?
and at least we have
No, no,
finitely
no,
many.
it
It
doesn't
doesn't matter
matter.
which ones we.
It doesn't matter.
Oh, it
Anu,
doesn't
you're
matter.
right. It doesn't matter. Why should it
It just
matter?
matters that we need to have finitely
Finitely.
many. It doesn't
Okay.
matter which
Yeah.
ones we have.
Exactly. Then just take some and do something.
Yeah, but like we still have to prove this AP. That's why we're stuck. Like if
Hmm.
we do this one thing will be done.
wait, okay, can anybody properly explain the argument for CP plus 1? So I can try to like.
That doesn't work. The CP plus 1 argument is based on that P plus 1 as prime factors, which will not work. That argument will not work. Or you can't extend that.
I see. Surely there's something else we can do.
It only depends upon the small primes we have. Like
Yeah.
Wait, look, like the problem is defined backwards, but we can also look forwards, right? Like
Yeah. Fine.
M is part of the sequence only, like some number J is part of the sequence only if GCD of AJ, AI greater than 1 for all I in N.
Look at the small prime.
Can we like use this? I don't know. Hmm.
I think we have used it before,
Okay.
but like we still might need to use it. But
We can
there
probably
is
still.
something we are missing.
Wait, like, what is the issue?
That CP
Issue?
plus 1, CP plus 2 occur. But doesn't it occur? Can we prove that, like, even if it doesn't occur, like, probably the thing is it actually doesn't occur.
See, but
Like
if it
CP
doesn't,
plus 1 might occur, but like CP plus 2 doesn't occur, but like some other bunch of APs occur. Like this is not the if and only if case of our problem statement being true. So I think the thing we're trying to prove is
Is
not
that
true right
false?
now.
Can
I
we
think
just
it
look
is
at the
false.
cases that we have tried?
I mean, like I'm still
I
confident
think
on
it
the
will
idea
be
that
hard to look
mod
at the
30s
cases we
work.
have tried because of P and C.
I am
We
still
just have to go
confident.
with
I'm still confident of the idea that it's like mod 30 stuff. Mod like the product of the small primes.
No,
yeah,
ultimately.
that is true. That has to be true.
But like,
Like
But what I'm
we
saying is C into P plus.
for the case where even equal to 15, look at 42. 42 is 6 into 7. 7 is the new prime. So 7 is like P and 6 is like C. So like all the multiples of 6 from 15 onwards should appear and have appeared. And uske baad also they
Yeah,
are
it
appearing.
has occurred, but doesn't mean it have to occur in like every sequence.
I mean, like if
Probably
you
this
extend, I think it is
probably like the radical occurs or something occurs like I don't know, like we don't need this thing exactly to prove it. Like we can have some weaker thing and then also will be done. We don't need this strong
हाँ
version.
तो weaker चीज भी क्या है? Fine.
Like
You
we
want
can
really
have
weak?
any AP, not with the AP.
Fine. You want weak? Then let's just take any set of the primes, and then you take.
like here, dekho, like observe everything has a 2 or a 3. Like everything has a 2 or a 3.
Oh, another thing is that means see say a number comes, the number must have this
Arey, we are coping.
this
We are
fall.
coping hard,
Oh,
bro. Oh my god.
what?
Bhai, we are
I
coping
think
hard.
that
What?
So hard, bro. Everything is something common with A1, and then A1 like A1 has C.
It's all the primes that divide any natural. Oh, it's all the primes which is
Dekho,
smaller
dekho,
than
dekho.
A1
I
square,
am
which
dekho. I
divide a
am
number.
wait, Ridhima, what are you saying?
dekho. Firstly, observe that like all of the terms have something in common with A1. So
Yes.
so if we take C as like rad A1, then like the entire AP will appear. So we have that.
What?
What is rad?
Like radical of A1.
What is radical of A1?
Basically, the
Basic.
product of prime factors. Like you don't take the
Like
powers, you only take the primes.
like rad of A1 appears in the entire C, like as the AP. Like that appears as the AP. We have that.
What if that's there? We're done.
Yeah, that is true, but that is not done. But I have a better thing.
oh wait, no, wait, Ridhiman's right, I think.
No, that appears, but doesn't mean that we are done. Like any AP doesn't. Everything has to be AP. That doesn't prove. That only proves that rad
No,
of A
like, wait,
comes.
what Ridhiman is saying is take P equals product,
Yeah.
P is less than AI square,
Like all the small primes, just write it.
All the small
product.
primes. All the small primes.
P. And now he's saying, suppose GCD of some like n comma P is greater than 1, then n appears. Is that what
Then
you
like okay, then just take the union of the sets such that like primes in P. So like primes in P
Oh, what I was
such
saying
that
like the kind of this
P
thing.
divides
Like
A.
basically mod P, mod capital P, it is
For
fixed because if A comes, then like A plus P also comes, A plus capital P.
Yeah, exactly. That is what I'm saying.
then just take this thing now.
Because the GCD is equal. So, and with the small primes and the like larger primes are irrelevant, so don't care about. And the small primes, they all the small primes are in the capital mod P. So their GCD is same. So
Wait. Look
anything
at
we
this.
can work out.
Look at this. It's just like then just look at this set now. All the small primes that P divides A for all naturals A. Then like the set of ANs should surely be a subset of this.
Basically, it is defined something by like AI mod P, and like it will
But
repeat at AI mod
Why do I
P.
feel like we're
Paritaka, my
overcomplicating
conjecture,
this?
just a second. My conjecture is that whenever a new multiple of whenever a new prime occurs in one of the terms, then the remaining thing has to be divisible by capital P. That is what I think.
But we don't need that strong arguments. Like even if we don't have that, that doesn't make a difference. We don't need
Is
that
there a
strong
way we
thing.
can
We
classify
can
the ANs?
we can do
Is there a
much
way
weaker
can
stuff and be happy.
I think I might go now. Like my mom is
But
calling
what
for
I'm
dinner.
saying is we can take the set of small primes, like each subset, okay?
Hmm. That
Right?
won't appear at AP because like some might not.
Yeah, I know. So I'm saying is there will be some fixed subset which will appear a repeated number of times. Like if some subset doesn't occur, that will not occur anytime. And if some subset occurs, which then it will occur a lot, like every time with capital modulo P. Just because all the prime factors are
Can
same,
someone
so it
define
will be
the
a.
set of all these small primes first?
P is less than A1 square.
P is the sum of all primes, no? No, P is the set of all primes. Small primes. So you're saying P is product of all elements of S, yeah?
Uh, sure. Yeah.
Yeah.
Yeah, see, all these subsets are there, right? So a number occurs. If the small prime is dividing it,
What if we look at the small primes
is there.
dividing? What if we look at the small primes? So like P in S such that P divides AN for all N. Yeah, for all N. I call this T. Surely this is the set we care about. Right?
Guys, I'll leave now. Like my mom is calling for dinner. Like closing ceremony already started. I don't want to miss that.
Opening ceremony.
Closing ceremony.
Close. It's fine. Bye.
Uh,
Bye.
bye.
Bye, Rahman.